and aviation. His research has been supported by prestigious agencies including AICTE and ISRO, and he has worked on advanced control design strategies for MIMO systems and systems with structured uncertainty at Vikram Sarabhai Space Center. Dr. Abram has been recognized with multiple awards including Young Scientist Award, the ISTE Syed Sajid Ali National Award for Renewable Energy Research, and Professor VMK John Award for Best Engineering College Teacher in Kerala. He brings with him teaching enrichment portfolio with having taught wide range for postgraduate and undergraduate courses. We look forward to gain insightful and vast experience both in research and education. Thank you.
Oh, so normally in space, we know that active satellites will go around the Earth repeatedly, right? It will follow a path which is called a closed curve, and that closed curve is called orbit. You can see, okay? And orbits are of different kinds. There may be circular orbits, there may be polar orbits. We will come to that later, right? So you see, due to the velocity provided by the launch vehicle, a satellite should travel in a straight line. If there are no force acting on it, right, then why it is being bent? Because of the gravitational force on the Earth. Okay, that will bend the path of the satellite towards the Earth, and that results in a curved path. So depending on the velocity and altitude, the curve can be a circle or an ellipse or a hyperbola. So once the satellite starts orbiting, you can say along the orbit, there's no need to spend any fuel to make it move, because that there's no air friction. That's what I told you, right? In space, there's no appreciable air drag or air friction. So in other words, the satellite, you can say it's in a state of continuous fall. Okay? There are many things to be explained, but due to paucity of time, I will just rush up to the slides. Okay? Now, what's a rocket? A rocket is an equipment that a vehicle that we use to send satellites to the outer space. Hello? Can you make it full slide? It's not in full slide mode? No, sir. Okay, I am already sharing it. I don't know. Wait, let me share once again. How is it now appearing?
Just press F5.
F5. Okay. Yeah. Is it okay now?
No.
In my screen, it is in full screen only. I cannot see anything else other than my slide.
Okay, then. Okay.
Okay. So rockets are incredible machines that allow us to travel beyond Earth. Okay. So if you want to fly out of the Earth's atmosphere and go up into space, we need to use rockets. So building rockets in most cases involve pushing the limits of technology. That is why when there is something difficult, we say, oh, it is a rocket science kind of thing. Okay. So we need extreme precision, extreme engineering actually to assemble a rocket assembly. So you see, it basically expels hot gas at very high velocity, and then that will automatically get pushed to go in the forward direction because of the reaction force, as per Newton's third law of motion. Now, if you consider rockets and airplanes, what are the basic differences? Any idea? Airplane has to carry its own fuel alone, whereas rocket has to carry not only the fuel but also the oxidizer. In most cases, it is oxygen. Okay. So if you compare the speed, a rocket will travel at the rate of 100 kilometers per hour, whereas airplane can travel at a rate of 800 kilometers per hour. So that's the speed difference also. Okay. So 30 to 40 times faster than aircraft, it can move. The rocket can move, right? But the only disadvantage is that it has to carry its own oxidizer along with the fuel. So which means rocket becomes bit heavier aspect. Now this slide, let me okay, because of paucity of time. So what was the first artificial satellite which was man-made? That is called Sputnik 1. Okay, that was launched on October 4, 1957 by USSR. The then USSR. Okay.
So your screen is not moving.
My screen is moving here, so I don't know what's the issue. I don't know what is to be done. Here I am seeing my moving screen only, nothing else I am seeing.
And we are able to see basics of rocket flight.
No, I have moved actually.
No, sir.
Now what are you saying?
Indian space
Now you are seeing, right? Oh, okay, fine. So let me put in this way. I think then this is moving, I think, right? So can you identify who is this person? This is Vikram Sarabhai. He is considered to be the father of our Indian space program. He is considered to be the father of Indian space program. So you can see that our space program had very humble beginning. Okay, you can see the parts of rocket being carried on side bicycle and bullock carts. Okay, so it had a very humble and modest beginning basically. Right. So these are few older days, beginning days slides. You can see how people are assembling things together, how they are being carried to the launch site. This church is right now a space museum. Okay, so this houses all the all the previous days data and belongings like rocket parts, models, etc., etc. So if you are visiting Trivandrum, you can visit this space museum as well. There. This is the sounding rocket. Okay, that happens every month from Trivandrum. So this is the night Apache launch in 1963 from Tumba. Okay, Tumba is in Trivandrum. So again, why Tumba was chosen for being the space program? Any idea? Why Tumba was chosen? Because Tumba is closer to the equator. Okay, that is the reason, right? It is the Indian space spot operated by ISRO. Okay, and it is near to the southern tip of mainland, which is close to the Earth's magnetic equator. That's the reason. And what do you mean by magnetic equator? That's the imaginary line around the planet that connects all the points where a magnetic needle, when freely suspended, is horizontal. That's the significance. Okay, that is why this site was chosen for the space program initiation. Coming to launch vehicles, there are multiple elements in a modern rocket system, right? What are they? Like the structure of the system, structural system, the avionics, which acts as the brain. Then we have the control, okay, to control and guide the launch vehicle in the proper direction. Then payload. Payload is the pass of the satellite. We want to insert satellite in a correct orbit. So that sits at the top, right? Then there are navigation guidance, which acts as the eyes of the system. Then we have telemetry system, okay, and then there is a propulsion, which acts as a foot for the launch vehicle. There are mainly two kinds of propulsion system. One is liquid propellant and one is solid propellant. So based on our requirement, we make use of sometimes solid, sometimes liquid, and sometimes a mixed propellant as well, semi-cryogenic, etc. Then this slide shows different aspects in the making of the rockets. Okay, so various processes involved, such as motor casting, mixing the propellant, engine generation, etc. Now, this slide gives an expert view of the vehicle, right? You can see initially there are liquid strap-ons, solid motors are there. There are interstages. Okay, cryo stages here. This is called the payload fairing equipment bay upon which these things are placed. So satellite will be normally enclosed in a payload fairing. So that will take care of our satellite because it is passing through high temperatures and all, right? So satellite has to be protected. So that will be enclosed within the payload fairing system. Then different staging of vehicles has been shown here. So you can see that DSLV Mark III, its first stage consists of a rocket motor, right? This is the first stage. And the second stage in DSLV Mark II, it also uses Earth-storable liquid propellant. And the third stage makes use of cryogenic propellant. Coming to PSLV integration. So the PSLV integration different stages are shown here. So from about T-2, T means that the instant at which it is launched. About 2 months prior, it will be starting. It will go through different phases like this, and finally it gets launched. So it starts from preparation starts well from months to days to minutes to seconds and so on. How do we track the launch vehicle? There are mainly two methods. First one is, give me a moment. Now, we track the launch vehicles by two modes. First one is called skin mode. What do you mean by skin mode? In skin mode, we use radar, okay, to track the vehicle. And then the second one is called the transponder mode, where we use antenna to communicate the exact location of the launch vehicle. Okay. Now coming to the spaceport. So it is better to launch rockets close to the equator because the Earth rotates at a greater speed, okay, than at poles. So this extra speed at the equator means a rocket need less thrust away, right, and hence less fuel. Keep in mind, carrying per kg of fuel to the per kg of weight to space is very costly. Okay, so our aim is to have cheaper launches. So since it is near to the equator, we need to carry less fuel away. Okay, because we will get more thrust because of this advantage being close to the equator. That is why we had our launch launch port at Sriharikota. Okay. So these are the different launch pad and allied services. If you visit Sriharikota, you will see all these facilities. This is the VAB, the Vehicle Assembly Building, the second launch pad, the first launch pad, the launch control center, and so on. Just a view. These are the different ISRO's launch vehicles. Okay. So we have launch vehicle SLV-3, Orbital Satellite Launch Vehicle, PSLV, Polar Satellite Launch Vehicle, GSLV, LVM-3, and SSLV. Okay, so here you can see the different aspects have been mentioned: the height, the lift-off weight, propulsion used, etc., etc. Right? So you can see that our LVM-3 has a lift-off weight of 640 tons. Okay, which is the maximum to it. How big are they really? So this here is a 12-story building. Just for a comparison, you can see how big they are and how much weight they carry. Okay. 1 ton. So we can see how much ton it is. Okay, how does it weigh? Coming to satellites and applications. What's a satellite? What's a satellite? It is any object that orbits around a planet. Okay, so what is the natural satellite of Earth? that is the moon. Okay, all other man-made satellites are artificial satellites. Okay, so they revolve around a planet or a star. So natural satellites of a star are called planets, and the planets' natural satellites are called moons. So the Earth is a planet in the solar system because Earth rotates around the sun. Okay, and moon is Earth's natural satellite. Okay, so everything else is artificial satellites or man-made satellites. Now it has to move around an orbit. So what's an orbit? It's a regular repeating path that takes around another. Okay, so this is one possible orbit. Right, this is not the only orbit. Different orbits are possible based on the height, based upon the shape of the orbit and inclination. Okay, like polar orbits, equatorial orbits, inclined orbits, etc. So equatorial orbit means the angle of inclination is 0 degree. It is parallel to the equator, closer to 0 degree. Right? If it moves like this, it's an equatorial orbit. Whereas if it moves from pole to pole, then that is called a polar orbit. Okay, and what will be the angle of inclination? It will be close to 90 degree, as you can see here. And all other orbits are inclined orbits because it makes some angle with the equatorial plane. Okay, along the equator, angle is 0 degree. Perpendicular to equator, it is 90 degree. So anything in between forms an inclined orbit. Okay, so inclination is the angle between the plane of the orbit and the equatorial plane. Okay. Now, these are not the only orbits. There are some special orbits. What are they? First one is Sun-synchronous orbit. So here, it means that it is a nearly polar orbit and it passes through any given point at the same mean solar time. Okay. And then there are geosynchronous and geostationary. What is geostationary orbit? Geostationary means the satellite appears to be stationary with respect to Earth. That means it is at a height of about 34,000 kilometers. Okay. So an observer from Earth will see that satellite to be stationary, even though it is rotating. Right? So it is kept at a height of 34,000, close to 34,000 kilometers away from the Earth. And then there are special orbits called Molniya orbits. Right? So that is a type of orbit to provide some communications and remote sensing coverage or high latitudes. Mostly USSR people used to send their satellites into these kind of orbits. And we are not straight away going to the orbit in one shot. Right? There are transfer orbits. Right? What are transfer orbits? They are special kind of orbits used to get from one orbit to another. So that means when satellites are launched from Earth and carried to space with launch vehicle, they are not put directly into that final path. They will just first they will be taken into a transfer orbit, right? Then by using relativity energy, they can move from to that final orbit path. That's where the in-between orbits, they are called orbit transfer orbit. Now, what are the major elements in a satellite? So similar to launch vehicle, we have power systems because it has to get power, it has to be powered while it can operate. Then there should be communication systems, including antenna, transponder, right? Then there should be active and orbit control system, correction systems. It should be propelled. So we have propulsion techniques. Then there's a payload, different experimental payloads are there. Okay. Then there should be avionics. What do you mean by avionics? Aviation electronics. Okay, electronic systems are there, packages are there. Okay, for its proper functioning. Then it has to be structured. Right. So we have a structures also associated with the satellite. So this slide shows different satellite testing and qualification process that is happening in our ISRO. Then coming to Indian satellites, what was the first Indian satellite built? Any idea? That was the Aryabhatta. Okay, Aryabhatta was the first unmanned Earth satellite built by India. Right? So it was established for performing experiments in X-ray, astrology, agronomy, solar physics, etc. Bhaskara 1 and 2 were satellites built by the ISRO that formed India's first low Earth orbit, LEO, low Earth orbit Earth observation satellite. They collected data on telemetry, oceanography, hydrology, etc. The Doherty series consisted of 4 satellites. It was launched in 1980, and that was the first India's satellite launch from Indian-made launch vehicle. Okay, so we launched Doherty on our first Indian-made launch vehicle. So these are Chandrayaan 1, Chandrayaan 3, okay, Mars orbital mission, Aditya L1, which we launched some 2 years before. Okay, just a view. Why do we need satellites? What's the purpose of satellite? Are our nuts loose? No. There are multiple applications like remote sensing. Okay, suppose you want to say scan an area of Earth. right? So from the space, you can definitely have a remote sensing capability, and you can take pictures and analyze what is happening. Then it is also used for satellite communications, right? The present day internet, telephone, everything is happening through space communication channels as well. Then you are making use of Google Maps that is used for navigation, right? We have our own navigation system. What is that called? That is called Navic. Okay, India's own navigation system, similar to GPS by USA. We have Navic satellite constellation. Then there are scientific missions, okay, and futuristic applications. Now we are planning to have our own Antarctic station, right? So for futuristic application also we need satellites. Now, coming to remote sensing. As I said before, remote sensing is the process of collecting information about an object without being in direct contact. So being in space, you can scan a particular area and get the relevant data from for that particular area. So payloads are cameras operating in different spectrums. How photographs are taken in different spectrums to extract features of interest. Okay. So mostly it will be deployed in LEO, low Earth orbits. Now coming to remote sensing applications, meteorology, okay, weather forecasting, disaster warning, climate change studies, ocean studies, atmospheric studies, agriculture, for agriculture purpose also it is used to determine how much is the vegetation cover, crop inventory, etc. Then mapping, so that helps administrators to have proper mapping of roads and highways, planning, land survey, water resources, fishing zones, etc. Then also it is used for border security, military intelligence, and so on. So this shows, based on the sensors that we use in the satellites, a different view of Earth is obtained. With this data process, we can study different aspects like the water cycles to different patterns of gases distributed around the Earth. Okay, so you can see, based on the different types of sensors, we will get different kinds of pictures. Panoramic camera will give you these kind of images. If you are going for hyperspectral camera, we will get these corresponding images. And multispectral camera gives these kind of images, from which we can have different observations. Then, it is also used for disaster warning. You might remember, in 2020, a cyclone called Asan. Okay, so so because of disaster warning, several lives could be saved. Okay, it's being used by IMD, Indian Meteorological Department. Then, post-disaster management also it can be used. This data can be used for post-disaster management. Say for example, like after landslide, okay, what rescue operations you need to take, right? So identification of disaster affected area, mapping of roads for access to disaster affected area, etc., etc. Then flood mapping also we can use. In Kerala we made use of this thing during the floods in 2018, right? Then we can also have the potential fishing zones. We can guide the fishermen that saying that in this particular area there is a possibility of catching a good catch of fishes. So in that way, we can help the fishermen also in leading them to potential fishing zones. So these are different IRs, Indian Remote Sensing Satellite Series. So remote sensing means, as I told you before, of information about an object without direct physical contact. Okay. So they can be divided into mainly two types. One is passive remote sensing and second one is active remote sensing. Passive remote sensing gathers radiation that is emitted or reflected by the object or surrounding areas, whereas active collection emits energy in order to scan the objects. Right? It will release energy to scan the objects and areas, whereupon a sensor then detects and measures the radiation. Okay. So radar and LiDAR are examples of active remote sensing techniques, where the time delay between the emission and return is measured, establishing the location, speed and direction. Communication satellites. So this helps us to connect with the world. Okay. Why do we need them? As I said before, they help us to keep in touch with the outside world. Right. They provide service like relaying telephone calls over long distances. Right. You can see when you are doing a direct phone to phone, it is limited. But since Earth is curved, if you have a communication satellite, we can have communication with any part of the world. Right. Which orbit? Normally it is used in the geostationary orbit. Right. So satellites used are Apple, which is India's first communication satellite. We also have INSAT series and GSAT series of satellites. So from the base station, the signal is uplink to the satellite, and then it is downlink to the second station. and so communication happens between different parts of the world. Where do we use communication satellites? We use it for telecommunications or tele-education, right? A person sitting in one, say, maybe in Pondicherry can teach a student sitting somewhere in Delhi or Kanpur or UP, something like that. Similarly, a doctor somewhere sitting in Delhi can analyze a patient data and diagnose for someone sitting in maybe in a remote village. Then for internet services, for satellite internet, etc., we use communication satellites. So telemedicine, as I said before, is a virtual doctor, right? It started in 2001. It utilizes satellite links to provide medical diagnosis and consultation by specialist doctors to patients located in remote areas and remote and rural areas. So you can see a few snapshots from here, from the telemedicine that's happened in the past. Okay. So you see a doctor in Jigma, Chandigarh is analyzing a patient sitting in Jammu and Kashmir, right? So that is facilitated by satellites. The tele-education, as I said before, a teacher somewhere sitting in a metro city can teach thousands of students in rural areas, right? So presently it covers 26 states and 3 union territories. Okay. Then coming to Indian communication satellites, ISRO has launched communication satellites in multiple series called INSAT, right? The Indian National Satellite System, INSAT. It's a series of multi-purpose geostationary satellites launched to satisfy the telecommunications, broadcasting, meteorology, etc. Then we have GSAT. They are India's indigenously developed communication satellites used for detailed audio data and video broadcasting. Then we have EduSat, GSAT-3, also called EduSat. Right? Then there are satellite called Kalpana-1, which was the first dedicated meteorological satellite. Then it's also used for navigation. What is navigation? Navigation means where we need to be guided to our destination. Okay, we have a destination, we need to be guided, right? So in these days, people are making use of Google Maps, same ideology, right? Navigation means finding a position, velocity in 3 dimensions, in 3D, at a time with a specific reference coordinate system. How does it work? It is based on what is called 3D triangulation method, right? So that will be minimum 3 satellites, so you can find the common point, right? So that will give you more precise location. More the number of satellites, more accurate. Minimum number of satellites needed is 3. Okay, so with these 3, we can have our precise position. And we have different types of satellite navigation systems. The global satellite systems are GPS, which is an American one, as I said before. Then the Russian navigation constellation is called GLONASS. And the European navigation constellation is called Galileo. Galileo is the Chinese constellation. We have our constellation that is called NAVIC. And the capability has been augmented, and that is called Gagan. Okay. So it is also used for satellite systems can be also used for surveying and other applications, right? Remote areas or for planning and so on, right? To detect and distinguish resources that are used in surveying and mining. It is also used for military operations, as I said before. NAVIC means navigation through Indian constellation. Okay? The IRNSS, Indian Regional Navigation System, is an independent satellite system for positioning and used for national applications. So there are right now 7 satellites, 3 in the geostationary orbit, 4 in inland geosynchronous orbit. Okay? So ground segment comprises of the radar, and we are the user segments actually. When we are traveling from one point to another point, we can make use of NAVIC system. Coming to Indian navigation satellites. So this slide gives some snapshots about different Indian IRNSs that we have flown before. IRNS 1A, IRNS 1B, and so on. Bhuvan is an Indian web-based utility. You can also search internet and find the Bhuvan portal. Okay, it's an Indian web-based utility which allows users to explore a set of geographic content prepared by ISRO. Right? If you have ever explored this thing, if not, you should try. Okay. What are the basic features of Bhuvan? It visualizes 2D and 3D along with information on soil, wasteland, water resources, etc. Right? Then it will give you measurement tools. Horizon is horizontal distance, aerial distance, vertical distance, etc. The different contour maps, displays a colorized terrain map and contour lines. Okay? So if you have not seen this thing, I urge you to visit the Bhuvan portal and see explore what are different options available there. Now coming to satellites, this shows a brief timeline of the satellite evolution, starting with the small globe-like Sputnik. It evolved into advanced and multi-ton satellite systems. Okay, presently we are in the era of miniaturization of satellites with an increased number of CubeSats. Okay, this is a very small series of satellites that is called CubeSats. Then we have satellite constellation. We have the problem is that now almost everyone is interested in satellites. Okay, you might have heard of Elon Musk launching his I forgot its name. His satellite constellation, right? The thing is that more and more satellites are being entering into are rotating around. The issue is that once the lifetime is over, it becomes deadly. It becomes useless. Okay, so then how to eliminate the space debris? That is a major issue, right? So there are multiple debris of different shapes, different weights, different sizes. So each of these is harmful for active satellites and active launch vehicles because keep in mind they are going at very high speeds. So when they hit on ISS or a satellite, it becomes problematic for a satellite. Okay, its lifetime will be coming down. There will be technical issues. So space debris is a big issue which we need to undertake. Can you imagine a world without satellites? That's not possible. Okay, everything will come to a standstill. It has become like our electricity. We cannot live comfortably without electricity. Okay. So these are the different kinds of crewed spacecrafts. Right. Voshko, this was by USSR. Then Mercury was there. Gemini, Apollo, Space Shuttle, Soyuz, Shenzhou, Dragon. These are the present spacecraft upon which, if you remember, our Subanshu had gone on an Axiom mission, making use of a Dragon spacecraft, right? This is the Starliner, this is Orion. Okay, just a few spacecraft that was there. And major milestones, as you know, the Neil Armstrong landed on the moon. The first Indian in space was Colonel Rajesh Sharma, and this was the first reusable launch vehicle, space shuttle. And then recently we had our Subhashu Shukla going to Indian International Space Station. These are recent major milestones. Coming to Indian Human Space Program or the Gaganyaan mission, you all know there was 4 astronauts were chosen, and out of the 4, we come at Subhashu Shukla went to ISS very recently, right, and came back after about 2 weeks of experimentation and successful stay at International Space Station. Then what's the Gaganyaan objective? The prime aim is to implement a sustained and affordable human and robotic program to explore the solar system and beyond. And because we are planning to have a Bharathiya Antariksh station, right? So these are all precursor to that objective, ultimate objective. So we will be having a geometry half humanoid on the Gaganyaan mission, right? Then key related technologies that have to be developed as crew escape system, recovery logistics, crew safety of the launch pad, mission control, recovery system, deep space network we have to build. Okay, so testing is going on in all these areas, and we have completed almost about 70 to 80% of this thing is over actually. Now, because human is being carried, we have to be very careful about all these things. We cannot take any risk. Okay. Now, hello. Okay. Then coming to International Space Station, right? This is the world's first. So the world's first space station was called Salyut 1, and that was launched by USSR. Okay. So here, this was launched by a collaboration of many European countries. So it has been in operation for quite a few years, and it is proposed that it will be coming down maybe in another 2027, I think. 2027, they are planning to decommission it. Okay. So this slide shows what are the structure of ISS in a glimpse. Now, these are the other space labs. Okay, Mir, it was already decommissioned after the lifetime. Mir was there, Skylab was there, Salyut was there, which I had mentioned. Okay, this was decommissioned before. Right now, we have the Chinese space station Tiangong and the ISS, the International Space Station. Now, why do we need these things? These are different kinds of science in space. Okay, microgravity experiments. See, on Earth you can see this flame looks like this, candy flame, but in microgravity or in space it looks like this. Okay, so this shows the refuse gone in space in the ISS and the water level, how it appears in space. So different kinds of technology involved are shown here. The lithium cartridge, etc. The regenerative ECLSS, and these are some spin-offs actually. So the cold weather wearables, actually these are all spin-offs because of the technology involved actually. So scratches and glass we have developed. Miniature image specific digital camera were developed because of the as a spin-off technology of for this kind of space-related research. Fireproof clothing and so on. So space tourism, that's also an active area, right? So now with the Axiom mission and all, now people are thinking of space tourism, right? You can go in a launch vehicle, stay there for a few days and come back, right? So I think I have to stop here because I have another meeting, okay? There are not many things to be explained, but due to paucity of time, I have to stop here. So thank you. Lot many slides are there to explain, but I have to stop here. Thank you so much.
Now we'd go for question and answer session. If you have any questions, you please raise your question.
Good morning, sir.
Good one.
You can ask, carry on.
Sir, how sir NARL data will useful for ISRO, sir?
Come again? I didn't hear you properly.
Sir, how NARL data was very useful to us, sir, for launching a rocket.
Oh, come again, please.
Sir, NARL data, sir. From NARL you are taking data, sir, for
I cannot hear anything.
Sir, I know, sir. I am asking relation between.
You are not audible.
Sir.
Now you are audible. Yes, hello.
Sir, how NARL data is related to ISRO, sir? How to launch rockets?
How? How what? Yes, atmospheric data, it is available actually. If you contact appropriate person, it will be given actually. Now we are giving away data for scientific purpose also. Definitely you will get atmospheric data. Whatever data you want, you can just contact, there is one NRSA, National Remote Sensing Center in Hyderabad, right? So this data, it should be available. In fact, in IIST, the atmospheric research is happening and our students are making use of atmospheric data. It will be available for scientific purpose.
Any more? On behalf of Sitams, NARL and ISRO, we extend a heartfelt thanks to Dr. Rajesh Joseph Abraham, Associate Professor in Indian Institute of Space. Thank you for delivering such an engaging and informative technical talk about satellite and space technology. Your insights and depth of knowledge were truly appreciated, and the session was both thought-provoking and inspiring. We are grateful for the time and effort you took to share your expertise with us. It was a valuable experience, and we look forward to future opportunities to learn from you again. Thanking you, sir.
Thank you.
Society for Space Education, Research and Development. Its training programs have guided over 1,000 students in research-based learning, and he has played a key role in designing experiential STEM curricula for international schools. He has conducted numerous hands-on rocket science workshops across the country, helping students connect theory with real-world application, making space science both accessible and inspiring. His passion for outreach and innovation continues to shape the next generation of thinkers and creators. Currently, Mr. Mahesh is a Chief of Staff at Neurosome Cybernetics, a robotics company pioneering AI agents for real-world application. He is leading the development of Neural Pilot, a no-code AI agent stack that enables users to train robots for simple demonstration with rapid simulation to reality deployment. Please join me in welcoming Mr. Mahesh sir.
Hi everyone, good morning. Lot of empty chairs again. Will it be filled? Okay, alright. So you're all from which standard again? Schools. People who are from schools. 6th, okay, alright. And had your breakfast? Your face looks like you don't have energy at all. You need to answer a lot of questions. So I'll tell you something about this session. So usually what happens in technical talks is I talk and you listen, and towards the end you ask questions, right? That's the standard format. But here what we can do is I'll interrupt all this explanations in between. I'll try to ask few questions. So whoever answers, we have few gifts from our side. Okay? And I definitely know college people won't open their mouth, so leave them. This is for specifically school students. Okay? Fine? By the way, you also get that gift if you want that. Okay? Alright. So I created this presentation for both the combination of schools and colleges. Okay? So it won't be very basic, it won't be very advanced as well. So I'm going to include two different topics. One is entrepreneurship. I don't know if you have heard this term. This is something about creating businesses, right? Rather than working, you create work. And again, it has to do with some space science, alright? And the next part of the talk will be about why space. I have been asked these questions everywhere I go teach, like why space science? Why do people even have companies in space science? You have a lot of other problems existing on the world. Instead of solving that, why do you spend a lot of like billions of dollars in space industry? Like, does it really matter, right? So yeah, the second part of the talk will include the answers for that question. Okay? Yeah. So for the first topic, you might not be aware of a lot of things, specifically the school students. It is fine if you don't understand things. Later, if you have any questions, you can ask me. I'll try to explain it in a very different way, okay? Because this was specifically designed for the college people. Because they are the ones who would be like coming out of the college, so they need to know what to do after that, right? Maybe it will also help you because you also have to make that journey and come there and pass out and decide what you want to do, okay? If you have the clarity now, amazing, but most of the people don't have that clarity, even after getting out of the graduation, okay? I hope that is true. Yeah. Can you guys tell me what do you mean by entrepreneurship? Have you heard this term? You should have heard this term. Come on. Doesn't matter if you're a first year or a final year student. The word entrepreneurship. You can spell that, right? So that's how it's pronounced. Yeah, I see your hand. Right. Nice, okay. Answer from the school student. Yeah, you have to clap at least, no? Yeah. See, all the people know answers. The thing is, you have to tell that answer. So you need brainless for that. Okay, yeah. So what do you mean by creating your own business? It could be anything, right? But let's concentrate on space science. So right after your UG, what are the options you have? What are the things that you can do? Whatever you know. Either you can go into academia, take masters, and do a PhD, right? And do postdoc and work in any institutions or colleges. So that is one path. What else can you do? Really? Nothing? Well, you can work, right? You can work in an industry based on your core domain, whatever you're studying, mechanical, computer science, electronics, right? You can either go work in that specific domain or you can also work in other domains, irrespective of what you study, right? So you can work in industries. What else can you do apart from this? Academia and industries. Right, so the third one is whatever topic I have shown here, entrepreneurship, right? Create our own business. So that is third option, which not many people get into because of a lot of challenges and not having a proper understanding of the entire thing, right? And okay, is that all the options you have? Creating businesses, academia and industries? Okay, so school students, right? So you are in school, right? Eventually you will pass out and you will go to college, right? So do you have any idea what you want to do after that? You will have a lot of ambitions, goals and things, right? Yeah. Anyone? Come on, you have gifts, people. If you answer, you get gifts. You want to become a doctor. Okay. So you can write this and keep all the stuff that you think that you want to become, everything will change once you get into college. Okay? For sure. That is what usually happens. Once you are, sorry? Okay, very specific, nice. Urologist. Anyone else? Right, yeah. Army. Okay. Astronaut? Nice. Sorry? Just engineer. Any specific engineer? Okay, just engineer. Good. Yeah. Doctor. Okay, so the reason why most of the people come up with these common terms like doctors, engineers, army, pilot, because these are the only things that you are aware of, right? Because since you study and people tell these are the industries or these are the jobs that you can get after you finish studying, that is what you also tell, right? But there are a lot of other things that you can do after you pass out from the college. So this is one among them, okay? Right. Okay, so let's say space science. I hope you know what is space, right? Space astronomy and things. So what are the businesses do you think you can create in space? Yeah. Exploring planet. Okay, I'll tell you something about the business. So you will be offering a service and someone will be paying for that service. For example, a tea shop. You sell tea, right? That is service you offer. It's a product-based business. You're selling tea and someone is paying for that tea. So that's a business. Same way, in space, what can you sell and get money? Yeah. Yeah, that is actually a very good answer. Sell fuels, of course. So if you own a business which manufactures rocket fuels, you can sell it to the rocket companies which have rockets, right? Yeah. Anything else? Yeah. Right, rocket manufacturing facilities. So that is what ISRO, NASA and all the other companies do. They manufacture rocket and sell it as a service. Right, yeah. Space center, but how will you make money out of it? Oh, okay, okay, interesting. All right, good answer. None from college, apparently. I will keep comparing you guys with the school students, unfortunately, because you're sitting with them. Sorry. Yeah. Satellite services. Yeah, that's a very good answer. You can service satellites. Yeah. Sorry. Right, data. I'm not sure if everyone knows what is data. Anyone from the school student side, do you know what is the data? It's okay if you don't know, it's fine. Yeah. It's information basically, right? Right. I think that side will empty all the gifts, whatever we have. You need to tell answers and get that, whatever we have left. So data means information, right? So you are sending a lot of things to space. Satellites, astronauts, robots like rovers and other missions. So those things collect data, right? They collect information. Information like what? All these, yeah. Okay, that's a specific type of information. Yes, gravity. What else? Yeah. Can human? Okay, it's another question. Yes, they can live in space. Yeah. Actually, they are living in space. I don't know if you have heard of ISS, right? There are humans who stay in space. But yeah, so answer. I need answer, not questions, people. What is the information that these missions collect in outer space? A very basic information. Yeah, okay, weather predictions. But there is one very basic information all these things collect. You also do that when you have phone, if you go out.
Photos.
Yeah, exactly. Photos, right? They are one of the primary data things collect in outer space. You need a lot of pictures of everything. Planet surfaces, surface of the earth itself, and a lot of things, right? So what you can do is, you can sell these data. For example, you have a satellite in space, and it keeps taking photos of earth, and you own the satellite. You can sell those pictures to whoever needs those pictures, to defense, to nations, to private companies and anything. Okay, so that is also a type of business, right? Can you give me examples of companies in space science in India? Whatever space companies you know, apart from ISRO. Yeah. Leave ISRO, whatever companies you know. Yeah. Yes. India, Indian companies. No, that is a facility of ISRO again. Any companies you know apart from ISRO, which is in space science domain, in India. There are a lot, by the way. Yeah. No, apart from ISRO. College people, and come on. Sorry? NSIL, no, it's again an entity of ISRO. Yeah. Private companies, I want private companies. Have you heard of a company called Skyroot? Yeah, now you come up with the answer. Pixel, okay, yeah, that is another company. Skyroot, Agnikul, Pixel, Galaxy. So these are all the companies which exist in India. So back then, when you talk about space, only one company will come to your mind, ISRO, right? Wherever you talk about space science, ISRO, they are the only ones who are involved in this. But now, there are a lot of companies, okay? 100 plus companies which are into the same domain. Yeah. Yes, Dhruva Space, very good. Yeah. So all these companies again sell a lot of things. Few people make rockets, for example Agnikul, Cosmos and Skyroot. So they make rockets. So which means once they start launching the rockets, it will be 3 companies in total in India who will be launching rockets, right? And they haven't launched the rockets yet, but they would be doing that very soon, probably next year or end of this year. And there are other companies who manufacture satellites, right? And there are also people who manufacture propulsion systems for satellites. Have you heard of this term called propulsion system? What is that? You put your satellite in space, but how do you control it? If that needs to move. Usually you don't need that to be moved. Once you put it in orbit, it will be there. But sometimes you need to move your satellite, maybe in different orientation. How do you move your satellite? Yeah. Yeah, that's what we would be controlling it, but how? AI? Okay, interesting. Right, by burning rocket engines, right? There are rocket engines fixed on the satellites. You fire it, you change the direction. So there are companies which manufactures that specific part, the propulsion system. For example, Valedictory Aerospace in Bangalore. So they manufacture that. Okay. Now, if you want to start a business, what do you want? What do you need to start? Capital? Wow, very good word actually. Who said that? So what is capital? Right, that is a very primary thing, right? If you need to run a business or to start a business, you need money, right? The problem is most of the people who have like very nice ideas don't have money, which is the majority actually, right? Because you cannot start companies in thousands and lakhs of rupees, right? Specifically in space science, you need a lot of money. But how exactly will you put money, like where will you find that money? I'll come to that part later, okay? Think about your idea. To start with, you can have a lot of ideas, right? For example, tell me your idea, like what do you want to do in space science if you want to start a business? What do you want to sell? Space tourism, yes. So space tourism, okay, anyone know what does space tourism mean? Yeah. So it has a word called tourism. You know what is tourism, right? Yeah. Now, if you want to go to space and see things, and you want to do that by paying tickets, but not going through the astronaut training, you can do that at present. So there are companies which lets you buy tickets from them, and you can go in their rockets and see the space and come back. Okay? I mean, you cannot be there, you have to come back, because those rockets are not that powerful. For example, is Blue Origin. Have you heard of this company? You know Amazon CEO, Jeff Bezos? Yeah, so that is his company. So there you can actually buy tickets and go to space. Any idea what is the ticket cost? How much they sell the tickets for? Just take a wild guess. What? You think you can go to space by paying 5 lakhs? It's more than that actually. What? You add a couple of more billion, you can have your own company, having your own rockets, and you can go to space. Not that high as well. Very interesting numbers though. Yeah. I'll tell you that answer towards then. Okay, how much is the ticket? You can actually go and book. But they have a lot of restrictions in age and your fitness. Because see, flight though, you can board a flight and you can go to other countries, irrespective of how your fitness is, right? But space is very different. If you have any health issues and things, going to space will have an effect on your body, right? Because the rocket goes very fast. It has a lot of acceleration on your body. So you won't survive if you're not fit to travel, right? So that is why not everyone will be fit to travel to space, but if you can, well, you can buy tickets. So to buy tickets, you need a lot of money. Again, money comes everywhere, by the way, right? So you need a way to make that. But how do you get that big money? You have an idea, you want to start a business, but you need that money. Any idea? Sorry? You want to trade and then you start a business? Okay. Investors. So who are these investors? Yeah, well actually that is right. Straightforward answer. So there are people with a lot of money, okay, but very less ideas. So they seek out people with amazing ideas and they put their money in the ideas and create businesses. But what do they get out of it? Right, they get a percentage of ownership from the company itself. Very nice. That is also a business actually, right? They have a lot of money which they don't know what to do, and they're putting that money into another business and making the company bigger in terms of money, and again they are taking a percentage of that. So which means they are growing their money, right? So yeah, if you want to make a business, you have an amazing idea and you know that idea will work, and then you can reach out to these investors, so-called investors, tell your idea and get the money. Sounds very simple, right? Well, it's not that easy. You go to a person, you tell your idea, sir, I need this 25 crores, have this beautiful idea. Can you give that? Exactly. You cannot have that kind of conversation, right? The entire process is very huge, right? Now, people who would like to work in industries, right, after your graduation, this is again a suggestion from my perspective. Instead of going and working into huge companies and stuff, try working for a few months in a startup. You know what is a startup, right? What are those? There are also companies, okay, very new companies with a team size of less than 10 people. And again, they would have had an amazing idea, they would have gone to an investor, got money, started the company, and they would be building something. Pretty new company, less than 2 years old. So if you go and work in that company, you get to learn a lot of things, including how do you pitch an idea to someone, an investor, and how do you get a money out of that. And how do you use that money to build a product, and how do you sell that product to a customer, and how do you make money out of it. If you go work for a big companies, you don't learn any of these things, right? You do whatever they tell you to do, and you keep doing the same thing on a repeat basis, which is totally fine if you need like a proper settled job, right? But if you want to learn a lot of things in a very short span of time, the best way to do that is go work for a startup. It can be any startup. All the space companies which I said, those are the best examples for you to go work for them, right? Even if they don't pay you much, it's totally fine. You're going there to learn things. So yeah, you can do that. Yeah, by the way, these are some of the companies. Yeah, in India. Can you read? Is it visible? Yeah, you have Skyroot, you have Agnikul, you have Pixel, Satshore. Satshore are the people who sell data actually. You have Dhruva Space. What is? Yeah, we have Digantra. You have Bellatrix, you have Kepler. Yeah, so all these people had those beautiful ideas in space science. They wanted to sell something and they created companies out of that. This is not all the companies in India. These are the major ones who had some success, some form of success. So when you start a business, it's not that you will be a success, right? You cannot take that for granted. Not all the business will see light. At some point of time, you'll run out of capital, you won't know what to do, you won't have product, and that's it. If the company goes bankrupt, you shut down and you move on. That is majority of the company. And the company which actually goes through the phases and they become a success, these are very few. Alright? Yeah, this is specifically for the college students. Yeah, networking. By the way, do you people, you do anything apart from your academics? Is internship part of your curriculum? So you do it in your final year, is it? Okay. So I'll tell you why networking is very important. The moment you pass out of your college, okay, this is for you as well when you come to that point. So when you come out of the college, the only thing that you will know is whatever you learned in textbooks, right? Which is not very practical in real world scenarios, right? That is the base knowledge which you need for sure. But with that base knowledge, you cannot survive in any of the companies. People don't want that knowledge. They want actual experience. So it's a chicken and egg problem. They want experience and you don't have experience. Like, what do we do? How do we get jobs, right? So you start from your first year itself. Okay? People would think, let's go with this 4 years, let's complete and come out of it, search for internships, then go for a company and do a lot of things. Well, it doesn't work, unfortunately, right? Because I also hire for my company and I get a lot of resumes with just degrees. We don't really look at degrees, right? Degrees don't tell a lot of things. It's the actual skill set what we need. So what you do is you reach out to all the companies which I listed. That is in space science domain specifically. But you can also make a list of all the startups in your company, like in your domains. So computer science, electronics and communication, civil, even mechanical. Reach out to them. How do you communicate with those companies, by the way, if you have to reach out to them? How? You have found a company, you need to tell them that, you need to ask them whether they have opportunities. How would you do that? Mail them is, yes, it's a primary mode, yeah. But what if you don't get any replies? People don't really read emails, a lot of people in companies. How else will you reach out to them? Have you heard of LinkedIn? Discord, GitHub. Okay, I am pretty sure you are on Instagram, Facebook, Snapchat and all this stuff. That is fine for your social life, but you also need to be on LinkedIn, GitHub and Reddit, Discord and all these things. If you don't know what these are, please Google what these are and create channels and get into that. Okay, it's very easier to get jobs if you are in that place, having some experience. So there are a lot of open source projects which groups of people do across the world. Okay, not just India. You can just join that community, get into a project, just work with them. You won't even know who they are. They'll be working on the other side of the world. But you can collaborate with them, work with them, and have that experience. And then when you go knocking on a company, you tell them I have worked on this. Easier. You don't have to tell them I have a degree. Tell them I've worked in these projects. That is all they need, right? So yeah, maybe you can take a picture of this if you want to keep it. This works because this is what I did, and it works. Okay. Okay, all right. The second part of the talk. This would be pretty interesting. Then the entrepreneurship thing. Why space? I will start with this question, then I'll answer. Okay. Answer is pretty long, and there is also a very nice video towards the end of this. Okay. So whenever I talk to people about space and things, this is one of the common questions. Why space? Why should people spend money on space? It's not giving us anything apart from pictures from above the surface, right? Spending billions of dollars on a rocket and satellite, instead you can be spending on that for a lot of other basic infrastructures, right? On homes, electricity, and there are a lot of places without all these facilities. So why do you even spend money on space science? Or why should people know about space science? I'm not interested in space science. Why should I even learn that? Anyone with any answers for this? Wait, okay, before that, another question. Of all the people here who like space science, actually like space science, not just for the sake of you being here, but if you really like space science, raise your hands. Okay, very few, which is great actually. This will help really. None of the college students, you like space science? Not even some curiosity about what this is? Okay, alright, very nice. No, that is totally fine, because there are a lot of people who don't know anything about space science and they'll be like, why should I even bother? I have a lot of my things to worry about. Why should I even know these things, right? Okay. So maybe towards the end of this thing you might give that question another thought, okay? So for this, I have to tell you where do we exist in the universe and how big our universe is, which you won't know for sure, but here's the thing. Can you tell, okay, here's another question. Again, do you have more gifts? Okay, what is the fastest man-made object we have ever made? No, don't tell rocket. Specifically, there is one man-made object which is the fastest that has traveled ever. Satellite? There is a specific kind of satellite. We Indians did not do that. Light, we don't invent light. Light is something which exists. Okay. Something which we created, that, yeah. Spaceship. It is a satellite, it is a spaceship, but there is a name to it. Okay, which country made that thing? Let me, yes, obviously it's America. Okay. There is a spacecraft called NASA's Parker Solar Probe. A spacecraft designed to go near the sun and collect data. Yeah. Any idea how fast was it going? Just take a random guess. In kilometers per hour. Just come up with a number. No. 10,000? No. No. Come on. It goes at a speed of 600,000 kilometers per hour. I'll convert that into kilometers per second. It's 200 kilometers per second. So in that time, it travels 200 kilometers. Imagine how fast it is going. And that is only possible because it is in space, no friction. It's vacuum, right? If the same thing travels here, it will go into pieces, right? Because of atmosphere. So even with that speed, let's travel from our planet and see how big our universe is. Okay, clear the concept? We are traveling at 600,000 kilometers per hour, which is 200 kilometers per second. We are sitting in the spaceship and we are traveling from Earth. Let's see how much time it takes for us to go to our neighboring objects. Okay? Alright. Let's say we have to go to Moon. How much time will it take with that speed? Days? No, you're traveling very fast. You need to understand. 200 kilometers per second. It will take half an hour approximately for you to reach Moon with that speed. Right? 30 minutes. It's 30 minutes approximately. Okay? In half an hour, if you leave now, in half an hour you'll reach Moon with that speed. Looks very fast, right? Okay. What about Mars, our neighboring planet? 1 hour? So people think moon is half an hour, Mars is well bit beyond that, so 1 hour, 2 hours, right? No, not exactly. In space the distances are very strange. You cannot comprehend. So Mars, it will take 13 days. Yeah, very far. But people don't like comprehend the distances. Even with that speed, it will take 13 days for you to reach Mars. Okay? So let's say Jupiter. Let's travel beyond Mars. Jupiter is the next immediate planet after Mars. What? 15 days? No, 13 days. It took 13 days for Mars. It's approximately 47 days. Okay? For you to reach Jupiter. Again, very fast, given the distances, right? So 47 days you reach Jupiter. And okay, what lies beyond Jupiter? Pluto, okay. What about Pluto? Pluto is not a planet, by the way, but let's say we want to go to Pluto. That's the end of the solar system. Yeah. 6 years. Okay. Any other guesses? By the way, if you would like to know the distance, it's around 5.9 billion kilometers. I don't know if you can even think of that number. That's how far Pluto is from us. So even with this speed, it will take around 355 days approximately, 1 year. Imagine going at 200 kilometers per second, it will take you one year, complete year to reach Pluto. This is still within solar system. You haven't left solar system. 1 year is already gone from here. So what lies beyond our solar system? You're done with all the planets. You're at the edge of the solar system. You want to go beyond that. What do you think lies beyond that? No, my question is, what lies beyond our solar system? No. Stars, right? Stars, other stars. We have neighboring stars. Which is our neighboring star? Dhruva? No. Okay, sun is the closest star, right? Who is the neighbor to sun? Sun will have another neighboring star, right? So what is the name of the star? Venus is a planet. Okay, that's a very good answer. Yeah. Someone can give, yeah. So actually the star name is Alpha Centauri, but Alpha, Proxima, these are all like a group of stars which stays together. It's a 3-star system. 2-star, I think. So it's the neighboring, okay, you're traveling at this speed, 200 kilometers per hour. How much time will it take for you to reach our neighboring star? Our closest star, which is closest to the sun. Alpha Centauri. 10 years, okay. Any other interesting answers? No. Take a guess. Very close. It's around 6.5, 6.8 years. Okay. So, which is again a lot of time, given the speed at which you're traveling. Now, if you want to go beyond this, your 200 kilometers per second is not enough. It'll take forever. Now, let's say you want to travel at the speed of light. What is the speed of light? How fast light travels? Okay, I want a proper number. I don't want 10 power and all the stuff. Yeah. 3 lakh kilometers per second. Anyone else? Is that right? Anyone have different answers? What is the speed of light? No, I wanted kilometers per second. Yeah. No, I don't want the 10 power 8. People won't understand. What is the 10 power 8? I want a number, proper number. Okay, so 3 lakh kilometers per, which is, do you think that is fast? You're thinking for that question? Of course it is fast. That is the fastest thing in the universe. Okay, you cannot travel faster than that. It's a universe speed limit. Okay, you might ask me why and all this stuff. Okay, I'm not going to answer. That's a very long answer. Sorry, but the fact is you cannot travel beyond that speed. It's the universe speed limit. Okay, so you are traveling at that speed. Imagine 3 lakh kilometers per second. I'll give you an example for you to imagine how fast that is. In 1 second, you can circumnavigate Earth, our planet, 7.5 times with that speed in just 1 second. which means that is how fast light travels. Even with that speed, let's say you want to travel beyond our neighboring stars, okay? Let's say you want to leave our solar system. What is the solar interstellar neighborhood? These are our neighbors, right? Other stars. Sun is a star, right? Alpha Centauri is another star, and you have a lot of other stars in the neighborhood. So let's travel beyond this. So let's say you want to leave our galaxy completely. How long will it take? You're traveling at the speed of light, and you want to leave our galaxy and go to another galaxy. Yeah. Remember this again, you're not traveling at 200 kilometers per second. You're traveling at 3 lakh kilometers per second. Speed of light. One day, you're leaving our galaxy and you're just leaving the galaxy. You want to exit the galaxy. Let's say that, yeah. 48, very nice number actually. Any other guesses? It will take 100,000 years. With that speed, if you start now, it will take 100,000 years to just exit our galaxy. Imagine the distance involved here. It doesn't make any sense, right? So that is how big our galaxy is. So even if a human is traveling at the speed of light, and you start now, it will take 100,000 years, which means I don't think 100 years maybe, that is how long we'll live. No, I don't think that long. 17, 75, that's the average lifespan. So you can never make that trip, which means whatever technologies that we invent, even if you want to invent something which travels at the speed of light, we can never leave our galaxy. So we are prisoners within our galaxy. You cannot explore beyond that. Alright. Now let's say we want to go to our neighboring galaxy. Which is our neighboring galaxy? I will definitely give a gift if someone guesses this. Which is our neighboring galaxy? Okay, what is our own galaxy? What is the name of our galaxy? Yeah, that everyone knows. No gift for that. But neighboring galaxy. Which is, no, galaxy. Yeah, so we have two people. You decide between you two who wants the gift. Okay, Andromeda. So that is the answer. Our neighboring galaxy is Andromeda. Okay. Any guesses how long will it take for us to go to that galaxy? Let's say if we are traveling at speed of light. You know it takes 100,000 years for you to leave our galaxy. No, it takes 100,000 years to leave our galaxy alone. And we need to go to a neighboring galaxy, Andromeda. How long will it take? It will definitely take beyond 100,000 years. But what? How much? What is the number? You're okay, you're multiplying by 2. No. No. College people, come on, use your some mathematical skills. 5,000, no ma'am, it's more than 100,000 for sure. Because, yeah. It takes 2.5 million years. I'll repeat that number. It takes 2.5 million years for you to reach our neighboring galaxy. It just takes 100,000 years for you to leave our galaxy. But at the same velocity, it takes 2.5 million years to reach our neighboring galaxy. So imagine the distance between the two galaxies, the gap, right? Which means our universe distance between any two objects is very, very huge, okay? Which we don't even comprehend. So that is how big our galaxy. And this is just two galaxies, okay? Imagine all the other galaxies. So that's how big our universe is, right? Okay. I'll show you another thing. Do you know what is this picture? How many people say it's stars? Are you sure? Okay. So this is one of the greatest images humans have ever captured. And this was captured through Hubble Space Telescope. Have you heard of that? It's a huge space telescope which is in orbit beyond Earth. And we have, so what happens is, you have this huge sky, right? You pick a small patch of sky, the size of this much, right? And you focus your space telescope in that patch of the sky for multiple days. Because you need to collect a lot of light, right? In your phone cameras, when you click capture, it just captures, right? Your shutter gets closed immediately, just like that. But here, you just leave it open. If you hit capture, it will take multiple days to capture one image. So you leave that, and this is what Hubble Space Telescope got. Okay? Why this is so special is, all those tiny, tiny dots are whole galaxies itself. So each of the galaxies hold around 100 billions of stars, each galaxy. And you have these many galaxies in that, just that patch of the sky. Okay? So imagine how many galaxies you will have in the whole observable universe. Any idea? No, infinity is not a number. I mean it is, but no. In trillions basically. Okay, that's how much galaxies you have. Okay, and there is this comparison where, you know beaches, right? You have gone to beaches. You have played with the sand. So let's say when you take a scoop, like handful of sand, how many sand grains do you think you have? Who would even count that? It's a very silly question, right? Well, that's a lot of grains in one handful of sand, right? Imagine how much sand grains that whole beach will have. They can't even come up with a number, right? Imagine all the beaches on the planet Earth, all the countries. You know how many sand grains we'll have? So we have more stars than the grains of sand on all the beaches on planet Earth. We have that many stars in the universe. Imagine. And at least 80% of those stars have 4 planets or 5 planets orbiting around those stars. Okay? And out of that, at least 1 planet will support life. Which means we have around quintillion planets which might have life. So, well, where are those life? Have you seen any aliens? Anywhere? Any pictures? Movies? Yeah, they only exist in movies, not in real life. But don't you have this question, like, if you have that many planets which can support life, why haven't those aliens visited us? The answer I just told you way before this. Distance. The distance is like very humongous. Even if you want to travel to adjacent stellar systems, it takes a lot of years, right? And yeah, maybe that is one of the reasons. Okay. And I have this nice video. Have you heard of this scientist called Carl Sagan? Anyone? Carl Sagan. Any idea who is he to start with? Okay. Yeah, I'm sharing it again. Carl Sagan is one of the scientists who was primarily responsible to launch a lot of spacecrafts in NASA, like Voyager, Viking, Mariner probes and all stuff. So have you heard of this Voyager spacecraft? That is the spacecraft which has gone the farthest we have ever created. It has left our solar system and it is traveling to the neighboring star. Okay, it's called Voyager 1. So there were 2 spacecrafts, Voyager 1 and Voyager 2. So after this Voyager spacecraft went beyond Uranus, these people decided, let's take a family portrait of our solar system, which NASA, of course, did not agree, right? The spacecraft is traveling at that velocity. Why do you want to turn the camera towards backside and you want to spend all that energy to capture that picture? Because picture won't have any planets at all. Planets will be as dots because it's how far away it is. But these people agreed for some reason and they took a picture, okay, looking back towards the solar system. And this is what they found. So this is one of his famous speeches, and there are subtitles for if you don't follow his words, so you can listen. It's a 4-minute video, but this is something that actually everyone like should watch in their lifetime. They should know this. see and observe that picture. You see that dot?
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lone speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Is it? Yes. Settle. Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only one we've ever known.
That picture was very famously known as the pale blue dot. Why? Because that's how Earth looks like from that vantage point, right? So at that distance, Earth was just a point of light, which was like a blue color dot. So whatever happens, everything just happens with the dot. I told you how big our universe is, right? So in comparison to that, Earth is not even a dust, right? It doesn't exist. So whatever happens within the Earth, well, it exists on this Earth. If you want to go beyond Earth, like where else will you go? Nothing, right? If you want to go to the nearest stellar system, it'll take beyond the lifetime of our humans. We won't come up with a technology which we can travel in speed of light, ever. Its laws don't permit you to do that, right? So the fastest that we have traveled is what, 200 kilometers per second? That is a spaceship. I don't even think humans can travel that fast in the space. Maybe if we can come up with some technology where you can closely match that speed, yet you cannot leave our solar system or even our galaxy. So we are kind of prisoners to wherever we are. So the reason why he took that picture, convincing the whole NASA, to turn the whole spacecraft around to take one final picture is to tell people that you have to take care of the planet, because if there is no planet, well, you cannot go anywhere else. That's the whole point of that video. And you can also read up on Voyager 1, how it managed to take pictures. This was back in 90s, okay, where technology existed in a very flimsy level. We don't have any advanced tech, but they managed to send that spacecraft to take pictures of all the outer planets. This is the very first time actually they took pictures of all the planets to that scale, okay? Any questions, people, so far? Scale of the universe, entrepreneurship, no questions? Was kind of like a, sorry? Yes, sir.
So far we have the thought of having Big Bang theory, but later a new concept is coming that Big Bang theory might be false, and there exist two black holes that union makes the universe to generate. So is there anything idea about on this for you, or please?
So far the answer to the question like how did the universe come into existence, the best theory humans have come up with is Big Bang. It's just a theory, it's not an answer, by the way. If someone tells you that is the answer, it's not an answer. Scientists themselves accept that it's the best theory. Why? Because we have the most proof so far, mathematical evidence to support the Big Bang theory, right? So there was this person called Edwin Hubble, okay? You know Hubble Space Telescope, right? Same person found out that the universe is expanding. All the objects in the universe is not static, instead everything is going away from each other at a very high speed, right? So if that is the case, what would have happened in the initial days? Rewind the whole thing. So everything would have started from a single point. So that is what we call it as Big Bang. Not exactly an explosion, but that smallest point expanded, okay? And that is the best theory. But now people are coming up with, again, lot of different theories, but not enough evidences to support those theories, okay? We might never know what created this universe because we don't have physical evidence. No, you cannot just go there, take pictures or take data and correlate. Never possible at all. The only way we can prove something at those level is mathematics, the best tool that we have. Mathematics or observational evidence. These are the two things that we have. Apart from this, I don't think we can get other proofs. So I don't know if I've answered your question, but yeah. But yes, any other questions? No one has any questions?
Anyone else?
Very, okay, we have more gifts. Okay, interesting questions will also get gifts. This is our way to make you talk, unfortunately. Bribe you with gifts. What is the full form of NARL?
I think
You have it here.
National
Atmospheric Research Laboratory. And we have people from NARL sitting here. Yeah. Any other questions? No questions at all? Okay. At least did you like or did you kind of understand what I was talking about? Did you feel that it was interesting? Did you feel that space is kind of important to know where you are? Because things exist outside, you cannot just live and just disappear from the planet without knowing whatever exists outside, right? You should at least put some like thought on what exists. Our human's basic intuition to know what is beyond. So yeah, that is the whole point of that video and that lecture. So if you don't have any questions, I here. So yeah, thank you.
with that insightful and inspiring session by our resource person, we've certainly gained a deep understanding of space science. We truly appreciate the clarity, passion, and the depth of knowledge shared. As a token of our gratitude and appreciation, we now move on to the felicitation of our esteemed speaker. May I request Dr. T.N. Ram Kumar to kindly come forward and felicitate our resource person with a memento. Please give a big round of applause. I call upon Mr. Tulsi Prasad to present the vote of thanks.
Yes, I'm going to give a vote of thanks.
Just continuing, you hearing? Okay. Okay, fine. Just over 2 minutes only. So, when a very nice question was asked, you are audible? Okay, fine. Very nice question was asked. No? The question Big Bang theory is correct or wrong, like that. Okay. Yes. Okay, that's right. Okay, fine. That answer is the prominent answer what he has given. But there is a very nice background, Indian background is there, that is very encouraging for the students. You know, there is Professor J.V. Narlikar, Jain Vishnu Narlikar, he is from Pune, and he promoted, along with another great international scientist, Fred Hoyle in Cambridge University, steady state cosmology. It means it is not like a one point of explosion and planets, stars flying and forming like that, but it is steady state oscillation of the whole universe. It means they expand, they shrink, they expand, they shrink. Today the phase is that expanding phase, and after some time it will become shrink, again it will expand. This is called the steady state cosmology. You know, for that theory, Professor Jain Vishnu Narlikar from Pune in India, he was awarded Padma Bhushan Award at the age of 25. He is the youngest person in India and he is a scientist. He promoted that astronomical theory. You go to that one, you see that you can find it. Not only that one, you might have heard about Professor Stephen Hawking. You know, you might have heard about it. He is talking about the life and this time travel, everything is being. You will know he became familiar by talking negative against this theory. Even in his PhD physics, if you get a soft copy, in the abstract we will write. He says openly, Professor Narlikar theory, there is a flaw. Okay? Say in mathematical, there is a beauty of the mathematics. You can assume innumerable solutions, and some set of solutions you can take it and promote that theory. And our set of scientists, they pick other part of solutions, they promote with that theory. Who is winning is that? Observations. So you need theoreticians, observations. So some point of time, observation will support one theory. In some another point, other part of theory it supports. Finally, we will travel with those knowledges. Thank you.
Now, vote of thanks. It's a pleasure to me to extend heartfelt thanks on behalf of ISRO, NARL and Sitams to Mr. Mahes sir, a dynamic engineer representing rockets. It was a privilege to have you with us for the technical session on rockets. Your talk provided a clear and fascinating overview of the subject, enriching our understanding and igniting curiosity among the participants. We are truly grateful for the knowledge and expertise you so generously shared. Your contribution added immense value to the event, and we deeply appreciate your time and effort. The students enjoyed and gained knowledge through your talk and rocket launch. Thank you so much, sir. Thank you.
I just like to add one thing. Mr. Mahesh very generously agreed to give this lecture on the last moment notice. I told him last night that please give a lecture, we have a free slot, and he generously made all these slides and put such effort. So please, one more round of applause for him.
I extend a heartful welcome to the gathering for the exciting technical talk. Dr. Arun TV is currently an assistant professor of CSE Department of the Indian Institute of Information Technology, Sri City, Tirupati. He is also leading the Spatial Analytics and Mission Intelligence Group at the Institute. His research areas include drone and satellite remote sensing, deep learning, explainable AI, geospatial technology, and reinforcement learning. Before joining Triveni Sri City, he worked as Associate Vice President at the R&D Division, High Technologies. He completed his PhD from IIT Bombay and postdoc Ben Gurion University of the Negev, Israel. He was awarded the Outstanding Postdoctoral Fellowship and PhD Sandwich Fellowship by the Higher Education Council, ISRO. He was also offered postdoctoral position at the Italian Institute of Technology, Italy, University of Hull, Finland, Madison, USA, and Rolls-Royce Lab, NTU, Singapore. He has published over 50 publications in reputed international journals and conferences. He is the principal investigator of projects from different national agencies, including ISRO and DRST. He received appreciation from the Indian Army for contribution towards the project Drishti. He also multiple travel grants and best paper awards. His group consists of B.Tech, MS and 5 PhD students and 3 RJFs. He serves as a receiver for many reputed journals and technical committee members for various conferences. Now we welcome Dr. Arun sir for technical talk.
Okay, so a very good morning to all of you, and thank you for the very nice introduction, and thank you for the kind invite, NARL as well as CMAT team. Thank you so much. Actually, it's a privilege to be here. First time I'm in Sitam, so it's really a privilege to be here in Chittoor, that too with young mix of audience, right? So I'm now wondering how I will cover the topic given the audience, but I will try to keep it interactive. I don't want you to sleep during the session. So okay, so to start with, I hope I'm audible now, right? Yeah. Yeah. Sure, definitely. Yeah, sure. Okay, so to start with, when you see the topic, it will look very complicated to you, but it is very simple. I'll tell you an example. So like you, I was also a student, particularly during my PhD, okay? So I don't know, as a school children, if you face the same problem, feeling sleepy during your sessions, So I was feeling very sleepy, particularly during the, PhD time. So for us, PhD supervisor means he decides your life. So if you feel sleepy during his course, then it will create a bad impression, and at the same time it will be a problem for you, right? So I started attending his sessions. I mean, he's a well-known expert, but the problem is after a heavy lunch, afternoon class will be a problem. So I started sleeping. So I found out a good way to solve this issue. That way is drink water so as to avoid sleep. But the problem is we are evolving, right? So our system is quite adaptive. So it learned how to drink water and sleep. Now next idea was like you pinch yourself while sleeping. So again system is evolving. Then it learned how to pinch yourself and sleep. So this is how learning goes. So same way, like we want to make these machines also learn, right? So that is where when we are launching this Chandrayaan, so that rover has to learn itself where to move, where to go, right? So this learning process has to be there. So that is where where my talk is. So how to make the machines learn, right? So this all of you now so far familiar with whenever you hear the term ISRO, you will see that satellites, one more satellite they are launching. So primarily what are these satellites for? Primarily we can say that 3 different purposes they have. One is for communication. All of you will be now using your mobile phones, right? So communication satellites, so your mobile phone, it will send signals. So this way, when you use internet, so you have the data, right? When you use internet in your devices, so it will be going to satellites. It will help us to communicate, because we cannot have electric post or telephone post everywhere, right? So it's better that we have some post which is placed in the orbit. So this is one type of satellites. And whenever you nowadays you take photographs, so it will automatically, when you upload in Facebook, it will show that from where you took the photograph, right? So usually when you take photograph, you will go to some special places. You will take photograph, and as proof that you actually went there, you will add this GPS tag also, right? So it will say that, okay, you were there, this coordinate, right? So that means, now that location is also attached to your photograph. So if in this classroom, if I am sitting there, so you can say that, okay, he is sitting in the first row and the second chair. But if I want to say this to someone who is in US, how I will convey this? So here the frame of reference is local to this room. That means I can just say which chair, which row, which column, or which row, which chair. So same way you can use latitude, longitude. That means which latitude you are, which longitude you are. So that means it's a general frame of reference, or anyone in the world can understand where are you. So for example, when the NARL person came to pick me up today morning, I just sent him my Google coordinates. So I don't have to tell him where I am. He will find a way out to reach there, right? So how is it possible? It's possible using this set of satellites called Global Navigation Satellite Systems. So you can see that, there are a lot of satellites which will give us the location. So how are they giving us a location? This is like you can see. So this photograph, it is getting tagged, right? So you can see all these type of tagging is happening because the photograph is attached with a location. So how are we getting that location? And it's having a lot of applications. I already told you, you can tag your photographs. Not only that, you can tag your photographs when you order your food in Swiggy. It is reaching you because they have coordinates, right? So many such applications are there, ranging from day-to-day applications to defense, right? So, when you send flight, tracking of flight, tracking of missiles, all these things, are one way or other way governed by GPS systems. Its actual term is GNSS. The company, a separate company is there, GPS. But since the company is more famous than the actual system, we usually use the term GPS, okay? So same like there are some products, right? Wix. We use that company name is famous for that, right? So same way, GPS is a company name and GNS is the system, Global Navigation Satellite System. So earlier satellites, it will help us with communication. These satellites will help us with where to go. So we have two sets of satellites now. One is the satellites, the communication satellites. They are more or less geostationary satellites. Geostationary means they will be stationary with respect to the Earth. So always they will be at the fixed position when we see from the Earth. Okay. So, and we have navigation satellites which will help us to know our location. Now I will just discuss something very boring. That the math behind the GPS. This is very interesting. Like, how are you getting your location? So I am here, I don't know my location, but the satellites, they know their location. So you can see these satellites, all of them knows their location, and I don't know my location. Now they have to tell me what is my location. So how would they tell me what is my location? So how would they tell me what is my location? They know their location. Now they will send some signal to me. So I am holding this mobile phone. This mobile phone is having a GPS system. So from this mobile phone, I will be able to know my location. But how this mobile phone will know what is my location? So what satellites are doing, they will send some signal. They will tell you what is their position and what time they send this signal. So the moment I will receive, I will calculate at what time I received. Then with the help of speed of light, you can easily compute, speed equal to distance by time, right? So you can easily compute your distance from those information. So once you have the distance, you will just use a very simple, equation. I am not going to discuss it. So you have a lot of satellites. So now from at least 3 of them, you know the distance and you also know their locations. Now you don't know your location. So you can form equations like this. These kids you may not be knowing, but it is fine, right? So you have 3 equations and 3 unknowns, so you can easily solve it, and 4th one you will use for error correction. So at least you need 4 satellites. But the takeaway is that you can just use 4 satellites to know your location, because they know their location and they know the time that they are sending. We know their time in which they are sending the signal. So with that we will know what their location is. So right now you are seeing me, right? So are you seeing me by touching me? No, you are just seeing me with your eyes. So whether your eyes are touching me? No. So you are remotely sensing me, right? You are remotely sensing the color of this shirt. So this is called remote sensing. Okay? So if you use a camera, we have a camera here. So whether the camera is touching you? No, but the camera is collecting information about you without touching you. So same way, if I have a camera on a satellite, it can take the photograph. Like this camera is taking your photograph, that camera can take the photograph of the earth. Any of you, if you climb a tall tree and you will look down, you can see the ground, right? So same way, if you take a camera and climb a tree, you can get the aerial view. So same way, the satellites will get the view from above. Yeah, you are smiling because if you climb with a camera, you will fall down. That is why we use satellites, because we will not fall down, right? So we have a camera fitted on the satellite and the satellite is moving. So you can see that we are getting, you see me, because why? Because there is light. This light is hitting me and is getting reflected, and that reflected rays are reaching you. Why your shirts are appearing red? Because the red light is getting reflected from your shirt. And why the leaves are appearing green? Because the green light is getting reflected from the leaves. So same way, you can see here, sun rays are coming, it is hitting, it is going to the satellite, satellite is capturing it, and that forms a photograph like this. So same way, like you are taking the photograph of the room using this camera, satellites will take the photograph of the earth's surface. See, same view you will get if you travel on a flight. If you look down, you will see the terrain like this. You can see a river flowing through there, right? You can see some other, urban built up, some green patches, other things. So why we use these satellite images? Because you will get a view from above. I'll tell you the advantage of this. So instead, if our class is like plain class, now since the class is oriented like this, I can see each of you, right? But if it is a normal classroom and I am standing here, if someone is talking or someone is sleeping, whether I will be able to see them? No, because it will be obstructed by others, correct? So, but if I am, fitting a camera there on the top, it will be able to monitor you, right? So this is called the aerial view. So we are looking from above. We always say, na, Bhagwan upar se dekh rahe hain. Matlab God is seeing all of us from above. That means God can see everything, right? So God is not looking from side, not looking from this side, but He is looking from above. Same way, satellites are also like Bhagavan. They are also looking from above. So once they are looking from above, if they are in the field, if there is some, some disease, some crops are getting affected, we can easily see from that image. I don't know if you have watched a movie called Paramanu. There is one movie. So there, when we are testing this, nuclear bomb, so the American, people, they are watching using a satellite, right? So they are looking from above, and they are trying to see what is happening here. So same way, it has a lot of application. One of the most interesting application for us is the food. You search for food, you search for restaurants, right? So how you will search? You will search in Google Map. So how is Google Map getting all this information? It will have a satellite image like this. By processing that satellite image, it will get information plus some additional metadata. It will get information like this, right? So then you can search for food. Like for example, these are the restaurants near my college. Okay, so in both the ways, you can see it in a satellite sense or in a map view. Okay. So now the distance from one place to another. This is the distance from my institute to the place where my house is. So you can see I am staying somewhere there, right? So this is the, these are, you know, these are how we are seeing, yeah, that how we are seeing the earth from above. Now this is a very tricky thing. See, you can see an image, right? So what is this image? Yeah. A branding, correct. So there is an image, there is a face, correct. So now you see this image. Is it actually an image? See, it's a number. You see, these numbers are actually called pixels or image. If you zoom an image, you can see this type of numbers. Okay, you won't see the numbers, but at least you can see those pixels. So I am not sure if you are familiar with arrays or metrics. You know, this you can see as a you can see this as a collection of numbers. Okay, so that is what we call it as, you know, an image is being seen by any you know, machine, computer. It sees the image like this. See, you see the image like this, but the computer sees the image like this, because computer is a machine, right? It will not understand the colors like we are saying. It will only understand values. So it is seeing the image like this. So now you see this is one image. See, when we were also kids, we used to take a pencil, we used to draw images. So this is not a color image, right? Is this a black and white image? How many of you say this is black and white image? Any of you black and white? Black and white. Then what is this? Then what is this? It is written the grayscale, so it's easy for you. Yeah, so you understood the difference, right? There is a shades of gray here. Here there are only two colors, black and white. But here it is not color image, but it is having shades of gray. So that means black is 0 and white is having some other value, but it is not 1. Here it is having two values, only 0 and 1. Here the values, you have shades of gray. So this is one image. You can see, right? I am writing here red, but the image is not red, right? Again there is one more image, green, and I have written here green, but the image is not green. Again blue, but the image is not blue. Now the image is colorful. So can you correlate this with whatever images we have seen? See, wherever I have written green, just focus on this. This is the green, right? So wherever I have written green, that image is bright. Wherever I have written blue, this is bright. That means the blue color is bright. Wherever I have written red, the red color is bright. So that means now I am using 3 different cameras. One camera for red, one camera for blue, one camera for green. But all of them are grayscale images or gray images. Now when I combine them, I will get color image. This is how your eyes work. See, your eyes are like having 3 cameras, one red, one green and one blue, and all of them are getting combined to give you a color image. Now this is same thing. So you have a green image, you have a blue image, and you combine together to get a color image. Okay. So why we are saying all these things? Because your satellite camera also works in the same way, and so you have, so satellite image means one more thing. During COVID time, any of you travel through airport or any place, malls, other places? So they will, many of you travel. So at least a few of you travel. So then what they do, they will have a camera by which they will say whether you are having fever or not, right? So they used a camera to see whether you are having fever or not. But with your eyes, whether you can see whether you are having fever or not? Any of you? Can you look at me and say like whether I am having fever or not? Is it possible? Why it is not possible? Why camera can see that? Pardon? Our eyes cannot sense the heat, correct? Our eyes can sense only red, green and blue. But the camera can also sense heat or infrared radiations which are getting emitted, correct? So that means there is something which you cannot see, the camera can see. So imagine, some terrorists are trying to enter our country through the border, right? So night time you are having so you are having only your optical camera. So whether you will be able to sense if they are crossing in? So you understood the question, right? So you have optical camera, they are crossing the border, they are coming in. So optical camera means your usual camera, whatever you have in your phone. So imagine that you are fitting that to a satellite, and the satellite is looking at our borders. That camera, through that camera, satellite is looking at the borders. Then whether we will be able to see that people crossing during the daytime? During the daytime? You understood my question, right? So I have a camera, the camera is fit onto a satellite, and now we are seeing in our screen, we are seeing the border through that camera. Now one terrorist is coming. So whether you will be able to see that terrorist? Yes, you will be able to see, correct? Why you have a doubt? It's a screen, so the camera. At night time? Yes or no? No, because night time if you will take a photo, whether you will get photo? No. You will get if you will use flash. Clear? Otherwise you will not get. Correct? So that way, sometimes you may need to use some sensors which can sense the things which you cannot, your eyes cannot. So there are some radiations or some emissions which your eyes cannot sense, that you can use cameras to sense them. That's why during COVID time the camera was sensing whether you are having fever or not, but your naked eye cannot. Clear? So now same way, so instead of just having like a normal camera, the satellite sensors can have more number of more cameras. So that means they can have more images, so they can sense things which we cannot. So you can see that when a satellite is seeing somewhere, this is the entire image. So I can split this image into different grids. So you can see this grid, right? Each grid will be one rectangular block or one pixel. Now I can also grid it like this. I can also grid like this. I can also have grid like this, right? So when I have a larger grid, so pixel size is more. So you see when I think now you have very high resolution camera, but when we were children like you, we had very coarse resolution cameras, okay? So when we will take the photograph and we will zoom those photographs, we will only see pixels, like this. Like this. So when you use better cameras, you will get more number of pixels, but when it's better, it will become better and better. Now you can see it's very clear, correct? So this is called resolution. So you are increasing the resolution so that things will become more clear to you. So you can also have more number of cameras, like I told, rather than just having red, green and blue or only one camera, you can have more number of cameras so that we can detect things in a better way. So now you know that, an image means just a collection of numbers like this, right? You see the the initial image that we have shown you. So an image means the collection of numbers, correct? So you can see some are appearing black, so say 43. Some are appearing bright, say 234. So yeah. So if suppose that 43 is black, right, somewhere. You can see this 43 is black, 36 is almost black, right? But 234 is bright. So if I want to make this bright, what I should do? I can add a value 60. Then the value got changed to say 95. Is that clear? So that means if I want to increase the brightness of this image, I can simply add some constants to these values. See, this is an image. An image is nothing but a collection of values. If I want to increase the brightness, I can simply add some values. So that means by processing, by adding some simple, doing some simple matrix operations or some mathematical operations, you can always, increase the brightness. It will be processing. Also, you can do multiple processings. You can increase the resolution. You can increase the brightness. So any of you, who is this? Very good. So you can see the difference between these two photographs, right? This is little bit darker, this is brighter. So by simple mathematics that you are studying, what mathematics I have used here? Addition. So I am simply adding a value to that existing image, right? So by using simple mathematics, you can do this image processing. So what I meant to say is that it's very easy for you to see. Here also we can increase the brightness of an image. Now we can increase the resolution. You can see here many things you cannot see, but here you can see very clearly, right? So again, you can increase the bands. You can combine multiple data. You can have drone images. You can have satellite data. You can use all these. Like I told you in border side, right? Border when you are using. So we are monitoring the border. We only have satellite data. So sometimes satellite data will not have that clear resolution. Then you can also use drone images. You can combine both. All these are possible. Yeah, so this is a doctor, but it is a robot doctor. So how can we make this robot doctor? AI, correct. So what is AI? Wow, so you know much better than me. So how to make this doctor? This is what we are going to see now. How we can make this doctor? Electronics, mechanics, all these are there. But how can you make the brain of that doctor? See, okay, mechanics, we made something like this, right? But whether it will be a doctor? Yeah, CPU, yes, CPU. But how the CPU is working? Yeah, leave all these things. If you go to a doctor, let's focus. If you go to a doctor and you suppose you are a doctor. So how you will give one medicine to a patient? By checking. What all things you will check? heartbeat, pulse, then BP, then temperature, yeah. Then what you will do? Sugar, yes. Yes, then what you will do? Okay, you checked all these things. Then what you will do? How you will suggest that medicine? By asking what problem, but you understood the problem. But then how you will suggest the medicine? You understood the symptoms, okay? You understood that he is having sugar high. Pardon? Very good. So from where it got into your memory? Brain. From where it came to your brain? Someone told learning. Who told learning? Very good, very good. Very good. By learning. So how you learned that? How the doctor learned that? Observing or some textbooks, right? He read some textbooks. He understood, right? He memorized. Clear? All of you understood this? So the doctor, when he suggested this is your medicine, he memorized. I mean, he tried to understand what you learned, correct? I mean, what he learned. I mean, what is the problem? If suppose a person is having this problem, this is the medicine I should give. So that means there is a set of rule, or there is a set of things that you should keep in your memory, so that you will feel like, okay, this is this is the medicine. Got it? Now you see, when you are talking, your teacher came in. So that was the medicine for the disturbance that you are doing in the class. Correct? So for each thing there is a medicine. So how are we, so that means there is a rule. So if the patient data or the patient is showing these symptoms, there is a rule. Okay, if the patient is having this, then give this medicine. So we can build a doctor. Like you told, we can CPU be the, we can have a memory, we can have a CPU, so we'll connect both the things. So in the memory we will store all these rules. Then whenever, the patient comes, the doctor will say that, okay, you have this symptom, then this is the medicine. Clear? So is that learning or is it memorizing? Memorizing. So is memorizing same as learning? How it is different? Okay, let us take an example. So when you are small kids, how you learn to distinguish apple from other fruits? Someone will show you an apple, they will say, beta, this is apple. Again they will show you another apple, they will say, this is also apple. Again they will show another apple, they will say, this is also apple. Again they will show another apple, they will say, this is also apple. Again they will show an orange, they will say, then you will say that, you fed up with this, you will say that this is also apple. Clear? Then they will say that, no, this is not apple. So you are being presented with the positive and negative samples of apple. See, someone is giving you apple as well as non-apples. So what are you doing actually? You are observing that fruit. Maybe based on its color, its smell, taste, shape, all these attributes you are understanding, that is apple. Clear? So in classrooms, sometimes some teachers will identify some students are problematic, right? How they will identify? They will talk in the class, then they will yell in the class, they may quarrel with their friends. All these are some of the properties of a bad student. I don't know that, it's just an example, okay? It's not necessarily bad. So same way you have, if I am giving you a jackfruit, all of you know jackfruit? How you will distinguish jackfruit from apple? Shape, size, weight, right? Colors, yeah. So recently I have seen some YouTube video shorts in that someone was saying like, doctor told me to eat one fruit. So I am eating one whole jackfruit. So one fruit a day. So that means one jackfruit. So we are distinguishing, fruits, one fruit from another based on our observations, right? So we try to correlate all these things. Okay, in your mind it is there like, okay, apple means it will be something like this. So rather than memorizing, we are correlating. Okay, if color is like this, shape is like this, color, this is like this, then this is apple. Correct? So that way learning happens. So when a new fruit comes, you will see how similar it is with that concept of apple that you have in your memory. Got it? So based on that you will say it is apple. Same way you extend the same principle to the doctor. Doctor learned something, he could now generalize it. So you learned what is apple based on maybe 10 samples of apple. But whenever you see a new fruit, you can say whether it is apple or not. So that is generalizability. So that means rather than having a rule-based doctor, our doctor should be able to generalize. Right? Whenever you come with a symptom which is not there in the book, he still will be able to give you medicine. Otherwise what will happen? Memorizing, what will happen? If you memorize, you will only see whatever written in the book. If anything outside comes, what will happen? You will not be able to answer it. Same way for exams, right? If you will memorize, you will not be able to answer the questions which are outside that. So same way, your doctor should be able to generalize things. So that is where we keep this as machine learning. Or I told you in the beginning, right, how my body learned to sleep by drinking water. That's a learning process. Same way, now you can distinguish, you can make even a computer to distinguish apple and non-apple by presenting it with, positive samples of apple, that means apples and non-apples. And we will tell that, that system. This is apple, this is not apple. This is apple, this is not apple. Finally, it will, like you are learning, the system will also learn whether it is apple or not. Same way, we can also train it to be a doctor, train it to be a soldier, train it to be anything. Clear? Now we will see one example of how we can make it, how we can train it to detect these images. So see, I told you in that Paramanu movie, they took a satellite image of our, of India, of that desert region where this was happening, right? So any of you watched this Paramanu movie? Yeah, our kids are not interested in movies. You are more interested in YouTube shorts or YouTube videos nowadays? Yes. See, there was a movie, a Paramanu movie, in that I will tell you I think we have time. Okay. I think I have to stop now. Okay. So our movie says like, they just observed, they have a satellite image. So they were checking whether we are doing some nuclear test. So they want to see that. So they will always take the photograph and check, right? So what we used to do, whenever during the night time or whenever the satellite coverage is not there, we used to quickly do all the tasks. Okay, then we will, see, same thing you will do, right? When teacher is not there, you will do all the mischiefs. When teacher is there, you will be, sitting very straight. Correct? So same way we also did. Whenever satellite is not looking us, we will do all the nuclear related work. Whenever satellite is there, we will be steady. So this way, we can analyze the satellite, they analyze the images and they will get to know whether we are doing some nuclear related works or not. So same way you can see this image. This image you can see and you can categorize it as, these different categories, like whether there is a corn there, whether there is a grass there, whether there are trees, and you can categorize it. So these are some applications of how you can automatically analyze the images. For that we will use same like we trained our doctor. We can train some models to see that how by presenting with samples of what is corn, what is not corn. Then it will be able to detect. So same way, see, all the time you are not getting trained right. So sometimes when I see here, I was not introduced to any of you, but I know that all of you belong to the same school. Why? Because we are wearing the same t-shirt. Correct. So that's a grouping that I am doing. So for this grouping, you may group people based on their age, their size or their color, color of the t-shirt or whatever. right? So this grouping doesn't need any training. So this is called unsupervised way of learning. For example, if I am giving you some fruits, you can just group them based on the color. That may not be always correct, but you can have different groups. So that way also we learn. So now, you all know the Google Maps. So from these satellite images, you can get the roads, you can understand which are the roads, which are the buildings. Now you are extracting the roads, right? Using that, like we train the doctor, we can train a computer to understand which are the roads. So you can see the roads, you can extract the buildings. You can have this type of a system, same like your Google Maps. If you search for restaurants, so what it will do is, if you are saying give me all the restaurants which are within 5 kilometers, so it will first extract out all the restaurants, then it will try to find out which restaurants are within that 5 kilometers. So all these are some of the applications of this so this one very important application, like some of you may have your house near to the river, right? So if the river floods, whether your house will be, at what level your house will get flooded. So those things also we can estimate using. Now you have seen this, right? The Chandrayaan rover, which went on there, which was moving there, collecting samples, correct? So if in a nutshell, an overview, if I will give, it was automatically moving. I told you if it needs to move, it needs to be intelligent, right? I am not sure whether this was the principle that they used, but usually how we can make a machine to move automatically. See, when I am walking like this, I didn't stuck here, right? I mean, I didn't stuck here. I moved this way. So I know which way to move, how to move, avoiding the obstacles. So how a machine will learn how to avoid obstacles? See, for this also we'll take an example. So one way you learned is like someone give you apple, said that whether it is apple or not. Another way was like you grouped everything without any knowledge, right? There is another way which you learned, how when some guests will come in, if you will talk unnecessarily or if you will shout, you will get either beatings or pinching or something. Then next time when guests will come, whether you will shout. Whether you will shout? No. In classrooms also, whether nowadays I think we are not beating, right? We are not there. So earlier in our time, if we will shout during the classrooms or we will do something, there will be a stick with the teacher. They used to beat us. So so then what we will understand is like so what we will understand is like if we talk like this, we will get beaten up. So this is called self-supervised learning, or you are learning yourself based on some rewards. Sometimes if you do some good thing, parents will give you chocolates, right? So you will get rewards, positive or negative rewards, sometimes beating, sometimes chocolates. So what you will do is you will do things more frequently that you will get more chocolates. You will not do things by which you will get beating. Okay? So this is how you learn things. That is how even a rover tries to move around. So that means you can see here the red blocks. They indicate the places where you should not move. So slowly after each iteration, it will learn how to avoid such obstacles and how to move forward. Okay. So and also last thing, you all have used the apps, right? How you will look like if after 50 years or after 30 years, or how you will look like if you were a girl or a boy. You may have seen some apps, correct? So that apps, same apps, that they are like simulations, okay? They are like, generating the data. So such apps, such things also you can do using machine learning. So all these are, some of the, with this like type of self-supervised learning, how you can, create this type of videos or this type of games. This is a very important, but how you can see when this is the yeah, I'm just stopping with this. So just see that, these are some of the examples of, these are some work by some of my students. So you can see that how this reward, like I told you, when you do good things, you will get chocolates. When you do bad things, you will get beaten up. So same way here, when you do bad things, you will fall in that lake. When you do good things, you will move till the call. So same way you will learn. So same way you have snake play game. All these students have done. They used this technique. So you can see that automatically system is learning, right? So you are learning something. So like your doctor, like your, like you learn to distinguish fruits. So same way here also system is learning. Okay. So I hope I have confused you a bit. So now I'll conclude. Like behind all these things is mathematics. So please, mathematics is not a boring subject at all. You can do a lot of wonderful things with mathematics. So please try to correlate mathematics whenever you are learning. Even addition, I told you, right? With a simple addition, you can increase the brightness of an image. So please try to take it as a very interesting subject. Talk to people of what they are doing, how they are using maths. And with that, I will, conclude my talk. Once again, thank you, and sorry for boring you with a lot of information. I understand it's a very diverse audience. So when you grow up slowly, I'll share the PPT now. You can keep it slowly. When you will grow, you will understand this PPT in different levels. Okay. So at any stage of your growth, you can definitely contact me. Thank you once again, all of you. I'm really privileged to be a part of this, Space Day celebration. Once again, thanking you.
Thank you, sir, for the wonderful session. Now it's time to felicitate the esteemed speaker of this session, Dr. Arun TV. I would like to call upon Dr. Untasalapati, Principal Sitams, and Mr. Harikrishna GM, SMPC Shah, to felicitate the guest. First to Shah. Thank you, sir. Now, vote of thanks. It's my honor and privilege to extend a heartfelt vote of thanks to Dr. Arun TV for the insightful and thought-provoking session on artificial intelligence and its application in space technology. The talk was not only intellectually stimulating, but also incredibly inspiring. Your deep knowledge, real-world examples, and forward-looking perspective have opened our eyes to the possibilities that lie ahead at the intersection of AI and space science. On behalf of ISRO, Sitams, and NARL, and all the participants here today, I extend our sincere gratitude for taking the time to share your expertise with us. Thank you. Thank you, sir. End of session. Just now take a break for 10 minutes. Of course, almost end of session. It is left in break. Faculty members need to stay here itself. Students can leave. After 10 minutes, there will be a talk.
Okay, 7th, 8th, 9th. That's all. Okay, 10th, like board exams, and 11th, 12th are too big students to come here, right? Okay, no problem. Point taken. So thanks for coming. But this is the age, where you develop your curiosity, right? I understand, the moment you hit 10th standard, curiosity, takes a significant backseat. You would be only left talking about board exams, research, this, that, etc. Okay. So let me tell you, during that time, right, when the onus will be on scoring marks and performing well, you will be expected to think fast. But during this time, right, think slowly, think deeply, and note down all the questions you have. Okay, right? You will be having lots of questions at this stage, right? And I'm sure that you may not be getting satisfactory answers. Okay, but note down these questions. Okay. Sometimes, throughout your lifetime, you may not be getting a satisfactory answer. Okay. Be okay with that. Be okay with that. But note down all the questions you have. Okay, right? At the age of approximately, 12, 13, enjoy life and note down all the questions. So, how many of you are aware of, what is physics, chemistry, biology, and mathematics? Do you guys know what these things are? What are they? Somebody? You may just stand there and see, I won't let you sleep, okay? Right? I can't sleep, right? So why should you sleep alone? Okay. So I'll be asking you questions. So please. That's coming up. That's a surprise. Okay, yeah. Pehle, pushtash karenge. Then, yeah. So folks, tell me, what is physics? Have you heard these words before? Have you heard these words? Yeah, what are they? What is physics? It's okay to say whatever comes to your mind. Physics is a boring subject that, that is in my textbook. That's a perfectly legitimate answer, right? You can say it. Come on, folks, somebody. Hey, open up. Okay, I will be having lots of quizzes. If you give me the right answer, I'll give you a dairy milk. Okay. So, I mean it. So please answer. Anybody out there? Hello? Okay, I won't stop, asking questions there, okay? So physics is one branch of science. Chemistry is another one. Biology, of course, is one more branch of science. And mathematics is all pervasive, which connects all the three branches. And all of them, right? And all four of these facets are deeply connected with space science. So what is space science? At least that. We are here, right, to celebrate the National Science Day in advance. So what is space science? The science of space, or the space of science. Something like the science of space, right? So what is the science of space? Well, it is basically all these four subjects, okay, right? So don't worry if you don't understand anything, okay? Just try to answer, okay? In fact, let me tell you, one of the biggest skill sets, as students that you should be getting is how to deal with any situation when you have no idea about it, okay? So even if you don't have any idea about an answer, how would you start thinking, right? So don't worry about the final answer, but think about what process is going to get you towards the answer, okay? That's something very, very important. And that is, in fact, the deepest idea behind what is called as the philosophy of science itself, okay? So please think about how do you answer these things, all right? Okay, now forget that. I have a picture out there, right? What is that? Something, right? Yeah. So because I'm going to be talking about space, I've given this black image. Now why have I kept it black? Why not like yellow? Why not green? Why is space black? If space is black, why is it black? Have you thought about it? No sunlight. Excellent, ma'am. Why no sunlight there? That's a question, right? No, it's a fair point, ma'am. No, it's a fantastic start, ma'am. Okay, but just to students, okay, especially, this is how you think, okay, right? Every time you think you give an answer, right? Don't be happy with it, okay, right? By the way, don't employ this trick on your teachers in school. They don't have the time, okay? They have to finish the syllabus. That's important. However, when you think about, actually how to learn things, this is the way to think about it, okay? Don't be happy with the answers you've been given, all right? Huh? So, this is space. Why is space black? Any idea? What's behind it? Is it completely black, or or you can, depending on the resolution, yeah, We had this machine learning talk before this, right, where he was talking about pixelation and all. So perhaps if the resolution is good enough, you could see some dots over there, right? So why is it dark in the first place? And why do you have some dots over there? Stars, exactly. But why are stars colorful? Thank you. Yeah. Why are stars colorful and space black? Colorful as in like they radiate, they give out sunlight, right? Why? Why? Okay, note it down, okay, note down all the questions I ask you, okay, right? You may like take it as a homework, but without any responsibility to do the homework, okay? It's a happy homework, alright? So please note it down, okay? Number 1, why is space black, right? Number 2, why is it that, the star alone appears shiny, right? I'm not going to give an answer now, because I want you to figure out, okay, right? And if you figure out, and once you figure out, you will be getting more questions from that, alright? And this is how the enquiry of science begins, okay? Now, before I actually go to the content of my topic, I am from ISRO Tirupati. Wherever I go, I get lots of queries about ISRO and ISRO Tirupati, okay? So this is our campus. Do you know where is ISRO Tirupati? Have you heard about ISRO Tirupati? No, right? Excellent, okay, yeah. So ISRO Tirupati is an educational institution exclusively for the study of science. Okay, we're talking about the fundamental sciences, math, physics, chemistry, biology, and earth sciences, etc., etc. Okay, right? Now, how many of you know about IITs? IIT, okay, yeah. Thanks, ma'am, yeah. Okay, yeah. So you all know about IITs, right? Yeah. So it's equivalent to IIT, okay, right? See, don't worry about these are, you may just think of them as like, like good colleges, okay, right? So these are good colleges, and how to be joined there as a student, right? How to join there as a student, I'll come to that very soon, okay? So this is our campus. It's right, of course, the whole area is beautiful, beautiful hills. So right next to the, these are the Eastern Ghats, and you have, I'm just showing 2 buildings. And this is a library building, not a high resolution picture. And we have engraved the name of very famous scientists, and also, contributions from Indian science, genuine contributions from Indian science, as well as, these are the periodic table of elements. So we have a beautiful campus. You can come visit us sometime. Tell your teachers, on Science Day, we have an open day. So please, the students are all welcome to come to our campus. So this is ISRO campus. And of course, what do you do in a campus? You majorly play, and sometimes you work, right? Okay, right? So that facility is also there. So you can, you have outstanding sports facilities. Of course, the mess, eating is also important, but I didn't include it. So you have great lab facilities, etc., etc. So please join for that also. The next one is, yeah. So these are the various programs at ISRO Tirupati. Okay, right? Yeah. And we have a 5-year BSMS program, which is for the students of your age, predominantly for your age people. So what you do is, you can gain entry into the program by appearing in a national level entrance test. You're too young, okay? The moment, you come to your 10th standard or something, your parents will start putting you in coaching centers, okay, right? For various exams. Now, one of these exams is going to be what is called as the ISRO aptitude test. So you can write this test and come to ISRO. That's the first thing. The second thing is, there's something called as 2-year MSR students. If for the students of collegiate students, anybody has come back, or okay, for the collegiate students, after your 3-year BSc, you can gain entrance to our college, to our institution, with this program called as Masters by Research. And then we also have for working professionals, for the teachers also who are especially interested in learning about data science and biological data science, machine learning, etc. The previous talk was about that, right? If you want to actually gain some knowledge about it, we have a program exclusively for working professionals. So this is called as the Masters program, and the application for this program is still open, and it closes only in about, let's say, August 10th. So there is still some time. So for the senior pros over here, if you are interested, this might be of help. And of course, we also have a PhD program where this is for people who want to do advanced degree beyond your what? You study like 10th, 12th, you go to 15th, 16th, 17th, 18th. If you want to still study, right, your 22nd, 23rd and all that, you can still pursue it in your PhD, okay, right? So these are the various options available to you. Alright, so having said this, finally, what do I do? Let's like, I think Shivansh already introduced, but these are my areas of research. It's not updated at all. It is all from, like a decade ago in fact, okay. But I work some research. This was my PhD student, this is a collaborator, and I'm very much interested in scientific education also. So this is just what I do. And about this talk, yes, this is important. Like I said, I intend this talk to be interactive. What is the meaning of interactive? Yeah, interactive is not, like what's been happening so far, okay? It's not like I talk and you sleep, okay? Right? It should be, like I talk, you talk also. Not between you two, but with me. Alright? So that's how I want it to be. Please focus on that, okay? And of course, I'll be asking a lot of questions. I've already, like set the tempo. So I believe that you will be having a lot of questions. But there should be some perk for answering a question, right? So I didn't get the perk, so you get only a dairy milk, okay? Right? So please answer the questions. Okay, fine. Oh wow, so you have like double gifts. Awesome, I didn't know this, yeah. Okay, yeah. Okay, I thought you knew my plan. So it's awesome, okay. So they have their gift and I have my gift too. So you'll be lucky, right? So please, it's your birthday, okay. So please grab this opportunity. And of course, I must say this. So for this talk, I have used a lot of material from the internet, and some of them could be like copyrighted. I want to tell that like this talk is only for educational purpose with no commercial gain. So this is also an important aspect. Please note this. Okay, so let's begin. Now, the first quiz. Who is this guy or this person? How many of you know that you can even Google, okay? Google Lens. Is there data in this room? Are you allowed to have your cell phones here? Who is this person? Who is this person? And I'll tell you why I put this picture. See, you may ask, at least if I put my picture, it will be of some use. Why am I putting his picture? You're almost there, ma'am. Yeah. Think another name. Think another name, yeah. Who is this person? Oh, Google is giving the wrong answer, ma'am. Yeah. Is this Satyendranath Bose? Or like, okay. Yeah. Who said? Thank you, ma'am. You get the first chocolate. See, your teachers are getting. What about the students? Thank you. So, hey, you should not simply clap. You should also get it, right? Thank you, ma'am. Yeah. For the students especially, okay? Yeah. So the point is, this is Meghnad Saha. Who is this Meghnad Saha? Write down the names, okay? Write down the name. Why am I talking about this person who apparently has no connection with any of our lives? I'll tell you the story, okay? Right? The point is, he came up with this equation. This equation is called what? This is an easy one. Now that you know the name, and I've given an equation, what is this equation called? This guy's name is Saha. And right next to this face, I have an equation. Thank you, sir. This is Saha equation, okay? It's simple, right? Yeah. See, so many times, right? Intuition helps, okay? See, for example, I do something, right? And then an equation is right next to it. I'm going to call it Raghu equation. Okay, right? Similarly, this is Professor Saha, Meghnad Saha, and right next to it is some equation, okay? Don't worry. In fact, if you're in the 9th standard, you may not even understand some of these terms, okay? Don't worry about it at all. It doesn't even matter. But what matters is that there is this person and there is an equation after his name. Okay, right? And what's the key point to note? This person is from India. This person is from India. He was born in undivided India and he was a scientist in India. He was also a politician in India. Okay, right? A very inspirational figure. Somebody, how many scientists can you think of, who are also like top-notch politicians? A member of parliament, right? He was all of this at once, okay? And his contribution to space science is amazing, okay? Now let me ask you one more question. There are so many scientists, right? So many scientists also from India. But why do you think I put this person's name? And to connect physics with space science, I could have used so many examples. Why do you think I this person's face? I'll give you a hint, okay? what is the theme of this space day? What is the theme of this space day? You can see it right there. I can see it, but maybe you have to turn back and see. What's it? Aryabhatta to Gaganyaan, right? So the Indian connection has to be very strong. Okay, so in connection with the theme of this meeting, I've had an Indian scientist. Okay, I'm sorry. I'll not fall, but yeah, I won't trouble that too. Thank you. Alright, so this is Professor Meghnad Saha, and an important, like classwork, if you could call it. Google about this person, okay? Google or do Wikipedia search about this person. How many of you have your phones with you? You don't have your phone? Yeah, the faculty, the teachers, of course, yes, the students. You're not allowed to, right? And you're all good students, so you don't sneak your phone inside, right? Okay, yeah. So the point is, what he did was something remarkable, and we'll come back to that. We'll come back to that in just a bit. Okay. Now, what is equation? This is like, sorry. Oops. How do I go back? Wait, how do I go back? Thank you. So, this person, came up with this thing called a Saha equation. Now, at 9th standard, you may be wondering, the math may be way above your head, okay? Don't worry about all of that. But the point to note is, what he did was, he came up with a physics equation, right? What is physics? It is whatever you study in your textbook, your F equals ma, and then like your P equals mv, and your what? S equals ut plus half at square. Do you understand what I'm talking about? Right? Huh? So all those things, okay, like that, he developed some equation, right? He developed some equation, and that is used for what? The equation developed by an Indian, okay, by an Indian scientist, right, is used globally to understand, what the temperatures of stars are. Okay, imagine, right? See, is the sun a star? Is our sun a star? Yes. Is the sun the only star? Right, there are twinkle, twinkle, little stars, big stars, superstars, so many are there, right? Okay, huh? So there are so many stars out there, near, far, and wherever beyond, okay, right, yeah. You have all these like stars, okay, right? Now, the temperatures of all these stars could be obtained from this person's equation. Isn't it amazing? Sitting on Earth, right? We can get the temperatures of the stars, right? That's point number one. And not just that. You must have all heard about, what is it, black hole. You've all heard about a black hole? What's a black hole? What's a black hole? Whatever comes to your mind. Students, what's a black hole? You said something, yeah. Just continue with it. Sorry? Attracts everything inside it, right? Excellent, yeah. That is amazing. Ma'am, can you please pass it along to that student? What's your name? Huh? Ishwet, thank you Ishwet. So Ishwet gets the first student chocolate, okay? A big round of applause for her. So, the point to note is that a black hole is something, it's an object in space which deeply, attracts everything to itself. At this level, that suffices, okay? So, the point is, this person, right, he was helpful in understanding that. So, for a lot of black holes, okay, in a lot of black holes, what kind of the pull, okay, right, although it is not in this particular slide, okay, right, it is useful to understand the evolution of a star. Eventually everything must have been a star, okay. From a star to a black hole, the evolution path could also be obtained from the Saha equation, okay, right. So, imagine from Earth, right, he was also born in a poor family, okay, he was not from a very rich family or an aristocratic family, etc., with a traditional scientific knowledge, blah, blah, nothing like that. From a regular poor family, this person could do so much, okay. So, he is an inspiration for all of us, okay, right. So, he was born in West Bengal, by the way, okay. So many applications from physics. And by the way, how did I get all this information? From Google AI, yeah, it's written right here, okay, right. Why do I put this? Because as students, you can also get a lot of information from AI, okay, ChatGPT. Don't just use it for, like sending emojis to your friends, okay, right, or like creating Instagram reels, okay, even though you may be a bit young for that, okay, right. Don't just use it for that purpose, but also for, getting information, alright. And always cite your information, because if the information is wrong, you can always blame it on the source, okay. Alright, so let's look about, I told you, right, that the Saha equation is something remarkable, etc., etc. Now I'm going to ask you something very important, okay, which is that, see, we all know the sun, right? S-U-N, okay, right? So we know the sun. Now, what is inside the sun? Can somebody answer what is there as part of the sun? What's lava? I know lava ice cream, chocolate lava. But what is lava? What is inside the sun? Molten. Yeah, I heard the phrase molten. What's molten? Hey, the boys are very silent. Come on, yeah. Molten what? Molten mass of what? What is magma? Magnum, I know. Again, the ice cream. Okay, yeah. What is magma? Huh? So what does the sun contain? Have you thought about it? See, the sun, right? We know the sun gives us light, the sun gives us, energy and all that. But what does the sun contain? Heat. Helium. Excellent. Okay. Outstanding. Okay. You get 2 chocolates for this, man. Yeah. What's your name? Sorry? What, Prasad? Dashwin Prasad. Thank you. Oh, you're from Edify. Edify Tirupati. Oh, Edify has multiple branches, is it? Oh, excellent. I know one in Tiruchanur. Okay. Okay. So the sun contains helium. What is helium, man? You know what helium is? It's a gas, right? Excellent. Okay, it's some gas. Okay, right? Now, how do you know the sun contains helium? Did you go and see? Did Dashwin Prasad go and see? Can you go there and see it? What will happen? You will be part of the sun, okay? Yeah. Alright, so the point is, sitting on earth, right? Sitting or standing on earth, how did you know that? How did you actually ever get to know that? The sun contains helium. How do you know? Sorry, by? Yeah, I heard you first, yeah. Raise your voice. Networks. What network? Which television? Inadu or like which TV? Sakshi? Which TV? Sorry? Satellite. Okay, how will satellites tell you? That's an outstanding answer, yeah. How will satellites tell you? What signal? Excellent. These are all outstanding answers, okay, but I'll get back to you. I'll tell you why I'm not giving you the chocolate yet, okay? Hang on. These are all great answers. Temperature, excellent. See, I received, outstanding. See, this is how you start thinking, okay, right? See, science is the process of going from the known to the unknown, okay? So if you want to, go towards the unknown, what should you start from? Something you know, right? And what do you know? You know that the sun contains light, okay, right? You talk about what? Signal, right? You say satellite network, excellent. This is about what you know. That is exactly what it was done, except that back in the day when it was actually, right, back in the 1900s, okay? This is what? This is 2025, right? Approximately 125 years ago. Approximately 125 years ago, or a bit earlier also. We're talking about mid-1800s in fact, okay? When all of this was done, were there satellites? No TV, right? Yeah, you can't watch the cricket match live, you can't watch anything, right? Yeah, no IPL, no nothing, okay, right? So back in the day, back in the day, you needed to have some version of a satellite, right? Some version of a satellite, some version of a signal, right? So I will tell you what that is, okay, right? Now, does the sun emit light or not? Yes. How do you know? You observe, right? It's as simple as that, okay? See, the answers are simple, it's not hard, okay? Now, why does the sun emit light? The sun emits light because something is burning in there, okay, at the high school level, okay? Something is burning. Now, what is that burning thing? It's a burning mass. Burning mass of what? Something. Like, for example, just one said, right? Yeah, helium, okay, right? Now, when it burns, okay, it emits light. This is according to what is called as the principle of thermodynamics. Just get to know the name, don't worry about the details, okay, right? So, when something burns, it emits light, okay? It emits energy, this energy is in the form of light, okay? Now, we get, like light from the sun, right? Now, how do you see, what does this instrument look like? A chocolate for this. What does this instrument look like? A telescope, right? Who answered that? Okay, ma'am, thank you. Yeah. What's your name? Thank you, ma'am. Yeah, this is for you. Yeah. The point is, a sun emits light. Okay, when the sun emits light, you can magnify it, right? You can, you can, when the light rays hit the aperture of the lens, right? You can get magnified images, right? So using telescope, you can see faraway objects, all right? So this person, I don't expect you to know his name. His name is Fraunhofer. Fraunhofer, he was a German scientist, okay, right? Not exactly a scientist, he was an optician actually. So this person, right, he combined a telescope, okay, he combined a telescope with something called as a prism. Now what does a prism do? What does a prism do? Splits the light, right? Yeah. So what is it? So students. So how does it split the light? There's so much physics behind it, okay, right? How it splits the light, right, can be explained at your class level. It can be done at college level. It can also be done at PhD level, okay, right? There are so many explanations for it. But the point is, in general, when a beam of light hits the prism, right, what is the prism made of? Excellent, okay, yes, it splits light, okay, and that's how you get these lines, okay. So he combined a telescope with a prism, okay, combined a telescope with a prism and added something also, something else called as a grating element, okay. This is above your level, but don't worry about it. So yeah, he included three things: a telescope to view faraway objects, okay, point number one, a telescope to view faraway objects, and a prism to get the light from the sunlight and to split it into different colors, point number two. And the next thing he did was, he also included, a grating element to get these lines with good resolution, okay. This you study about it in your 11th or 12th standard, okay, about this principle called as diffraction. Have you heard about the word diffraction? No, yeah, you're probably too young for that, okay, don't worry about it. So he used these three elements, and what he obtained was, see, the sun's light was split into 7 colors, like you say, okay, right? This is like VABGAOR, VIBGR, right? In this direction. So you get all these colors, you get all these different colors, okay. But the beauty is that, along with this, he obtained a lot of dark lines. Can you imagine, the sun gives us light, right? But when you split it, into different colors, it actually also gives us dark lines. Can you imagine this even? It's startling, right? In fact, the sun gives us light, which is the opposite of darkness. We all keep saying that, right? Yeah. The sun is, it's the opposite of darkness. But from the sun's lines itself, we get a lot of dark colors over here. Is it fine, folks? Do you understand the point, right? So from the sun, Fraunhofer, right, obtained a lot of dark lines. And by the way, this is what is called as the visible region, okay, the things that you can perceive with your eyes. There are like regions, the sun emits radiation, which is way beyond I would say, the aperture of, like the length of your eyes, okay, right? So you cannot see them. But within what is called as the visible region, right, he observed dark lines. Now isn't it fascinating? You wouldn't expect the sun to be dark lines, right? Now these dark lines, right, these dark lines, if you think about it, they happen to be precisely coming at one specific wavelength location. Do you know what a wavelength is? What's a wavelength? Wavelength, 9th standard students perhaps, what's a wavelength? Wavelength. Heard about the phrase? Don't worry about it, okay, don't worry, okay. So the point is, just note down, okay. Just like for your, when you're bored, right, instead of looking at YouTube shorts, just look at like what a wavelength is, okay, right? Alright, so there were well defined, precise lines from the sun, okay. This was all obtained. Now based on that, remarkably, let's say you have a bulb, okay, you have a bulb at home, right? Light bulb, you also have this yellow color light, right, like with a tungsten filament. Have you seen those bulbs? Maybe not in this generation, but maybe you do, okay, yeah. So you have this like yellow colored bulb also, right? Yeah. Now that thing, people compared, the collection of this color, the VIBGR thing, right? The collection of that, which is called as a spectrum, technically, they compared the things obtained from sun with what is obtained from a bulb, okay? And what they noticed was, the lines are coming, okay, the dark lines are coming at exactly the same spot. Do you understand what I said? You have the sun, okay? From the sun, you use a telescope and a prism, right? to get this sequence of colors and the lines at some well-defined locations. This is part 1. Part 2, in an unrelated thing, you have a light bulb. Okay, you have a light bulb, and you can either have a light bulb or a flame. See, back in the day, a light bulb may not be there. So from a flame, okay, right? See, the sun emits a light because something is burning over there. In a flame also, something is burning, right? So you observe the series of colors from a flame. They notice that the same things are, the same dark lines are present, okay? The same dark lines are present in the exact same location. Do you understand what I'm saying? What does it mean? The same dark lines are present in the same location, right? When you like get these colors from the flame, and the same pattern is obtained from the sun also. What can you conclude from this? What do you think you can conclude from this? Yes, ma'am. Yeah. Yeah, the frequency is same, which means when the frequency is same, yeah, what is causing the frequency is also the same, right? Thank you, ma'am. And what's your name, ma'am? Thank you. Yeah. So the point is, when the line location is the same, okay, right? See, it is like something is happening from the sun, okay, right? The same thing you get, from something known on Earth. What does it tell you? It tells you that, hey, the same material that is present on Earth is present in the sun also. Are you clear? Okay, right? That is how we came to know that, oh, the sun is not this mysterious, mythical entity. It is not something mysterious. It just contains, the same thing that's present on Earth. All right. For example, hydrogen, predominantly hydrogen and helium, and some amount of metals, your potassium, sodium, titanium, etc., etc. Okay, these are all elements. Are we good? What I want to convey through this is, see, using simple, I don't want to use the word experiments, simple curiosity-driven ideas, right? You can figure out what is present in the sun, which is something remarkable, right? Sitting from here, how will you know what the sun contains, right? How do you know? You basically understand what is the, you observe, like the line pattern from sun. This comes due to what is called as light matter interaction. Okay, right? This is what happens. Now the same thing happens on Earth also, which means that whatever is present on Earth is also present in the sun. Are we clear? Right? I don't expect you to understand the details, but do you get the bigger picture? Can somebody tell me precisely what I said now? Is your understanding? It's like you're watching a movie, okay, and somebody asks you to, tell me what happened in this scene. Can you summarize it? So that I know that you understand what's happening. Some student. Can somebody say it? Hey, a chocolate is at stake. What's that? A dairy milk is at stake. If you don't answer, I'll take all of them and I'll eat myself. Yeah. So what's at stake? Come on, somebody. It's okay, it's okay. The person who answers will be getting a chocolate irrespective of what answer is given. Student, somebody, yeah. May I pick? Hello? No. Yeah, but they shouldn't be embarrassed, ma'am. Yeah, if it's okay, yeah. May I pick someone? Do you understand the question first? The question is, right? How did people come to the conclusion that whatever is present in the sun, right, is what is present on Earth also? How did? Anybody? Just summarize in your own words. You can also say it in Telugu. Language is not a barrier, okay? Telugu, Hindi, English, whatever, right? Yeah. If you know Kannada, go ahead. I won't understand what you say, but you'll be getting the chocolate because I presume what you say is right. Anybody? Yes, sir. What's your name? Huh? Arif. Yeah, please, Arif. Yeah.
Water.
Water. What about water? Sorry? You understood the question? Yeah, what's your name? Geet. Heat. Okay, so what about heat? Yeah, okay, excellent. Yeah, so the point is, they performed two experiments, okay? One, they got the colors from the sun. They saw black lines and some spot, point number one. Now, on Earth, right, they, let's say they had a flame, a burning flame. From that they obtained the colors, right? They saw the black lines in the same spot. Therefore, they concluded that what is present in the flame should also be present in the sun. Okay, I'm saying it again. Many of you, like nodded your heads, right? Now summarize it. What's happening? Yeah. Yes, sir. What's your name? Sai, please. Yeah. You can take the mic, yeah.
Helium is burning in sun, sir. Now flame is also burning, sir. What we observe in that sun, it will get in that flame also, sir.
Excellent. Okay, the same thing. Exactly. Okay, thank you so much. Okay, that's what I'm saying. Okay, yeah. So it is not just helium, but in this case, it's a lot of. It's not just helium. Okay, right? It's a lot of other metals also. In fact, helium is a special story. Okay, right? Story. The special story about helium is that, see, what would you expect if we have to know what is present in the sun, we have to know that it is there on the earth, right? Because we see it on the earth. Okay, that's when we know what is there on the earth, right? But with helium, something super special happened. Helium, they first obtained such lines, okay, right, from the sun. They didn't know what this was on earth. So it was first discovered in the sun, and only then they came to know that, oh, this is also existing on earth. Okay, so the point is, it's not just a one-way traffic. By by studying what is available on earth, you get to know what is available in the sun. From what is available on sun, right, you also get to know what we have on earth. Okay, so it's a two-way traffic. Are we clear? So this is the beauty. Okay, now you may ask me, I mean, this whole slide in which I spent a good amount of time, it has no relevance to the Saha equation. Okay, right? Why did I show his face in the previous slide and this one? If you're watching the movie, right, between any two scenes, there should be some connection, right? Otherwise, you'll be like, what a waste movie it is, right? Yeah. Now, see, I will tell you the problem. The problem is as follows. Now, people knew that what is present on Earth, okay, what is present on Earth, the same thing is also present in the sun. Alright. But then, it's okay, things are there. Let's say, for example, somebody eats 1 chocolate versus 10 chocolates. Both have eaten chocolate, but the amount is varying, right? Huh? So what, by 1900s, what people were thinking is that, okay, the sun has the same elements as Earth, your helium, hydrogen, etc., all fine. But they came to the conclusion that the amount of helium present on Earth, the amount of hydrogen present on Earth, for example, your air contains what, 78% nitrogen, some 20% oxygen, and then the rest, blah blah, something like that, right? Yeah, right? Same composition, right? The same composition is what is present in the sun also. So what's the point? The point is, look at the title. You can have the right data, but you can always come to the wrong conclusion. Okay, right? This is another facet. So how did people come out of this? How did people actually come out of this aspect? Well, this lady here, okay, her name is Cecilia Payne, okay, right? She was, I'll tell you the importance, okay, right? See, this was 100 years ago. There were not many female scientists, okay, right? But she was a pioneer. She was from the US in the Harvard University, okay, and what she did was, she used this equation. She used this equation obtained by Saha and proved that, hey, of course, we agree that what is present on Earth, right, is also present in the sun. However, the quantities are not the same. Okay, right? And that is what this lady did. Okay. But notice the point. What did Saha do? Saha came up with an equation. Saha did not know that his equation could be used to, understand the composition of the sun itself. Right? That had to be done by somebody else. And look at the diversity. Where was Saha from? Saha was from West Bengal, India. Where was this lady from? This lady is from Cambridge, Boston, USA. Okay, right? What's the connection, right? So another point I want to tell you is that science is a collaborative and international expertise. Okay, it transcends beyond border. It is also helpful, within the border also. It really helps you, forge a lot of networks, etc. Are we clear? And one more thing I want to tell you. When this lady first proposed this, her idea was not accepted. It met with resistance. It was like, could it be meaningful? It could not be meaningful, okay? So don't worry about always conforming to the tradition and knowledge of this particular day. Think beyond, okay? Think beyond, and as long as, you have valid logic backing up what you say, right? You need not, worry about what others say. Okay, right? That is one more lesson for some of you young students. So that is what she did. So what is the point here? The point is given in the title of the slide. Sorry, oops. The point is given in the title of the slide. What's the time, by the way, sir? Yeah, the point is given in the title of the slide. Physics which was developed independent of space science. 110, right? Yeah, thank you. Yeah, I'll do it. Yeah. So physics, which was developed independent of space science, right, brings about a new change in astronomical sciences. Okay. So you would think, oh, this is physics. This is some equation. This is what you see in your textbook. But what you see in your textbook is what is actually applicable in not just daily life, but also way beyond in the science of space, etc., etc. Okay. I want to convey this information from this slide. The rest of it I thought would be useful for college students, but as for school students, ignore it. Happily enjoy just the title. Okay. Now, let's actually think about some chemistry. So far, this was physics, okay, right? Oh, the sun, temperature, equation, and all that. Let's think about some chemistry, okay? I want to ask you a question. Right next to you, okay, right? Do you understand the idea of volume? What is volume? Excellent. Okay, that's one understanding. What is the other volume? What is the volume of a cube? Formula for volume of a cube? Huh? S into? That is what? What is S? Huh? S into S into S, right? Yeah, excellent. What's your name? Nanda Kishore, thank you. His volume is S into S into S. In other words, what I mean by volume is, thank you. Can you please pass it along to him? Thank you. So volume is nothing but the amount, okay, the amount that could be enclosed within some space. Okay, right? Now, what is the unit of the size? What is the unit of size? You said no size something, right? What is the unit of it? In what units can it be measured? I heard the word meter from somewhere. Thank you. Yes, meter. Meter is there, centimeter, decimeter, all those things, right? Exactly. So, thank you. What's your name? Siddharth. Which class are you from? Oh, 12th. Okay, excellent. Thank you. Siddharth. So the point is, your size could be measured in terms of like a centimeter, right? If it's volume, like I think Nanda Kishore said, right? Your name is Nanda Kishore, right? Yeah, like Nanda Kishore said, if you're talking about volume, it is like centimeter times centimeter times centimeter. Okay, right? So centimeter times is multiplied by centimeter is what? Centimeter square. Now centimeter square multiplied by another centimeter is what? Centimeter cube. Okay, right? So that is 1 cubic centimeter. Now can you imagine what a cubic centimeter is with your hand? How much do you think it's like? Can you have an idea of what a centimeter is? Is this a centimeter? Is this a centimeter? What's a centimeter? It's very important, okay, see, develop these skill sets, okay, to have a feel. See, you may ask me, if I ask you, what a centimeter is, right, you may ask me to give you a scale, point number 1, right, okay, and you'll measure 0 to 1, 1 to 2. Now, the same thing, can you use your hand to kind of guess what a centimeter is? How much is a centimeter? No, yeah. In terms of feel, like in terms of feel, is this a centimeter approximately, can I say? Okay, then how much is it? This much? No for that also, then how much? How much? Yes, you got it right, okay. The point is, thank you. What's your name? Ivan? Thank you, Ivan Bharati, okay. Let me just check, if I have, I don't think I brought enough thing. Can you give him, can you give him a gift, yeah. Thank you, Ivan. Yeah. Hey, that's not a chocolate, okay. Yeah, it's a keychain. Alright, so the point to note is, a centimeter is approximately this much, okay. Now a centimeter cube is, imagine, this multiplied along all directions, this and this. It's a small box, toing. It's a small box, okay, right? That is 1 centimeter cube. If I were to ask you, how many of you know what molecules are? Hey, 9th standard you study about molecules, right? How many molecules will be there in this 1 centimeter cube space? A 12th standard student especially, yeah. How many molecules will be there in 1 centimeter cube of space? Alak Avogadro, excellent start, okay. Have you all heard about Avogadro number? Wait, that's a start, okay, yeah. That's not the answer. That's a good guess. How do you say this? No, that's a number, but what is the logic for saying that? What's your thought process when you answer this? They just told in the class, but that's, yeah, it's a big number, okay, it's some big number. The number is close to Avogadro, okay, but you want to, that's a good guess. But if you want to get the exact number, how will you do that? Have you studied the equation PV equals nRT? Have you? I mean, do you know about the ideal gas law, the 9th standard students? No, right? Don't worry about it. So, as you go to your 10th or 11th standard, be studying something called as the ideal gas law. Okay, right? And from that, what I ask for? I have asked for n effectively. So, when I ask for like some molecules right next to you, okay, right, in 1 centimeter cube of space, right, you know the pressure. What is the pressure? What is pressure in this room? Forget the teacher pressure, school pressure and all. What is the pressure in this room? What is the pressure exerted by the column of air in this room? Yeah, but what is the value? You guys should think about in terms of that. Okay, what is it? Exactly. Okay, see the 12th standard, yeah, the thing is unfortunately, you have to go to a bit higher standards to appreciate the concept, okay. It's what called as 1 atmosphere of pressure, okay, right. So, with 1 atmosphere of pressure, right, you can use an equation which is called as the ideal gas equation, okay, right, you can use the equation called as the ideal gas equation to calculate how many molecules are there right next to you, right next to you in this small space. It happens to be approximately a little less than Avogadro number. It's of the order of 10 to the power 20. Do you understand what 10 raised to the power 20 means? It is 1 followed by how many zeros? 1 followed by 20 zeros. Have you seen that number before? Such a big number, right? Right? So it's such a huge number, okay, it's such a huge number, and that many molecules are present, in empty space next to you. What does it tell you? It means that even though we cannot perceive things directly, there are so many things, okay, there are so many things around us, alright. So this tells you an application of chemistry in space, okay, right? Now, what number I told you, right next to you, or what is the number I told you? 10 raised to the power 20. Now imagine, this number becoming as less as 10 raised to the power 3. Okay, that is what happens in space. What you call as space, okay, outer space, right? The number of molecules or atoms which is close to 10 to the power 20 right next to you becomes extremely slow and extremely small. Okay, so that number becomes 10 to the power 3. That is what we call as, empty space, right? And this is what happens in this place called as interstellar medium, okay, right? And that's what happens in space. So and hence this picture. Why is it black? Because there is almost, I shouldn't give you the answer, right? Yeah, that's a homework, okay. There is almost nothing here, okay, right? So when there is almost nothing here, right, you see that this is what is called as the interstellar medium, which is the empty space between stars. Now in the interest of time, I will skip the next few slides, okay. So therefore, you have all the chemicals which are present, for example, and like I said, right, you compare with what is present on Earth from what is there, so you know like how these molecules are detected in space. See, for example, he was talking about water, right? I know water exists in a water bottle next to me, but how do you know water exists in outer space? An experiment similar to what was done for the sun, okay, right? I collect light and then I measure the extent of interaction of light with mass or something, and I know it, okay, right? So chemistry is also extremely relevant to space. What are these, by the way? This picture here, what are all this? So many dish TVs, DTH connection, what is it? Sorry ma'am? Robots? Are they robots? Yeah. Excellent. Antenna for what? Thank you ma'am. These are antennas to collect signals from outer space, okay. And this is called as the ALMA Observatory, okay. This is from Chile, okay, in South America. So you have all these collections, they collect all the light, and then from this you can do further analysis. You can do further analysis to actually determine what is present in space. Okay, so there's a lot of chemistry also in space. Now, why should we care about, molecules in space? I'll give you the answer for everything else, okay? You see this beautiful baby, right? What is this baby made of? Molecules, okay? You may think that, okay, a very, very random way of thinking about a baby is a bunch of chemicals. Tell this to the parents, the parents will come and hit you, okay? But it is what it is, okay, right? A baby is not just baby, okay, I'm also a bunch of chemicals, right? But how does it work out? Well, a bunch of chemicals which are like many molecules coming together, like for example, water bound with some molecule called as amino acid, protein, carbohydrate, right? What we eat is what we become, right? Yeah. So it's a bunch of all of that. And where do all these molecules come from? They all come from the smaller molecules which are present in space. So by studying, whatever is present in space, you can try to understand how life originated. Okay, right? Just understand this message. So this is the message that chemistry gives you. The point is, these molecules give you a hint about the origin of life itself. So these are some molecules, don't worry about the details. And hey, the moment you talk about chemistry, right? Chemistry is connected immediately with biology, right? So small molecules, how they assemble to form larger molecules. That is what is studied in what is called as astrobiology. Don't worry about this slide also. And this is the idea, how small molecules assemble to form larger molecules, and they eventually become what is called as life itself. Now, there is of course a lot to be done about the origin of life, etc., etc. I am going to talk about one last thing. Okay, I'm going to tell you. I'll leave you very soon, but after asking two questions. Okay, then the question is, mathematics is also exceptionally relevant to space science. There are many applications, direct applications. But before any of that, right? How many of you have heard this thing called as infinity? What is infinity? It's okay. Yeah. Is infinity a number? If it is not a number, what is it then? Okay, if we cannot count, then why do we include it? If we cannot count, then is it a number or not? Infinity is a concept. Okay, I want you to have that understanding. Infinity is not a number. That is why cannot do infinity times 0 is equal to infinity. Infinity plus 1 equals infinity, because infinity is not even a number. Alright, please understand this. Infinity is a concept. Okay, this will be very useful to you. Okay, now let me ask you another question. I'll pick a few students. Okay, what's your name? Vasigan. Sit down. What is the sit down? Yeah. What is the number after 1? 2. Are you sure? What is the next number after 1?
3.
After 1, what is the next number?
0.
In the Paco, 1. You said 2, right? After 1, what is the next number? 1 point? What's your name? Yeah? Yeah? Evangeline, thank you. You say 1.1. I'm going to say no to that also. How many zeros will you add? Excellent. Okay, yeah. What's your name? Huh? Netra. So can you please give Netra something? Yeah. So the point to note is, wait. When you say infinity, okay, do you know how many to add? You don't know, right? So I want to tell you that between any two numbers, carefully pay attention to me, between any two numbers, how many numbers are there? Infinitely many numbers. Please get this concept very clear. Okay, this forms the basis of what is calculus. Okay, the whole subject of calculus is built upon this idea, which you learn about in your 11th or 12th. Okay, right? So between any two numbers, how many numbers are there? Infinite. Can we even know how many? We don't know. And that's why it is called as uncountably infinite. Are we clear? Okay, because if you say 2, right? They said 1.1. Hey, don't worry, okay, all is well. Okay, yeah. So the thing is 1.1 is also all is well. Awesome, okay, right? So you can say, like 1.000. I'll ask you how many zeros. We can keep counting, okay? You can keep counting, until the end of life. Okay. Never be able to get a definitive answer. Right? So this is the concept of infinity. This concept of infinity is exceptionally relevant to space. Okay, in fact, now that I'm talking about infinity, between 1 and 1.1, there are infinite numbers. Between 1 and 1.01, there are infinite numbers. Between 1 and 1.001, there are infinite numbers. Between 1 and 1.0001, there are infinite numbers. between 1 and 1.00001. There are infinite numbers, and I'm not stupid enough to continue. Okay, right? Are we clear? So the point to note is, we don't even know how many numbers exist between any two given numbers. Please note it. Okay, and this forms the basis of the whole idea of calculus. Now this is what is called as uncountable infinity. Now if I were to ask you, tell me what is the next integer, okay, or the next integer after like 2, we'll say 3, right? After 3 what comes 4? After 4 comes 5, 6, 7, 8, etc., etc. This goes on and on and on, right? This goes on and on. And in principle, let's say what comes after like 10 to the power 21, it will be 10 to the power 21 plus 1. So when I talk about integers, they are also infinitely, but you can in principle count them, okay, right? So the number of integers can be in principle counted. So that concept is called as countable infinity. But between any two numbers, you don't even know how many numbers are there, and that is called as uncountable infinity. Please get to know this, okay, right? And this is why, if you're an 11th standard or 12th standard student, this is what gives rise to the limits. This is what gives rise to the idea of what are called as continuity. You talk about calculus, you talk about differentiation, etc. So now this concept of infinity is also very important to model the universe. For example, how vast is the universe? Okay, right? For that, the idea of infinity is important. To understand the density of a black hole, it attracts. To what extent does it attract? To all of those things, right? Your concept of your concept of infinity is extremely important. So math is exceptionally important, but I just took the idea of infinity to highlight something. Okay, right? So with that, what are the take-home messages from this talk? Well, if you answer, you'll be getting a dairy milk. Okay, that's the first thing. All right, yeah, or at least a keychain. So I could not, go through all of these details because the audience is a bit younger than what I anticipated. Okay, so I skipped a lot of details. However, the point is, there are so many aspects of science, okay, fundamental science, combining physics, chemistry, biology, and mathematics, which is extremely relevant to space science. All right. So if you master even one of them, okay, right, you can easily work on a specific aspect of space science. And I also want to introduce you to the fact that science itself, right, is genuinely curiosity driven. So will you have a lot of questions? Yes, you should. And will you be able to answer all of these questions? Of course, no. Don't worry about the answers, but think about answering questions from the standpoint that you know. For example, when I asked you about, the connection between the sun and earth, you were talking about water, you were talking about heat, right? These are all great answers. Similarly, when I asked about what is the next number between 1 and 1, right? You think about it, 2, great start. Then 1.1, great start. It goes on and on and on, and eventually you help the person who gave the right answer, right? The person did not get the right answer to begin with, okay? But it's through a sequence of, progressing from one step to another, making mistakes in between, that you eventually got to the right answer. Are we clear? Okay. So every effort matters. I want to say this clearly. Okay. So on that note, I thank, Mr. Shivanshu was very particularly, helpful in inviting me. I've had the privilege of, knowing him as I've taught him as a student at ISRO also. Thank you so much, Shivansh. Yeah, pleasure, and thanks to the organizers, and also to all of you, you must be very hungry, right? Yeah, I'm sorry, I took a bit longer, and best wishes with everything else, okay? Thank you.
Thank you, sir, for the wonderful session. Now it's time to felicitate the esteemed speaker of the session, Dr. Raghunath, Associate Professor, IISER, Tirupati. I would like to call upon Principal Sir, Dr. N. Venkatacharapati, sir, and Shivanshu Tripathi, sir, to felicitate the chief guest. Yes, sir. I also invite Dean Dr. M. Saravanan, sir, to join us, to join the felicitation. Thank you, sir, for the session. Now, vote of thanks. It's my honor and privilege to extend a heartfelt vote of thanks to Dr. Raghunath to talk. Your talk was not intellectually stimulating but also incredibly inspiring. Your deep knowledge, real-world examples and forward-looking perspective have opened our eyes to the possibilities that lie ahead at the intersection of AI and space sciences. On behalf of ISRO, Sitams and NARL and the participants here today, I extend my sincere gratitude for taking the time to share your expertise with us. Thank you. End of session. Now break for lunch session.
Three different ways. First, we need to collect the data itself. Any kind of or any algorithm software that you see in the world, let's think of it this way. I think you would have heard, maybe I think Mukesh Ambani told a few years ago, where it's like data is the new gold. Now, anything you want to do, any inference, any understanding, any data is your source, and anyone who generates their own data. Is this thing working? How about now? Yeah. Essentially, the data are owners of the whole segment. Is it better now? Yeah. Yeah. So there is no data on this truly in the world today. Observation data, even if it exists, it's controlled by the respective countries and their national governments. I mean, why are governments involved here? It's very simple, right? Like, let's take the example of India. In India, government of India would like to know what is happening in every nook and corner of the country, because it is the government's responsibility to do what they have to do with the sovereign space. Now, in space, there is no such geographical limitations. So every country will collect their own data and regenerate them or reuse them, work on them as they see fit. So data is one of the verticals, or the primary vertical where we work at, where we are trying to generate observational data that doesn't exist. Next is this orbital engine, which we call, which is essentially converting all this raw observational data into usable scientific or engineering numbers. Like, let's put it this way, if I'm imaging something, all I have is an image. Now, what can I get out of that image? Practically nothing. I need to convert that image into some form of data that I can use to infer something. So that is where our orbital engine comes in, where we do, in case of imaging sensors, it is image processing, and in some other ways, and this image process data then being converted to orbital mechanics or orbital elements. Again, when we say orbital elements, I don't think all the school kid children will know that. It's essentially a conic section. Like, you're aware of a cone, right? You cut cone in any direction, you'll get a conic section, and that is one shape of an orbit. That's how orbits are shaped. Now, let's say I'm a satellite operator. I really don't care about this data or the orbital elements. What I want to know is, if I own a satellite,
I want to know what is happening to my satellite, what can happen to my satellite, what I should do if I have to do an orbital maneuver, if there is an object coming to hit me, I have to escape it. That is an actionable insight for an operator. So we work in the third vertical where we convert this data into actions for the customer. Yeah, so far we have built a few payloads. We have our patented LiDAR, optical, space weather payloads. Yeah, I don't know if you understand the word space weather, but there is weather in space too. It need not be just like the air atmosphere that you see here, but there is a space weather that's almost very different from the atmospheric weather that you are used to here. It's not rains, clouds or wind. That is a different kind of weather pattern here. Yeah, so we've done 3 successful space missions so far. We had our first mission Roby back in 2022. It was on ISRO's PSLV POEM mission. The second one we did was mission Pushan Alpha. This was using SpaceX Falcon 9. It's a space weather payload. Both of those were space weather payloads. And the third one is our mission Scott, which flew on Falcon 9 this year, January. This carried an optical telescope for imaging of resident space objects. Yeah, this is an image of our satellite that we launched this year. It carried 2 telescopes. It's placed in a sun synchronous orbit. I'll not go into the details and bore you guys, but yeah, all this is available on the internet. You can look it up. Now this is the optical system we intend to fly going ahead. So these optical systems are really complicated tech. Right now in India, it's only being done by ISRO and some defense agencies for defense applications. Practically no one else does it. But there are umpteen applications using these payloads. And this is our first in-house developed system right now. We do something called as diffraction limited design, where we push the optics to its best possible performance while being in that dimensions, let's say. Yeah, I don't know if you all have heard of the term LiDAR. It's pretty famous. It just flies around. I don't know how many people really understand what that means or what is that tech. It's pretty simple. Let's say you have a laser, and what I do is I shoot laser in a certain direction. It reflects back and comes to me, and I do some inferences based on that forward and backward motion and how it reflected off the target object. So LiDAR for space is a very, very difficult problem. I don't think there are payloads existing that do it in space today, because LiDAR is a very heavy, very power consuming, very expensive thing to do. We intend to become the first LiDAR based space system for tracking and surveillance. This is going to be our first satellite. It will come up in the upcoming couple of years. Yeah, in addition to these satellites, we operate a network of ground-based telescopes. Again, it is kind of similar principle to what we've done in satellites, where we observe night sky and try to capture images of the night sky and then infer satellite positions from that. Yeah, we currently operate 5 operational sensors. This is our software suite, but yeah, that's a very quick overview of what we do. Yeah. Do you guys have any questions, or do you want to go over something else in the slides?
What do you mean by both? Means the same technology you get licensed here as well as in US, or?
Yeah, so when we do patenting, patenting is also country specific. where you're developing, or if you want your interests protected in other country also, because government of India doesn't have any control in United States, and neither does United States have any control in India. So we have 3 global offices. We operate in US, India, and in Singapore.
For example, you might have heard about ISRO's one object in Bangalore. They are also trying to put a space-based LiDAR system. So you have any connection with them, or you are independent? You are independent.
We are independent.
You are independent. So any missions in our Indian missions, anything you got approved, or anybody approached you to?
So we are a private entity. We don't need approval to do things, but at the end we'll need an authorization.
For example, I am a scientist in ISRO, so we may be interested because we have some applications, science-based applications. I know here also is working in LiDAR here, ground-based LiDAR. So we are thinking of putting in space-based. So many challenges are there. So if we approach to you, so then you will be able to help us.
Yeah, we can work with you.
We can work with you. Like that, anybody else from India?
Not right now.
Not right now. Okay, because I am hearing, so I am able to understand you are there. So I can approach you. Like that I am asking.
Yeah. Not right now. We've yet to demonstrate the tech itself. So we are still developing it. It will still take a few more years.
Yes. Good, sir. Thank you, sir.
My question is about space traffic again. So now you have shown that almost 10,000 satellites are already there in the orbit. So what is the policy in the coming 5 or 10 years? Almost half of them will be after their operational period and will be useless. So what are the policies they have taken to clear the?
Good question. So there is one committee called International IADC, Debris Mitigation Committee it's called. They have set some guidelines where they say that once your operational is done, you don't intend to use the satellite anymore, you have to move it down into such an orbit where you will deorbit within 5 years. So the debris mitigation guideline is that you have to deorbit from space within 5 years of end of life of your mission. So that's the mitigation guideline, but again, like anything with space, there is no real control or no authority. There is no police to check these things. It's a guideline. If you are a responsible person, you will use it.
You talk about the orbital engine and data collection and all. So have you started it or it's planned?
No, we already have it.
You already have. So have you designed some kind of model for that?
Yes. So we already do these things. Just a second. Yeah.
And this one.
So the first one is only generating the raw data. We already are operating ground-based telescopes and we have one satellite in orbit. So we are getting data now. But that data itself, to be able to convert, let's say, into orbital elements, like that's one part of the whole thing. So that involves this orbital engine, and now we call it orbital engine because the output or the product of that vertical is orbital information. It will take raw data in. It can be from RF systems or it can be from optical systems, and converts it into orbital information.
Like any kind of information like in public space, whatever, maybe you research, publish some papers or patents on that AI enabled orbital engine.
Our patents and our papers are there. We publish in a conference called AMOS, which is a US based conference for SSA. Then we have patents also public, but it's pretty, like, to put it at the high level, the things we do there are image processing, then we do orbital determination, then initial orbit determination, then orbit determination, then orbit propagation. And once we do that, we'll have something called as TLE, which you might have heard of.
Okay, so if I understand it correctly, what you are trying to say is we have a repository of data where we know where each object is in the space, and what you're saying is some of that is missing, that we are not, for various reasons, able to track or obtain data for. And I think that is where you use your orbital engine to predict and fill those gaps, right?
Not necessarily. That's where the first vertical, generating the data itself. Now, whatever current numbers I told you, it's based on some open source data. Whatever US government felt is decent enough to release to international community at large. Now, they can have 100 things.
Yeah.
They'll only tell you 30 things, 20 things. They are not bound to give you anything actually.
Yeah.
So it's something like that. So to have your own data gives you a lot of power.
Okay. So when you say you are solving for data inadequacy, you are filling certain gaps, right?
Yeah, yeah.
So what exactly are those gaps?
So when we say gap exactly, right? It also I'm trying to think of a simple way of putting this. Like I pointed out, there's a US catalog. It's called a catalog.
Yeah.
You would have heard of the term space track or Celeste track or some of those. That's publicly available information, US based.
Yeah.
So how do you know what is adequate or what is inadequate in that? You are fully dependent on what they're publishing as results using their sensors.
Right.
Now let's say India's case itself. How does the Indian government know what to do with the sovereign space above it? Like tomorrow, let's say there's a military establishment somewhere here, nearby Chittoor or Tirupati somewhere, and they want to carry out some sensitive tasks. And then there's a Chinese Earth observation satellite that's overpassing, or a US Earth observation satellite. Forget Chinese also. Now US is fully at freedom to remove the TLE information of that Earth observation satellite.
Right.
So you can't really know if there is some satellite of theirs that's flying over you and observing whatever you are doing on ground.
Okay.
So that is power. If you know independent of what the other guy is doing, then you can plan for any kind of contingencies or events.
Okay. So you just take your own you data collected from your own sources to get that information. Okay. And you use an AI model for that.
We do have a data science team. So this AML enabled you see here, right? So that enabling is more on the data processing side at the end. But our ultimate goal and the research problem that our AML team is working on is the true freedom is to have independence of astrodynamics or orbital mechanics. Currently everything is dependent on equations, models, so on and so forth. Everything is analytical or numerical. But imagine if AML inferences can fully replace this. They'll take the raw data in and give you outputs directly.
Yes.
They are not limited by your algorithms limitations,
Okay.
input limitations, output limitations. So on.
Okay. So you are using AML to make it more efficient to do the that is done by traditional methods.
Currently it's done for efficiency, but going forward, hopefully in the future, they'll replace the algorithm themselves.
Okay. Thank you.
What you are getting something, you should put your question, something. Even though you feel, you ask what are the questions. Sometimes you ask a very nice question. Okay, up to level of understanding, you free, don't afraid. You ask me.
You might ask your parents sometimes. Anything silly questions also. We will convert it.
It's okay, I know Telugu. I can, Telugu వచ్చు, మీరు తెలుగులో అడగచ్చు.
Anyone? We will have a gift. We will ask question. Raise your hand. That side. No one? No one wants a gift? Okay.
So if there are no further questions, so let us thank Dr. Varshit Reddy. Immense thanks to you, sir. Please, sir.
Thank you, sir, for your wonderful session. Now it's time to felicitate the esteemed speaker of this session, Mr. Vasant Reddy. I would like to call upon Dr. Rajendra Prasad to felicitate the speaker of the session. And would like to call upon Dr. N. Venkatachalapati, Principal of Sitams, to felicitate with this all. Thank you, sir.
Hello.
Good afternoon, everyone. Now, this section is about panel discussion by technical experts. A very warm welcome to you all. It's my privilege and pleasure to extend heartfelt greetings to everyone joining us today for this engaging panel discussion on space and technology. We are honored to have with us a distinguished lineup of experts. It's my privilege to introduce one of our panel experts, Dr. TVC Sharma, sir. Dr. TV Chandrasekhar Sharma, B.Tech in Electronics and Communication Engineering from Sri Venkateshwara University College of Engineering, Tirupati, M.Tech in Communication Engineering from Indian Institute of Technology, Mumbai, and the PhD in Informatics from Kyoto University, Japan. From 1991 to 1994, he was a scientific officer with the Society for Applied Microwave Electronics Engineering and Research, Mumbai, working on development of MST radar subsystems. Since 1994, he has been a scientist with a National Atmospheric Research Laboratory Gandanaki, India. Dr. Sharma is a fellow of IETE, senior member of IEEE, a founding member of Indian Radio Science Society and a member of URSI, Indian Society of Remote Sensing, Society for Small Satellite Systems. His current research interests include the development of atmospheric sensing techniques, lightning physics and remote sensing using GNSS reflectory. I would like to call the sir on dais.
Hello.
Now I would like to invite Mr. Vashit Reddy onto the dais. Now I would like to call Dr. Arun TV to the dais. Now I request Dr. Raghunath sir come on to the dais. It's my privilege to welcome Mr. Shivan Tirupati, a scientist and engineering at NARL who will guide us expertly as moderator today. Together they present a diverse spectrum from theory of practice, innovation and application spanning academia, engineering and national research. Please join me in welcoming the panel to open our discussion. Thank you.
Please welcome Dr. Raghu and Dr. Arun TV. Hello, hello. It's okay. Hello. I hope I'm audible to you. Yeah. Okay, welcome everyone. This is the last session for this National Space Day celebrations that Sri Harikota and NARL jointly conducted at Sitams College. And the topic of this panel discussion is the present and the future of AI/ML in space science and technology. And I think we have actually an overkill, or you can say overqualified panelist with us who have decades of experience, and especially Sharma sir, who has been working on radar systems before even when I was born. So you can see the amount of experiences there on this panel. So the first question comes, why this title, why AI/ML, right? So this is not just a buzzword. This is like the future. What computers used to be in around 1980s and 1990s is the same era going on for AI/ML. So this is the future, the AI/ML is just not the hoax. It is going on, the application science and technology. So first of all, I would like to talk about what is the present scenario of AI/ML, and I would want each of the panelists to please enlighten us one by one on how this AI/ML techniques are being useful in your current work, especially related to anything to space science or technology. So I have a question for Mr. Vashit Reddy, that you have such experience working with hardware and sensor systems of satellites. What is your opinion about implementing AI/ML in large satellite constellations, especially to manage sensors and improve data quality? And even to in the future maybe or in the present, are you using it to detect and correct issues on their own? And how is it going, or what are you doing currently to make it completely autonomous? Please.
Do you want me to answer that question first, or?
Yeah, please. I will start with you.
Actually, I think you should come to AI in space later. Because AI in space is very different from AI on ground.
Yeah.
And I don't think anyone here understands AI on.
Yeah, please.
But so AI on ground is. You'll hear all terms like 100 billion parameters, compute power, how much compute do you have, where are super clusters. You'll hear terms like this for on-ground applications.
No, I think it's open, that's why feedback is coming. Yeah, switch off. Yeah, it's working, please.
Yeah. So you started with a very, I'd say, opposing viewpoint, but AI in space is very different from AI on ground, especially on hardware side.
Okay.
In space, you don't have the luxury of unlimited power, unlimited space, mass. You're constrained for every single resource you can imagine.
Yeah.
So the AI implementation on space is low compute, low power usage, but how do you get the best ROI out of it?
Okay.
And I know a bunch of companies that are doing this also. The AI implementation in space on their end. So I think the current state at which small satellites especially are in, it's like they're trying to carry at least one GPU to space.
Okay.
One GPU consumes enough power to, let's say, operate one optical payload of mine for 2-3 days.
Okay.
That's the amount of power consumption these GPUs do.
Yeah.
And so they are not on outset compatible for space application directly, but there's humongous potential and everyone is working on it. I know folks in ISRO who are doing this, there's folks in NASA who are working on it. The whole or the direction in which AI for space is going is to automate as much as possible.
Yeah.
Especially once your, let's say, your satellite or your asset goes to space. It's an operations heavy task. You need operators on site, engineers on command 24/7. Like ISRO literally has 2 centers focused on space operations and nothing else. We have ISTRAC and MCF.
Yeah.
That itself is like a huge domain in space.
Okay.
Now imagine you're able to automate majority of it.
Yeah.
AI is going to help us in that.
Okay.
And it's not going to happen today. It's going to take some time.
Yeah.
Especially because, like I pointed out, the resource constraint on space is very difficult.
Okay.
So, yeah, that's where we are at right now.
Yeah.
But there was one satellite of NASA, if I'm not wrong, which was a tech demonstration satellite they flew, where they tried to automate the whole mission planning of it. It autonomously chose or what it needs to do, what it wants to do, and where it needs to do at what time.
Okay.
And I think one of the biggest points of interest, especially in Earth observation satellites, is they don't want a task for imaging anymore. They want AI to decide when to image and how to image. They want that to be done optimally.
Yeah.
Because you're aware how these imaging commands, there's a lot of analytics that go in where you pick and choose where to image. But AI is picking right there. The satellite has to autonomously decide when to image. You'll only give it your regions of interest, nothing else.
Okay.
And even it has to decide what is good image, what is bad image by itself. It need not come down to Earth.
Yeah, so I have a follow-up, actually a very interesting one I always wanted to know. Like, what are the advantages of having on-board computing when especially on satellites, rather than sending the data to a ground station and doing it the same thing? Like, is there a upper hand in that, and do we really need that at the moment?
Okay. You can please use this mic. Yeah.
Mics hate me.
Please, can you change the mic?
Hello.
You turn off that mic, please.
Hello. Yeah, sorry about the mic troubles. No, it's huge, right? Ground stations are very expensive.
Yeah.
And downlink passes are even more expensive.
Yeah.
No one downlinks everything.
Okay.
And you can't command everything. The one time you get a chance to, you uplink all the commands you can, time tag them, and you hope that it will run as is. It's not, so as much compute as possible is going to space. That's not,
yes,
in fact, there are companies that are working on data centers in space.
Okay.
Not,
yeah.
The end goal is nothing has to come to ground.
Okay.
Events, capturing, processing, everything has to happen on space and be done there. Because at the end of the day, we really don't care about the images, do we? I'm not getting them down for visual purpose.
Yeah.
I want to see what has happened in that region.
Yeah, what is
if the inference itself can come to the ground, why do I need the image?
Exactly.
That's as simple as it.
So, but you said like sending one GPU itself is a big deal at the moment. And as you know, the cost of sending anything to space, it's much higher than having anything on the ground station. So what do you say about that when it comes to cost?
No, man, not when it comes to AI. OpenAI raised $100 billion just to build data centers. I don't think space industry as a whole spent $100 billion in the last decade.
That says a lot, like what the priorities are and where the money is actually. Okay, thank you so much for the insight. Now, Sir Sharma sir, I have a question for you. So you have decades of experience in this radar system, signal processing, instruments like GNSS, reflectometry. What is your opinion about implementing AI/ML techniques in this area, especially like detecting lightning? You have actually had someone work under you about this, and improving the radar data or extracting useful weather informations. Like, to what level do you think these AI/ML techniques are like fruitful over the traditional techniques that you have encountered over the years?
Yeah, before I answer your question, I'm just looking at the students. You see, how many of them, what do they want to hear? We are talking all this sophisticated stuff. And then, how many of you are engineering college students? This college or any engineering college? How many? How many of you are engineering college students?
Okay.
Okay, good. So, are you interested in what is going on here? Or you are, no? Yeah, I saw a lot when this event is going on, people are going out, coming in, settling down, some students are going on and out. So, settle down and just listen what all, school students, I hope you will get something. So, maybe you can enjoy these, the exhibition there and these rocket figures and all at the models. And maybe later on you will understand what it is happening. It's exciting to see something moving and all that. Static may not be much interesting. But coming to Shivansh's question, what is the application of AI/ML in radar signal processing and also in detecting atmospheric phenomena which are transient like lightning and all that. But as earlier Varshit said, you need a monumental amount of data to find patterns in it and let the machines find it. So even today I don't think, even the atmospheric sensors generate a lot of data. Ground-based sensors also generate a lot of data. So we still don't have so much data. We have some data on which we can try to find, we can automate some of the product generation, especially like wind, and then focus towards finding the extreme weather event or extreme something like which is very short duration like gust, that kind of thing which is immediately useful for rocket launching. So there it has some application, though we haven't tried. We need a high resolution, high time resolution data. But from the available data also, from historical data sets, it is a possibility. Then transient events, we still don't have enough data on transient events, especially this lightning kind of events. Only location finding location finding networks are there. They only do the lightning count. So, but in them, some maybe prediction is possible by incorporating data on the other parameters like the cloud cover, intensity of the thunderstorm, and then aerosol load. Then how, again there are some weather radar data like what is the reflectivity. So these can may be used to predict the possibility of lightning occurrence over a particular site. Now when we use spaceborne sensors, the cameras which map the Earth, in them if you are trying to look for the weather phenomena, that is also a possibility because a lot of data has been generated, spaceborne Earth observation sensors. We have our own, and then a lot of data is also available in the public domain. So there is good scope for machine learning algorithms, but one has to try out and see. We still have to do some trial and wet our hands. Yeah. Any of your students, are you learning these tools, artificial intelligence and machine learning tools? Either they are being taught in the college or you are doing by yourself by taking some online courses? Yes, no, don't know. I give you third option also. Okay, maybe please proceed.
Yeah, that means we are actually successful in choosing the title. We're introducing something that they are not aware of. So I consider myself successful in that. So thank you so much, sir, for your answer. So now the next question for Dr. Raghu. So in your current work of like chemistry and molecular simulations, you are obviously using so many artificial intelligence methods and technology. Like, can you, in simple terms to this audience, explain exactly what your work is, what you do in astrochemistry, and how is your AI/ML techniques actually elevating your research?
So I work in what is called as astrochemistry, like I rightly pointed out. Just earlier in the morning, we had a session about like how fundamental sciences are relevant to space sciences. The moment like people talk about the science of space, it's predominantly physics that comes to everyone's mind, which is pretty natural and it's well established that over a huge, let's say, over a few decades, or in fact centuries, the sky has been ruled by physics. You have had, phenomena starting from first observational astronomy, then you have the development of astrophysics, then you have the more modern ideas of black holes, and now eventually culminating in the combination of trying to understand how quantum mechanics and gravity combine together. So this has been the flow. But over the past 100 years, there has been a recent development, and that has been the detection of molecules in space. So it all started with, for example, I say approximately in, if I'm correct, around 1930s or 1940s, based on radio astronomy, which was, by the way, which was a technique developed out of accident. People during the Second World War, they wanted to know how noise interference can be eliminated from the USA to the transatlantic. There was a disturbance. How could that be eliminated? That eventually, resulted in the discovery of radio waves and the cosmic microwave backbone, at least for the college students. I'm sure for the school students, just enjoy your day off school. Yeah. So for the college students, this is probably how the cosmic microwave backbone was discovered, and it eventually won the Nobel Prize in 1970. But what that led to was, it led to this concept of light-matter interaction, via which, we could detect molecules in space. So the whole idea is, it's amazing. It's awesome to think, right, that imagine a star which is like far away from us, a constellation, say something like Leonis or whatever you can think of. From there are some same small molecules that is present in your and my body. So the idea itself is fascinating. So once they are detected, what we know is that molecules are there. That is definitive. That is a fact, because we get the signals. We employ radio astronomy. We get the signals, and we know that these molecules do exist. But What is the million-dollar question is, how are these molecules formed over there? Because the physical conditions are completely different. The physical condition that you would expect a priori on Earth, we're talking about 1 atmosphere pressure and room temperature, close to 298 Kelvin or something. But the conditions up in space are very different. In various regions of space, you have like cold molecular clouds, you have diffuse clouds, you have the H2 regions, the highly ionized regions. So temperatures vary from as low as 5 Kelvin to approximately 3000 Kelvin. So how do molecules exist in these conditions? How do they react? Well, of course, it's a matter of hypothesis. It's a matter of tremendous hypothesis. But hey, one that would lead us to new knowledge on a bigger picture, on the grand scheme of things, how life itself could have evolved. This is a grand question, sometimes occasionally meaningless also, but at least, we get a lot of information about what new chemistry and physics we can learn on Earth from this. So this is the science part of it. How does artificial intelligence and machine learning come in there? Well, they play a huge role. Like both Mr. Reddy and Dr. Sharma, like they beautifully pointed out, eventually, it all comes down to data. What do we get from space? Ultimately, what we get from space is a bunch of signals, right? And the signals are speaking in terms of physics, you get the intensity of the signal, you get it at some specific wavelength or frequency or wave number. That is what you get. Now, using this, how do you actually convert it into knowledge? How do you convert it into knowledge that a human being understands? For example, this specific signal corresponds to this specific molecule which is vibrating with the specific mode. So how do you do that? For this, we need to manage a lot of data. And obviously, the moment, the huge volume of data comes in, machine learning algorithms are extremely useful. But I would like to put a caveat right away. Machine learning algorithms, in many ways, are like mathematical induction. Perhaps the 9th and maybe 11th standard students can also say that. Given n, it is very useful in finding n plus 1. However, you cannot expect a paradigm shift with it. That happens, but that happens due to what is called as AI fallacy. That is like if in case, the algorithm fails, then you can get some spectacular new results which could also be meaningful eventually. You don't know that. But by and large, let's say you want to understand the pattern. You don't want any disruptive new knowledge, but when you want to study existing knowledge, when you want to extend existing knowledge, in that particular case, your ML algorithms are particularly powerful. But if you want a paradigm shifting new knowledge, then I think that's where traditional human intuition and the expertise gained are always going to be very powerful. And I would also add one more fact here. I mean, especially the college students here, for how long has this buzzword, the artificial intelligence, machine learning, data science, the mathematics behind all of these techniques is very old. It's all, linear algebra, calculus, statistics, yeah, you name it, right? Linear algebra, calculus, statistics, and that's about subset. In fact, maybe some, what do I say, probability also, probability and statistics, that's about it. Yeah. There's nothing more. The mathematics and the theory is very, very old. But why is it coming in as a buzzword only now? This is something we need to think about. The answers are actually, already being kind of put in. It is the ability to store data. What we couldn't do, like 10 or 15 years ago, was to store data. The relevance of data centers is massive. And it is not an algorithmic development. It is an experimental development. It is the fact that, that you could store data in some place. That was absolutely impossible even 10 years ago. So with these data centers come huge power requirement. So with these data centers, they were talking about data centers in space, right? Forget that, having a data center, do you know how much it costs to, have you ever seen your server room in this college, if you're a college student? Do you know what it costs to, just maintain your server room? A lot of data is stored over there, right? Do you know what is the cost? So when we think that machine learning is cheap, right? We talk about machine learning as being cheap and nice. That is at the rudimentary level. The moment you actually look at the costs involved in managing the data, it may no longer be cheap, It may perhaps be useful to even hire human beings and use their expertise. In fact, we don't know. So that calculation has to be done very carefully. So the relevance of data centers is something very, very important, and what it costs to manage this data. These are not just data science for space applications or any fancy new science, but even for routine applications. Whenever people talk about, let's say, compute power or like a billion or trillion parameter model, where do you store all that data? And what is the cost of it? What is the cost in terms of climate change? Is data science a culprit for climate change? This is something we should also ponder, When we say that we discuss about the benefits of AI and ML, the pitfalls also have to be considered. It's not, it comes with its own set of problems and the cons, and one has to seriously look into whether a traditional physics or fundamental science-based model, intuitive, of course it's limited in terms of handling huge data because the human mind doesn't have as many neurons, but what is the cost? That is something which has to be carefully looked into for general applications of artificial intelligence beyond just using it as an exploratory tool. Yeah, thank you.
Thank you so much, Dr. Raghu. And in fact, we'll be talking about the pitfalls very soon. Actually, I would like to add to this statement, as you said, the creation of this data center. Like what I have read and what I have experienced is this, that anything that can be commercialized is easily developed better. Even computers, when they were being able to being commercialized, is when the technology grew like exponentially. I think the same goes with AI/ML. AI/ML was there for a very long time, but as soon as that we can like tap into that commercial market, right, image generation and people using prompt for daily activities, is when this took off, because then is when people started putting in the capital, when they can see the immediate the results in their life. They don't care about you discovering a molecule in space or not. They don't care about the earth image, they don't care about us using radar systems, they don't care. They care more about day-to-day life, and I think the capital lies there. And I think if we can correlate science, or we can push science much more into people's daily life, is when we can actually expect the technology to grow more, right? So this is, So now my next question is to Dr. Arun TV. So you have extraordinary knowledge and experience in using deep learning models like CNNs and using it for like Earth observation, Earth imagery. Such big words are there. Can you? And I've seen your capability of explaining such difficult topics in such simple terms. Can you explain to them what is deep learning and what is actually CNN?
Just before that, I'll just ask, like sir, I just asked the students, how many of you, earlier we used to do our assignments by reading book, right? So how many of you use Google to do your assignment? Any of you? How many? Can you raise your hand?
So they are advanced now, sir.
And they are advanced. So you use ChatGPT?
Yes, sir. Now,
yeah.
So, being humble, sir.
So see, that is how now technology is changing. So the moment I'll give an assignment in my classroom, so now I have to think twice, and I have to explore ChatGPT many times, or Grok, or for that reason, that whether it will give you a direct solution, And the thing is that even ChatGPT generated assignments also, it's very difficult to detect that. Last time I have seen somewhere a post like which says like you write a sentence, it will check whether it is machine generated or human generated, and there is also a tab there, humanize it. Yes. So basically someone has written his own word and he checked it, so it is saying it is AI generated, and now that means a human written text is detected by an AI as AI generated, and now AI is saying that whether I have to humanize it. So that means that's a level of AI influence that we have. Yeah. So yeah, to start with, actually it's despite of deep learning or all these things, so basically I think in my morning session some of you will be there, then that time we discussed how you can detect an apple from other fruits. So usually when I say, you have apple in front of you, how you will detect that it is, in childhood. So you will be given like apple, beta, this is apple, another apple, this is apple, another apple, this is apple. So again, you will get an orange, you will say that this is also apple. Then someone will correct you. So how you are perceiving it is an apple is based on its features. So that means its color, its texture, all these things. So a machine also sees everything in terms of features. It won't see an image as image. It will only see the pixel values. So for that, pixel values are the features. It see an apple in terms of all those attributes, so it sees apple as a, not an apple, but it as a set of features. So that means features can be the color, the texture, the size, other things. So who decides these features? So if I, for an apple, if I am giving only color as a feature, so and I am training it to distinguish between apple and orange, sometimes if another fruit with the same color comes, it will get confused. So if I'll give more relevant features, the machine will learn better. So we are detecting or we are actually instructing the machine how to learn or what features to use. So that is where, you know, the traditional or conventional algorithms, machine learning algorithms were. So now what people are saying is that why you are deciding which feature to learn or which feature to use. Let the machine decide. Based on what? It will decide based on the training data. Like for example, if you give 1,000 apples and 1,000 oranges, now it will decide what feature can better distinguish that apple from orange. But that may not be a human interpretable feature. That means for us, we will use color, texture, size as the feature. But sometimes it will be using color plus texture into, size. So that combination. And sometimes it will be learning something else. So that's where always, during our discussion also, I took this analogy. So if you are having an AI model or a machine learning model, you are training it to detect cats and dogs. And you are training it all with white cats and black dogs. And the moment you will give a black cat, it will detect as a dog. Because it is taking color as a feature. But color is not a feature in distinguishing cats and dogs. So can't we, so that is where we should have a control of what feature it is learning. So this is, so when traditional machine learning algorithms, they used to map features to a label or to a prediction. Now we are just giving the input, it is learning features and then mapping those features into, something understandable. So this is deep learning. Deep learning basically means we are also learning features. For a general understanding, I'll tell you with a very simple example. So this is a classroom. How you are deciding that this is a classroom or this is a place where some session is going on. You can see chairs, you can see people on the chairs, you can see some people with mics. So, there is a hierarchical level of understanding that we need to see. So if you see a theater, cinema theater, you can easily distinguish that from this classroom based on some context. So that is where there is a hierarchical level of understanding. For example, if you see an image, it is just a collection of pixels. But some of these pixels will, form some letters. Now some of these letters, when they join together, they will form a word space. Then they form a word day. So you understand, okay, it is not NATIONAL, it is national. So that, hierarchy of joining things, the bits and pieces into some information. So the same thing we are trying to mimic while learning the features. So what the deep learning or advanced machine learning algorithms will do is they will try to understand the features or try to combine the features in a way that they form a hierarchy of understanding. So that is where deep learning basically works. And that said, sometimes when I am here, right, so who am I? So if you want to say who am I, you should have some contextual information. Like, what is the, how can you say that I am a human? Am I a monkey? So you will say that, no, he is sitting with all human beings, so he is a human. This is the contextual information, right? So you are understanding the context and you are deciding who is this guy. He is not a monkey wearing shirt and pant, he is a human being, right? So that level of understanding is also context. So that context from an image, if suppose I am classifying a pixel in an image, so if I am not taking that context into consideration, so I can just, I may classify this black pixel as a rod. But when I understand the context, I will understand that it is not a rod, it is, some background in a poster. So that is, where convolutional neural network will comes into play. Basically, they will try to understand the context. So based on that context, they will generate some features. So for example, if I am developing a system to detect faces, human face from a cat face. So you know that, okay, there is a difference between how eyes and noses are placed in a, will be there in a human face, and that will be different from a cat face. So this is what a convolutional network will tell you. So there is eye here, there is eye here, there is an eyebrow here, there is a nose, there is mouth. For cat also it is there, but it is in a different form. So that is where convolutional network try to understand that context or those features like in a hierarchical manner, and then so that we can distinguish which is cat and which is human. So this is a very intuitive explanation of how basically CNNs works.
Okay. Thank you so much. It's very nicely explained. So everybody is clapping, but at the end of the day, I'll catch one of you and I'll want you to explain what just sir said. Okay. So you should be able to explain what is deep learning. Okay. So be prepared. Google or ChatGPT, whatever you want. So yeah, so now coming to the next round of discussions, as Dr. Raghu clearly mentioned, the pitfalls, like whenever you are using new technology, it's not all rainbows and sunshine. There are pitfalls to be aware of. You can't just overuse anything or any algorithm just however you want, and you can't just use everything as a black box just because it is giving some positive results. It may have some errors within. So I would want Dr. Raghu to please tell us about it, please explain what are the common pitfalls in the simplest way the simplest way possible, as well as please
you want more AI bashing from me.
Yeah.
Okay. See, if you think about it, I think Dr. Arun already pointed out tremendous pitfalls.
Yes, sir.
You train a model.
So the mic is.
Oops, yeah, and you show it a black dog. Who's going to call it a black cat, right? So the obvious pitfall is, I'll talk about it both ways. The pitfalls can be algorithmic, as well as the hardware related. Like the real physical world. The algorithmic, as you pointed out, everything depends on how well you train. For example, there are school students out here. You want to score 100 marks in an exam. What should you do? What should you do?
Anyone?
Yeah.
Stand up and reply.
You want to score 100 marks, but the denominator is 100 also in the exam.
Yeah.
Okay. So how would you score it?
How do you score full marks in exam?
Yeah.
Can you please answer? Anyone?
Where do you start? How do you score 100 marks in an exam?
We have lucrative gifts also to distribute.
Yeah. Even for this answer.
Yeah.
You don't want 100 marks? You're too young then, yeah. How do you score?
Anyone? Don't hesitate, please stand.
You're also part of the panel.
Yeah. We're not just discussing among ourselves, please.
Adav, yeah.
Hard work.
Hard work,
Please,
right?
hard work.
Excellent, yeah.
Yeah.
Hard work and training go. Thank you so much. Okay, yeah. Similarly, in artificial intelligence also, right? Somebody has to do the hard work. There is no free lunch. Okay, right? So the model has to be trained well. When we say the model has to be trained well, the pitfalls are obviously that you're training a model, in terms of some parameters which humans do not understand well.
Yeah.
So for simple applications, say for example, if let's say, when I say simple applications, I'm talking with respect to state of the art as of today. Now, you talk about image resolution or identifying an image or face recognition. Some of these things are reasonably straightforward given the intuition, based on today's technology. Yeah. So therefore, you can identify it. But let's say, you want, the problem given is hard. You want to identify, say for example, you want to identify if it is possible to crossbreed a cat and a dog, right? And how would you train an AI to do that? It's a random example that I gave, okay, right? So how is it possible? Or forget that, if you want to give a more appropriate example, you consider the agricultural sciences. In the agricultural sciences, let's say that you want to come up with a new crop variety, right? You want to genetically modify some specific species. How do you identify, which gene to be modified? How do you identify, can you train a model to do that? To give it. Okay, closer to my mouth, yeah. So that the ultimately the toxicity is not reduced, but the taste is retained, and yet it is also beneficial. How do you do that? For that, of course, you can come up with various models, but ultimately, that works is the empirical one. You don't know, because the simple fact that the human cannot come up with any intuition to predict that this specific feature is what works, right? Makes the whole business some sort of a black box model only. So this is one huge algorithmic limitation. I can keep going on. I stop with the algorithmic limitation. The hardware limitations I've already touched upon, because it's exceptionally, for any meaningful application, it's exceptionally resource intensive. Do you all actually know the cost of every single ChatGPT search? The actual cost of ChatGPT search? For you it's free, right? You think, okay, my parent has got me a smartphone and inbuilt, in some, as an extension, Chrome extension or whatever, right? I get the AI search. Now, do you know the actual cost of it?
Any guesses?
Yeah, just some guess. Now, give some number.
Any guess, like at all? Just stand up and say a number, that's it.
How much?
Yeah.
The cost of each ChatGPT search.
Each time you write a prompt in ChatGPT, right? Like
what is the actual cost?
Yeah.
Not just to your parents, okay, but the whole of humanity.
Yeah. Hey, yeah, please stand up.
You make a guess. By the way, I don't know the exact number, okay, so even if you say, I cannot verify it, I'll be clear about that, okay. It is, my anticipation is that it is huge. He can perhaps answer it, right? Yeah. What's the actual cost?
I also don't.
So one has to, yeah, please. 10 rupees. Yeah, I would be very happy if it is actually 10 rupees. Okay, thank you so much. So, the point I'm trying to make is that to develop this, you need to build what are called foundational models. All these LLMs that we're talking about, Meta, this OpenAI, and all those people, right?
Yeah.
Even the Chinese one, what's it called? The DeepSeek, right? Or
DeepSeek.
Yeah. DeepSeek claim to 5 billion, but they completely ignore all.
Yeah.
So it is extremely expensive.
Yeah.
We are ignoring the expense, and the safe way. I mean, my interpretation is that while these AI tools are exceptionally friendly, they are going to change the world. A lot of administrative positions are handled. They are going to change the way you access information, but information is different from knowledge. In my opinion, we are still far away from the age where you can use AI and artificial intelligence to gain knowledge. That still requires a trained scientist. A human being, I'm sorry. Not the only thing about science, That still requires, a well-trained human being. So you need a well-trained human being to actually make sense of what AI says. Especially because the features are not interpretable by humans. I'll just stop with one example. How many of you are here aware of deepfake videos? Deepfake?
Those videos will be there on Reels and such.
Deepfake, have you heard?
Yeah.
So you understand that what danger it is, right?
Yeah, you can't figure out it is separate, how separate it is from real life.
For example, just to give an instance, let's say, I'm speaking right now. Somebody can create a video saying that, take the exact opposite thing, that AI is awesome. AI has no pitfalls. ML is the next thing to happen, right? The exact opposite thing of what I'm saying can be done without any effort. Okay.
Yeah.
So there are obvious pitfalls at the socio-economic levels.
Yeah.
Your minds can be tuned to especially as young children, right? See, when I was a kid, my parents used to tell me, don't go near a TV, you will get spoiled. Okay. Now when I'm a parent, right? Yeah, when I'm a parent, the generation is such that let the kid only watch TV, at least don't give him another mobile phone. Let the kid watch a TV from a distance so that there is at least some distance, okay. So maybe, when you guys, when you folk grow older, probably they will say, okay, please use AI, only for some things in life, not for everything.
Yeah.
It's a socio-economic cost.
Yeah.
So algorithmic, hardware cost, like I already said, and the socio-economic costs have to be very carefully balanced out. And no space application though, yeah.
Okay, thank you so much, Dr. Raghu. Yeah, actually I don't know how much time I have, but I want to touch upon one of the topics with Dr. Arun. That is about explainable AI. And that will cover the pitfalls, and he will also explain the dangers of using AI as black box, and why is explainable AI is the need of for the space technology and elsewhere.
Okay, so with the pitfalls, I'll tell you a personal experience. So after a PhD, I was offered a postdoctoral position somewhere, and the topic was identifying the micro expressions. So that means if you will give your video, so from that micro expressions, they want to identify and they want to use it for some purpose. And I got myself afraid. Okay, if I develop such a model and my micro expression, they are trying to record it without my permission, it will be a problem, right? Yeah. So that is where the privacy of, your privacy sets in, privacy problem. I can take any of your videos, I can understand what is in your mind with your micro expression. That is not good, right? If your mind is being read by someone who don't know you, then it's not good. So, data privacy is a big problem, and many of you will be nowadays using these GIF images, right? So you are giving your photographs to them free of cost. So you are sharing so that if a person want to, just create such an app and they want to make fake videos of yours, you are sharing your photographs with them. So that means there are a lot of pitfalls in, in sharing your data, in data privacy, particularly in medical field and all. When we develop these models, who is going to access these data and what all things they are going to do about it. Like if a person understands that you are having this disease, of course he can approach you with insurance schemes. He can make you more panic, so that next day itself you will go and take insurance. So you can get easily manipulated by by the people who are having your data. So that is out of our control. So please be careful in sharing your data, and that is because the advancements of AI, people can easily use an AI tool to mine your information, get all the information about you, like where are you, when are you going for lunch, when are you going for breakfast, at what vehicle you are going. All these set of information can easily be mined out of you. So that is one thing related to data privacy, or one pitfall that already sir has covered almost. So one pitfall that I wanted to cover. So that's affecting all of us. And there are some ethical issues. Ethical issues means like I told you, like sir also suggested, like if you train with a black cat and white dogs. So same way, there are some sections when we use the data, there is some bias inherent in the data. That means, usually, from from beginning, so we have some biases in mind. That means for certain jobs, maybe male candidates will be preferred. For certain jobs, female candidates will be preferred. So this is a bias. This is actually nothing to do with the skills. But there is an inherent bias in the society that, make them, those people preferred. So that's a problem. Right? So same data we are using for training AI models. So AI will also have bias. This thing actually happened because they wanted to, in US they wanted to frame the criminals. So what happened is like, all the black, more probability was for the blacks, then they have to withdraw that entire, this. So that bias comes in. Even it is biased against, females for certain, resume shortlisting. Nowadays companies use this AI models for resume shortlisting. So those all things are problems. So how we will understand that there is a bias in the model? So that is where we want the model to be explained. That is, like, I want the model, like with our earlier example, I want to know which feature the model is giving more importance to. So if I have two models, one model which is distinguishing cats and dogs, there is another model also which is distinguishing cats and dogs, and the one model is giving importance to color, other model is not at all giving importance to color, then I will prefer the second model, which is not at all giving importance to color. So that means I need to understand, which feature my model is giving importance to. This is very important, and that is where explainability comes into play. That means, we discussed earlier also. So the underlying process is very important. Like when sir is doing or sir is working in their domains, they are having a lot of domain expertise. But the AI don't have any expertise. It just works with the data. So, you need to understand what feature it is learning or what underlying process it is modeling. Get it verified by an expert. Then only we should deploy them. That is where, the explainability comes into play, so that we can tell sir, okay sir, this is the feature that my model is learning. So whether that feature is relevant or not, that's where, yeah. Thank you.
Thank you so much, Dr. Arun. Now, looking at the movement of the students, I see that we are coming dangerously close to the valedictory function, and hence we will have to. 4 o'clock. Yeah. Okay. So, so before I end this session, students coming here. So I can continue. Okay. Okay. Sure. Thank you. Okay. So yeah. So coming to you, Sir Sharma sir, please. Coming to you, sir. As I actually mentioned in the last question as well, and I like to come to you again. Like you talked about the unavailability of data being one of the problematic points, especially when it comes to these transient events that you mentioned about. What other problems do you see in the future or even in the present other than hardware, especially when it comes to data collection and it comes to atmospheric sciences, either through radar system, LiDAR systems or space-based systems? What are the difficulties that you think are?
The most important problem in advancement of atmospheric science is lack of data.
Lack of data.
We need data all over the globe at all the heights and at as fine a time resolution as possible.
Yeah.
Now that is something which is extremely difficult to generate. So what people do is whatever little data is available, they use that, and then they try to interpolate or make some model out of it and then generate some additional data from the model. So the thing is we need more and more observational systems. Spaceborne observational systems have this advantage of global coverage, but their resolutions are coarse. They are of course getting better and better, but their revisit times are not as much as you would desire. But that is also being addressed by constellations and then follow-on missions. There are satellite constellations which, there are multiple of them which track the same path. And when we have more and more of these satellite-based or spaceborne sensors, all of them are remote sensing sensors. So whenever we have this new remote sensing sensors, they need to be calibrated with the ground truth, and for that we need extremely accurate and highly precise ground truth sensors at different locations. So that is the real problem about advancement of ultimately what we need in atmospheric science, what the society needs is a prediction. How early you can predict. If you can give 1 month in advance, there are commercial uses for it. As far as something like lightning is concerned, if you can give 1 day in advance, it has tremendous use. You can relocate. But right now we are not able to do that. We are very close, maybe less than an hour only we are able to do, even though there are claims that 3 hours in advance we are able to do. Even if we are able to do that accurately, it has tremendous value in saving lives and livestock. In our own country we have lot of fatalities by that. So one is data, another is maybe these new tools, ML can help us predict better. So provided we have enough data. So these are the two big issues going forward.
Okay. Thank you, sir. Thank you for your input. Now, please coming to Mr. Varshit. Yeah, sure. Please.
Yeah, we have modeler, Harish Verma.
It's open. Yeah.
Thank you. It was relevant to my work, so I just got intrigued. So, to add to what Sharma sir has said, today we have models which can, deliver the simulations at very high resolution, like large eddy simulations, which we can simulate the weather at meter scale resolution. But what we shortfall is that the initial conditions, we don't have the initial conditions at that resolution.
Okay.
So when your initial condition itself is not there, the simulations will not be able to, simulate the actual weather. Because there is error in the initial stage itself. So these and you know that this whole atmospheric flows are turbulent in nature. Turbulent means they are chaotic. Even a slight change in initial condition can develop into a huge, it can deviate from the
because of the butterfly effect.
Yeah, it's like just like the butterfly effect. So so where we face the issue when we are simulating the weather is basically most of the problems lies in the initial condition. So all the mesoscale models we take from global model data, which global model data is a very coarse resolution, and most of the model error we get is we attribute it to the initial condition. So there is a lack of data there.
Okay.
Yeah, that's what I want to add. Thank you.
Thank you so much for your input. Thank you. Thank you. So, yes. So coming to, like very nicely said, Harish Bhaiya, thank you for your input. Now coming to Mr. Varshit, you are working, as I said in the previous question also, you are working on these constellations, and you will be, you want to, as Sharma sir also said, that using constellations is the way to reduce this coarseness of the data, to increase the frequency of the passing. So you obviously have a vision, right, of collecting data of different and using these constellations. What exactly is the future, the future that you're not working on right now, but you see right now that is possible? And maybe once you are able to put all your satellites and form a constellation, and then maybe you can implement that, especially when it comes to AI/ML.
Very difficult question. So the thing is, right, you don't ever know what is that paradigm shift that comes and from which direction it comes.
Yeah.
And when it comes, it hits you like a train in the face. Either you catch up or you get left behind.
Yeah.
Like even with AI/ML today, there was nothing of this sort 5 years ago. Forget 3 years ago. The entry of ChatGPT. In fact, there are some few freshers have been we've hired a few over the last few months. I can't give them one task without them opening any AI model. First job they do, if I give them any task, is they'll open ChatGPT or Gemini or Grok or one of those tools, and they'll directly. I don't mind it. Doesn't matter, because in our job or work environment, at the end, results matter. How you do it is up to your prerogative, and but the bigger issue there is that you're transitioning to this post-truth kind of world where you really don't know what is real anymore. We've been already fast-tracking on the way towards that for a long time, but now AI is just accelerating that post-truthness. So I think earlier, sir, you mentioned you need to get experts to make sure these things right. I don't know who are the experts at that point. Genuinely, there's no truth anymore, right? Truth is whatever you're able to fabricate. Politics has already reached there. Every country's politics has already reached there. There's no more truth. Because that's where the first social impact always shows up first in politics and then rest of the society. Same like that. So when you say what is that future thing that we want to work on, or to be honest, I don't know if we'll be there by then. But if you ask me, collection of data is such a huge problem. It will never be solved.
Okay.
Like, let's say now Starlink, SpaceX is Starlink, the internet, LEO-based internet constellation. They have like 6,000 or 8,000 satellites. That's after replacing one phase. They've done a few thousands, decommissioned them, they are moving on to next phase of satellites. They have another phase of satellites. We had recent interaction with SpaceX on these things. And their constellation is not done. They have 8,000 satellites. They form 60 or 70% of all objects in space today. And still their constellation is not done. They have a claimed target of 25,000.
Okay.
Now, Jeff Bezos, Amazon has started launching their Kuiper constellation, another 27,000. China is doing their light sails or some constellation, again LEO-based broadband. ISRO is launching a LEM-3 satellite for one company called AST Space Mobile. They are launching hundreds of space-based internet satellites.
Okay.
So you really don't know. And constellation, right? Constellation designs or how you're solving what you're solving is your best decision on given data and your inference and understanding of it. You might be a very poor in the brain person, like not very intelligent person, you'll do poor inferences of it and do poor decisions. Again, who's to tell? If you have the power, you made the decision, there's no one to question you anymore. Same like that. Either our AI models will get so good that our inferences are useless anymore. We entirely start being dependent on their inferences, because this is a huge pitfall for students actually, where don't outsource your thinking to AI. The day you do that, you're not a human being anymore. If I believe that. I mean, the only thing that makes us human is our thinking capability. If we don't do that anymore, we are just an eating, breathing, shitting machine, nothing else. That's all we'll do. So, exactly. So I might be digressing, but these things change too fast, man. It's genuinely, the last decade, it feels way too crazy. Everyone thought the 90s and 2000s were crazy when TVs came in and they got phased out within 20 years. Like advent of mobile phone phased it out. I don't know what's going to happen. Like the Moore's law is really showing the exponential effect. I don't know if human beings can comprehend all this anymore.
And very nicely put together. Please give him a round of applause. And I think when it comes to education, as you said, because of these ChatGPT and AI models, and even Dr. Arun pointed out that he has to modify his assignment so that they can't be copied out of ChatGPT. I think it is a disadvantage for them in a way, because now the education level have to step up itself above ChatGPT, and that is a whole new level. If we are planning to make them more intelligent than AI, then I think for them it's a very difficult future to live in. A large amount of information they have to go through, a large amount of studies they have to go through. So so I think that is the future. Just like when calculators came, there's this handwritten maths phased out, but that meant that this level of mathematics itself increased for everyone. So I think this is the future for them as well. This will just step up the whole academics for everyone here, so that we are more intelligent than AI at the end of the day. And I think we are at the end of this session now. We have talked about the present and the future.
Sorry, just to add to one thing.
Sure.
Someone has beautifully told, till now whatever we build were all tools. Search engine is a tool. If you think of AI as a tool, you're using it the wrong way. Think of it as a teammate, it will be of humongous help. Use it as a teammate, not as a tool, because it has some thinking capability of its own. Hopefully students can learn to do that. Because if it's a teammate, that means you're not fully dependent on the team.
Exactly.
Don't be that student in the group who passes based on some other guy's work. Have your own contribution. So use AI as a teammate.
Please, Gaurav.
Especially that ChatGPTs and large language models, you can use basically in 3 ways. First, you can automate them according to your task. You can collaborate with them, and you can assign some task, and you can be with them and just guide them. So they will do everything what you want. Okay, but I would like to touch upon that transformation of AI and what will be the future. So I'll just give you one example of the how the computers evolved from a football size stadium in our hand, on our wrist. So what I see in that field of AI and all, it's all about the hardware. If you are capable to achieve that kind of hardware with the tiny size, so in maybe next 10 or 20 years, it will be going to, from that size of data center, the power requirement, it's going to be reduced. If you see in that way, like if you just parallelly just make an example with the computers, it was CPU, now it's going to be GPU. So that's the only difference I see. But AI can do the task from a reading the numbers, reading the alphabets, and the thinking, just matching the thinking process of a human being. So it will be a completely different technology. It will not be a tool anymore. So it's up to us how we evolve or how we will be with AI, or whether you want to adopt it or you want to live with it. So that's it.
Thank you so much. Thanks for beautiful insight. Okay, now before I close this session, I want each of our panelists to please give some like motivation to these students, maybe a insight in few lines, a guidance, maybe a few lines that will help in them in the future, especially this future which will be riddled with AI and ML. Please, sir, Sharma sir, Acha, please, Arun sir, please, can you please start?
Yeah, I think, for that I may have to again check with ChatGPT. What's that what I say? So basically, now everything, every walk of life you see, you use all these AI models. Many of them suggested you have to be careful of what is the purpose, and basically now, you will be competing with AI for a job, because many of your traditional jobs will be fading away. Some of I think you were discussing, like, many of these outsourcing jobs are now going because they are just replacing it with LLM, automating that bots and other things, right? So we need to see how we can be better than AI, and how we can use them to be better. So basically, it is about intuitive ideas, or our ideas are what make us distinct from all these. As a human being, you have power of imagination, you have creativity, and those makes you very different from these models. I don't know, after some time they will also become creative. Right now also they are, but still now that is one area where we can focus, and we use it as a complement, like already our panelists suggested. So use them as a companion and guide them in a proper way. Like I'll just close it with just an example, like of my PhD student. So she was coming to me and she was saying, like, this paper. So I found that just randomly I took one reference journal in that paper. I searched in Google, it was invalid, because she generated that text using ChatGPT, and ChatGPT generated one, journal on its own, so means the DOI, everything is there, but everything is fake. So now, then she told, next she was saying, like, next time when I'll search, I'll ask ChatGPT to not generate fake, but to give real. Then she did that, then ChatGPT replied, I am more or less a generative model. If you want actual data, you better search in Google Scholar or related things, right? So that is where you need to understand what ChatGPT can do, what you can do, what extent you can rely on that. So this is important. Thank you.
Thank you so much for it. So Dr. Raghu, please can you give these young minds some advice regarding curiosity, regarding academics, and whatever you feel is fit?
never lose your sense of intuition. Like Dr. Arun said rightly, what makes us human is our intuition. The ability to, the ability to think for ourselves and not just be dependent on some model. For example, already see, in a sense, right, one may also be thinking that AI is nothing new. Peer pressure has been playing the role of AI for a long time in our lives. If we think about it, right, how do we decide? Well, whatever my friend does, right? How do we decide what to do next? Well, okay, this fellow is going to this coaching center, I'll go there. Oh, this lady is going to this place. So, in some sense, AI is nothing new, if you think about it that way. We've always been guided, in many senses, been guided by features beyond our thought. Try to minimize that. So, it's just that, now you have AI as a companion for all the wrong reasons also. Okay. So, don't lose the individuality and the intuition. I think these are the two aspects which are going to make you unique and useful. For example, already, in fact, in so many ways, it's in my personal opinion, it's actually a blessing to be a student now than to be in the workforce. Because people in the workforce are getting laid. Because, they don't need, because they don't know what has hit them. But you know what has hit them, not you. Right? So you can be better prepared and intuition and develop skills. When I say skills, right? Say, for example, when you start coding, let's say you are in a course, which talks about most of you are you do coding, right? You're engineering students. Yeah, you should be doing some coding. So don't use ChatGPT prompts. At least, get to understand the syntax. Say, you have to generate some, some key pair function. Don't simply use ChatGPT, okay, ChatGPT, please give me the syntax. You please write the syntax yourself, right? You understand and don't lose the ability to debug. That is something extraordinarily important. See, for example, every time the biggest problem and danger with AI models is the features, what goes inside are not human interpretable. That is the biggest danger. You don't know why it works. You know why you failed. For example, you may be angry, you may be sad, you may be upset. That's why you failed. But you don't know what's happened with that model. You can't imagine, like so beautifully pointed out, to decide whether something is an orange or an apple, it may think about a combination of, some color plus texture multiplied by taste or something like that, right? We can never think about these things. It's way beyond this. So, do not lose your individuality, intuition, develop skills, and make sure that you use AI as your companion and as a subordinate, not as a boss. When you say companion, right, you boss over it. You don't let it boss you. So I think you're actually very lucky to be students at the cusp of this revolution and not in the workforce. Because let's say those who graduated 3 or 4 years ago, it's nasty. Okay, right? Yeah. For you, you know that it's nasty. For them, they didn't know that. Okay. So it's a much better situation, IMO. That's all. Do well. Thank you.
Thank you, sir. Please, Mr. Reddy.
Yeah. There's this one phrase that's called democratizing access. One good thing and bad thing about what internet brought to this world is democratizing access. Internet democratized access to information. You can go look up or, I'd say Google did it primarily with the search engine, but at the end of the day, it's internet. You can go look up a certain information, just ask Google about some topic, it'll throw 100 different sources and you can go start learning or studying about it. AI has not just democratized thinking or democratized inferences, it has, I'll put it this way, you don't actually need teachers anymore if you ask me. If it's just basic knowledge, they perfected AI for it already. You don't need for knowledge anything. So as human beings, your job is to do it. Use AI to do it. It's going to make your life way, way, way faster, quicker and easier. And you don't need to be in a fancy college somewhere or a fancy professor, big city. You can sit in a village nearby. All you need is some mobile phone, laptop, internet. People used to say about this, about internet, a lot of the same things. But that was truly not the case. There you still had to know how to infer things or what you need to. Today you can go to AI and say that I want to build a satellite. Well, how should I do?
it will give you a step-by-step end-to-end process. You don't need someone like me or sir here or anyone who's done it before. You can just do it yourself. In fact, there's this company in Hyderabad that's selling small satellites for a few lakh rupees. You can buy, assemble it yourself, they'll help you test it, go launch it, done. That's where the democratization is going. It will keep going. Make use of this opportunity, don't fall behind. The big risk of especially young people is they're never told that they can do whatever they want to do. Especially in India, it's a bigger problem where everything has to be passed by adults and all. You can do whatever you want to do. You don't need someone's permission, or you don't need to be told by someone what to do. You have a brain, whatever you can come up with, use the internet, use AI, just do it. Whatever you want to do, do it. I don't think there's ever been a better time in history of humanity or earth itself to do what you want to do. And the access or entry barriers are way low. Genuinely, stop depending on adults. They really don't know what they're doing either. So might as well do it yourself and figure out. Yeah, that's my 2 cents.
Thank you so much for your input.
Okay. So, very good. I'm going to give you some old-fashioned advice. Now that you have heard all the latest stuff. All of you are engineering students? All? Good. So, what I would like to suggest is study your subject and understand the concept. The way the human mind works, I've been observing myself. I have only myself to observe. So what I found is the mind has a tremendous capacity of connecting things. And the more over decades, what all I have read, observed, practiced, done myself, all these things get connected, and then there is a building pathway. So please don't avoid your subjects and don't read guidebooks and lecture notes. You have prescribed textbooks. Access the textbooks and read only the textbooks. They are written by the topmost authors who have 30, 40, 50 years of experience in teaching in classroom and trying to understand what is understood by the students. It is written in that way. So nowadays I see not one student is studying the textbooks. So teacher's responsibility is greatly to stop using the guidebooks and giving notes. Because you want to show good results, don't do it. Please ask them to read the textbooks. Engineering students must read textbooks. Second thing is, build yourself, build your body and mind, because the competition is cutthroat, and what all you want to do, as Varshit said, you should have, these are the 2 things you have, these are your tools, your body and mind. So build them with whatever tools you are suitable for you. Thank you.
Thank you so much, sir. With this, I think this panel has put it very beautifully. I think I can't add anything to it. And from this, I will just want to end this session with this one line. From the wisdom of Aryabhatta to the ambition of Gaganyaan, the future of Indian space science is one of the infinite possibilities. And the AI will be a powerful part of the journey. Thank you so much. Now we'll take a leave, and you please stay here, and after this it will be followed by a valedictory session. Thank you everyone. Please one round of applause for the whole panel, please. It's I'll say.
Hello, hello. Hello, hello. Hello, hello. Hello, hello. Hello, hello. Hello, hello. 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 Hello, hello. Hello.
Good evening, ladies and gentlemen. A warm and cordial welcome to all present here for this momentous valedictory session of National Space Day 2025, jointly organized by ISRO, NARL and Sitams. As we gather to mark the successful conclusion of our event, it's time to honor and celebrate the journey and contributions of everyone involved. We now begin by inviting our dignitaries to kindly come up onto the dais. First, P. Sunil, Chief Guest. Sir, Chief Guest, sir. Call up onto the dais, sir. Next, Guest of Honor, Dr. T.V.C. Sharma, Scientist, Engineer, G. NARL, to add on the dais. Thank you, sir. Next, Dr. N. Venkatasalapati, Principal, Sitams, to adorn the dais. Dr. P.K. Ramkumar, Scientist, NARL, to adorn the dais. Dr. M. Saravanan sir, Dean Academics, to adorn the dais. Dr. S. Vijay Kumar, Program Coordinator, to adorn the dais. To officially open this session and extend a warm welcome to the gathering, I now invite Dr. S. Vijay Kumar sir to deliver the welcome address. Sir, please.
Good evening, one and all assembled here. On this nice evening, I am happy to pronounce this welcome address on the occasion of valedictory function of 2 days National Space Day workshop titled as Aryabhata to Gaganyaan, Ancient Wisdom to Infinite Possibilities. First of all, it's my privilege and happy moment to welcome our beloved distinguished chief guest, who is none other than Dr. Sri P. Sunil, outstanding scientist, SDSC, SHAR. Welcome you, sir. And next, I take privilege to welcome guest of honor, Dr. T.V.C. Sharma, scientist engineer, NARL. They have busy schedule, but to grace this occasion, he also accepted to be a part of this 2 days workshop program. Welcome you, sir. And next, my heartfelt welcome goes to our
subcommittee chair, TK Ramkumar, who is behind the scene. He is motivating all of us, and he is guiding, always keeping in touch. Even night time also we are discussing how to do this in a wonderful way. So long discussion went and smoothly arranged. Everything is done fine with his support. I welcome you. Next, it's my, they are all my part of team, Sitams. I welcome our Dr. N. Venkatachalapati, our beloved principal, who is supporting us from our. Welcome you, sir. Next, I welcome our Dean Academics, who is supporting in each and every corner without any lack. It is successfully coming to an end. Without his support, it is not possible. I welcome you, sir. And I welcome all the head of the departments, various committee members, volunteers, particularly the students who have visited from various colleges, schools, and my own students, Sitams students. Without this, it is not possible to make it a grand success. I welcome all the school students, college students, and students of Sitams family. And last but not least, I welcome all the supporting staffs who gave wonderful support throughout the two days workshop program. Welcome you all. Thank you for this opportunity.
Thank you, sir, for your warm and thoughtful welcome. Now, it is our privilege to listen a special address by Dr. N. Venkatachalapati, Principal Sitams. Sir.
Today's chief guest, Shri P. Sunil, outstanding scientist, sharp, and guest of honor, Dr. T.V.C. Sharma, scientist, engineer, NARL. Especially, I thank both the team, SHAR and NARL, and Sitams-National Institute of Technology and Management Studies. Really, it is an opportunity to share the important space research activities for the rural background students, parents, and some of the faculty members, intermediate students, degree students. Really the 2 days is a wonderful session which have a lot of information related to space related activities. Really, recently I have been observed that panel discussion, it is a very nice interaction with the great scientists. They have given a lot of things about AI between human. So that discussion it was very nice and really the present generation have to think about your individual thinking. And really this National Space Day celebration we got opportunity to conduct in the Sitams-National Institute of Technology and Management Studies. Really more than 2,000 students has been participated about quiz programs and guest lectures and wheel on roads, the space vehicles, and really I am happy to inform you that Director NARL and the other dignitaries on the dais, off the dais, these type of programs will be conducted at least every semester one college so that it will be more beneficial for the young people and young minds. So really this today's session also very nice, sir. So see TK Ramkumar Garu, scientist NARL, he has given lot of opportunity for nearby Chittoor districts. The first day also the inauguration was organized by the Dr. Sumit Kumar, collector. That collector also given a valuable introduction about what is the importance of your subject concepts and you have to work about your skill set. So really this is very, very important to highlight and in future we have to compete with the AI. So that is a very important and I thank all the dignitaries on the dais, off the dais and my dear students, friends. So thank you for giving the opportunity. Finally, I thank the management, the chairman. He was in USA. Just he made a call to give the congratulations for the NARL and short team and Sitams. They have given a lot of information to the young generation students, and also our honorable managing trustee Dr. D.A. Kalpagan madam has given a lot of support, and our honorable secretary Dr. Sri D.K. Badrinath sir, who has given continuous support for the growth of this institution. I hope I thank the management of NARL and SHAR. We have chosen our Sitams will be the delivering this national space celebration. So thank you very much for giving me the opportunity.
Now I request Mrs. Raghu Madam to introduce the guest of honor, Dr. T.V.C. Sharma, whose presence today adds prestige to our event.
Dr. T.V. Chandrasekhar Sharma pursued B.Tech in Electronics and Communication Engineering from Sri Venkateswara University College of Engineering, Tirupati, M.Tech in Communication Engineering from Indian Institute of Technology, Bombay, Mumbai, and a PhD in Informatics from Kyoto University, Kyoto, Japan. From 1991 to 1994, he was a scientific officer with the Society for Applied Microwave Electronics Engineering and Research, Mumbai, worked on development of MSD radar subsystems. Since 1994, he has been a scientist with the National Atmospheric Research Laboratory, Gardanki, India. Dr. Sharma is a fellow of the IETE, senior member of IEEE, and a founder member of the Indian Radio Science Society and an Acoustical Society of India, and a member of ERSI, Indian Society of Remote Sensing, Society for Small Satellite Systems, and the Acoustical Society of India. His current research interests include the development of atmospheric sensing techniques, lightning physics, and remote sensing using GNSS reflectometry.
Now I request guest of honor, sir, to deliver speech.
Namaskaram, Chief Guest Sunil Garu, Principal Sri Venkatachalapati Garu, and HOD Computer Science and Engineering Vijay Kumar Garu, and faculty and students of Sitams. I am forgetting Dr. Ram Kumar. He is always behind the scenes. Dr. Ram Prasad is hiding in the last row, and we have our young colleagues here who have been working tirelessly to make this event a successful one. So I'm glad to be here, and it's always very exciting to go to educational institutions where we can interact with faculty and students, and especially here we had a panel discussion just now where we have brilliant academicians and a young and dynamic entrepreneur. So I'm supposed to give a special address. I discovered just now after sitting there, so I don't know how special it can be. The National Space Days today, the present theme is actually excellent. It is after my heart. This ancient wisdom to infinite possibilities, Aryabhatta to Gaganyaan. So Aryabhatta is our ancient astronomer, mathematician, and Aryabhatta is also one of our first mission of ISRO. So you see it as two things in one. Nowadays we are very excited with the space and all that, and many of the students are interested. It is very exciting to see something dynamic going into the space, lifting off, going into the orbit, going to other planets. But how many of us are thinking that our ancestors, thousands of years ago, they thought about these things. They calculated the precise position of planets. How can we know? You know, which many people who know nowadays, the skeptics, they say, how do you know that everything you are saying it was there in the Vedic time? Everything it was there, your people did it. But where is the proof? If we are able to do anybody, you know, to make a calendar, we have now a working calendar 5,000 years ago, without knowing the movement of planets and movement of the earth around the sun and its relative position in the cosmos, you cannot make a calendar. You cannot make a consistent calendar. So that is direct proof that we don't need to look far. And then in our Puranas, which I consider them history of this land, there is a concept of flight. There is Vimanam concept. And our people thought, whether actually things are made or not, that proof we are not able to produce now. So we should be proud that our ancestors thought about it. So we need not be diffident that everything is coming only from the West. And there are some people now, actually what I gather from the information, that our historians have been very unkind to us, our own historians. They have purposefully omitted the recorded references that the mathematical theorems which we think came from the Greeks or the West, they were done in this country by our ancients. Our own, you know, forefathers, thousands of years before the world even thought about them. So we have a responsibility to correct our history for our own sake, for our own generations. But then that is not enough. We just can't, you know, be saying we were great and all that. In Telugu we have a very saying that, you know, our ancestors ate well. They, మా తాతలు నేతులు తాగారు మా మూతులు వాసన చూడండి అని. There is a, so we cannot just take solace that our people did great things, so we are great now. We cannot be great unless we continuously evolve, continuously do things that are important. There are a lot of things, very interesting things in this world, but then we need to do what is needed to solve the problems of our nation, to solve the problems of the daily problems of a common man, and space is one of the contributing areas, but that is not the only one. Space is, of course, but being from the space department, I have to talk about space. So what is needed? So what I would like to advise the students is, you work on things that are needed. There is an abundance of ideas, concepts, products in the market, but then what is needed? That is what you have to look, and that is where you can contribute and make a difference in the lives of the common people. And so many times we hear that one has to innovate and all that. So what is innovation? How do you innovate? Innovation is about doing some things which is needed in a way which has not been done before, or which is improving even little on what is already available, because it is not delivering what is needed. And in what way your approach is going to be better and deliver in a better cost aspect, in a more economical way. So there are these some 4 or 5 ways in which one can do innovation to solve the problems needed. So Department of Space, ISRO, is working on trying to solve the problems of the country in providing remote sensing for disaster management support, in providing communication, in providing support and missions for scientific exploration of the Earth as well as deep space. And now there are opportunities for many startups to exploit the commercial opportunities available in the country in the area of space, access to space, building space systems as well as space applications. So this is where we hope that you will be interested and get to know, or take up, think in this line and work towards the application of space for the benefit of the common mind. And in what way? See, this is a 1 or 2 day event. From this, what you are going to get, what we are interested to see is that if you get excited, and among you who are interested in this, you can come and approach us. First step is to apply for internship. You are all either in second year, third year, fourth year. You apply for an internship. Next is you apply for a longer duration, a BTech project. Okay, either you come over to our place. If we are not able to accept you, we may guide you how to do. These are the possibilities. So if you are studying here, NARL is very close, so we have opportunities. Of course, we get how many every year? 500 applications? We get 500 applications, but we are not able to accommodate. We are taking maybe 100 at the most. Okay, so there is competition, not only from Chittoor district, all over the country. First people go for internship students, they look at ISRO. ISRO is well known, so they look at ISRO, they start applying VSSC, URSC, SDSC, everywhere. They apply, last NARL also, they applied NARL, but they hear mostly from NARL. So they come to us because ISRO, the people are so busy that they are not able to offer so many internships. Some students get opportunities in ISRO labs, but NARL gives many opportunities because we are a research oriented and we have data, observational instruments, so that kind of opportunities are available. So please come to NARL and apply. If you are not able, if you are not successful, but still you can talk to us, you can contact me. We can guide you in doing a small project, even during your semester coursework and all that. For school students, we have visits on Fridays, so please utilize. The teachers, please note about the visit program. So they may pick up something. They may not understand what is happening fully. They may pick up something. So that is our hope. So please utilize what all opportunities we have and which we can provide to you. So thank you.
Thank you, sir, for your inspiration speech. Now it's time to introduce our distinguished chief guest for today's valedictory session. P. Sunil, I request Rahul Madam to introduce our chief guest.
Shri P. Sunil Varu, outstanding scientist, is currently working as a Deputy Director, Range Operations, handling the real-time systems, networking, tracking, telecommand systems, as well as various electronic interface systems like the timing, communications, CCTV, photography, etc. He previously worked as Deputy Director, Systems Reliability, and prior to this position, he was the Chief General Manager for SHAR Computer Facility and Mission Analysis, Flight Safety and Meteorology at SDSC SHAR. He has joined ISRO in 1991. He did his BTech in Electronics and Communication Engineering from Bapatla Engineering College, Acharya Nagarjuna University in 1990, and his MTech in Computer Science from the University of Hyderabad in 1997. He completed the summer space program at the International Space University in 2007. He was awarded the Young Scientist Gold Medal by the Systems Society of India in 2008 and the ISRO Team Award for the realization of new Mission Control Center and Mission Real-Time Systems in 2011. He is an expert in software development, especially in real-time software development and software engineering, and is a member of the ISRO Software Control Board. He has developed several software projects and realized the range safety, SDS and MCC real-time systems, as well as antenna control unit and remote monitoring and control systems for satellite ground stations. He has developed display software to monitor the performance of all launch vehicle subsystems, as well as monitoring of the cryogenic stage during filling, as well as flight phases, and is an expert in acquisition, processing, and display of vehicle telemetry and tracking data. He has led the team with which he developed web-based workflow software for computerizing all administrative areas like general administration, accounts, payrolls, purchase at stores at all ISRO centers. He has authored and co-authored about 20 papers which were published in various national and ISRO conferences and seminars.
Now I invite our chief guest to deliver the valedictory address.
So we have gathered here on a very nice evening. So thank you first to Sitams management for hosting this program and also to the NARL team as well as the SDC teams who have jointly organized this program commemorating the historic Chandrayaan landing on Chandrayaan 3 landing on the moon, which was on August 23rd, 2023. So let me also convey my very warm evening to Dr. TVC Sharma, who is the guest of honor, and then Principal Dr. N. Venkatachalapati Garu, and then the coordinator and HOD for CSE, Dr. S. Vijay Kumar, and Dean Academics, as well as Sri Ram Kumar. So, warm good evening to all the students and the technical and non-technical staff and all the speakers, invited talks who have given the invited talks here. So, warm good evening to all of you. It's really a pleasure for me to be in an education institute, as Dr. Sharma also was reminiscing. So it's always a pleasure to be among the young students as well as the college students. It is basically, it also makes us feel young. So that way you are actually making us to come back to our memories, to rewind ourselves, to go back to our academic times, and then also try to spend with all of you, and we also will feel refreshed and will be feeling very young. So I hope you all had a very good 2-day seminar, 2-day interaction program. So basically I would like to have any talk as an interactive talk. So, how was the program? Anyone can just tell? Anyone can tell? How was the program? Or can you tell when is the actual National Space Day celebrated? August 23rd. Okay, fine. So basically on August 23rd, 2023, our historic moon mission Chandrayaan 3 has the lander, that is the Vikram, has landed, and then the rover, which is called the Pragyan, it has grazed or traveled across the surface of the moon, and a lot of scientific data has been collected from that. And many discoveries also has been done. And our nation has become one among the 4 nations to actually land softly. And then also the first nation to be, to land very close to the South Pole, if not to the actual South Pole. So that way it's a very historic achievement, and our Prime Minister also has rightly recognized the importance of the day, and immediately wanted to announce that the National Space Day has to be celebrated. And basically it is to celebrate our achievements, celebrate our indigenous efforts, and then in spite of being denied of a lot of technologies, we could surpass that and then develop indigenously, and we could send our own rockets and our own landers to various planetary bodies as well. So that way it's really a very important day, and such days we have to commemorate and remember, basically to inspire our new generation. And we all know that, you see, we are all becoming old, and we have to handle the baton to the next generation, the next people who are going to take over, and then they have to drive the Indian space program as well forward. So towards this day, this National Space Day is an occasion when we have to inspire a whole lot of new generation. We all know how much they are very much distracted by the technologies, especially the mobile and the internet and all these things. So instead of that, we must try to see that they are encouraged or motivated to take up STEM courses and then carry out space research. You see, basically space is the new frontier. And then space has a lot of applications, as was being mentioned by Dr. Sharma as well. Lot of applications for mankind, and which was the basic vision of our founder as well, the ISRO founder, Dr. Vikram Sarabhai. He was always trying to say how to utilize space for mankind. So that is how it can benefit mankind. So towards that, always the young generation has to take these steps forward and then realize as much as possible the systems for benefit of mankind. So whatever the recent, we had the 100th mission as well, and then now recently the 102nd mission is over, and this is going to give a very good science data for all the world science community. So this is like as if we are donating lot of data. Lot of data is available, like just now Dr. Sharma was telling, at NARL also there is lot of data, and with this NSR we have huge data, and it is being given to the world community, world science community, basically free. Everybody can use it and then discover anything. And basically it is to monitor the climate changes, which we know is a very pressing need in these times, because we see that there are a lot of climate changes happening, and how to study the climate changes and all, even maybe to some extent, I cannot say that it can do something like a precursors for earthquakes or something like that, but at least some kind of land shifts and all also can be monitored. So such kind of mission is a very, very huge mission, and it's almost the most costliest mission ever that ISRO had taken up. And it is a joint collaboration by both NASA as well as ISRO. So our space day this time also we have a good theme that is from the past to the present, and as was also told, this is the 50th anniversary of our Aryabhata launch, which was on April 19th, 1975. So this is a silver jubilee year for, golden jubilee year for our Aryabhata as well. And so next is our Gaganyaan program, which you all will be, I'm sure, very much excited. So when we can definitely send a man to the orbit, and then which by 2040 or so, we are also having plans to land a man on or a person on moon surface. It will be a wonderful job that we would have done. So what I request is, as Dr. Sharma was telling, so all of you have opportunity. You can all, ISRO encourages a lot of internships. So, and also we promote a lot of space research. And one more thing is, we also see that it's not only that the people or the students from the top technological institutes of India like IITs or only they can come and do something in ISRO. It's not so. If we see a lot of people are not from IITs. If you see the percentage is very, very less. And it's only the, what you call the motivation, the inspiration that one needs to have or to work in the area of space that is really required. And our job is also fulfilled if even one person among all of you are inspired to take up studies in space and then join into the ISRO's program or the Indian space program. Otherwise, we see that the trend, a lot of people always just go to computer science or EC, and then they go with the flow, with the tide, and then join some IT companies and all that, and then they do it. It's not that they are not bad, but only thing is we should also continue our space program, and for that we need the young generation to take up those projects and then move forward. And always we should try to do basic science and then the space research. And like earlier there was like 400 or 500 years ago, the sea was the frontier. Of course, as Dr. Sharma was telling, it's not that only Columbus has started that, but at least we can say that the circumnavigation was done first by the West. Our seafarers and all, so many are there, like Chola times and all that, they used to go and then conquer the kingdoms. So the seas are all conquered well before also. But then that sea was the frontier earlier, now space is the frontier, new frontier, which you have to take it up as a challenge and then explore. Exploration is one aspect for the science part. The other aspect is utilizing space for our benefit. So you can harness the solar power or whether remote sensing or whatever. There are so many huge number of applications. It's only once just thought that needs to come, and the idea will germinate into a product. So that way Space is really a challenging thing and also exciting thing. It will give you a lot of opportunities. So I wish that some of you will take up career in space and then take our and see that some of you will be there in our Indian space program in future. Thank you. Thank you for once again for giving me this opportunity.
Thank you for your inspirational speech. Now felicitation. I request Principal Sir, Dr. N. Vintasalpati Sir, Sitams, and Dr. T.K. Ramkumar Sir, Subcommittee Chairman, SNDC, to come forward to felicitate the guests of honor, Dr. T.V.C. Sharma. Sir, I also request the Principal Sir and Dr. T.K. Ramkumar Sir to felicitate the Chief Guest, Sri P. Sunil Sir, outstanding scientist on behalf of Sitams and ISRO. Now over to Raghavi, Madam.
May I now request the college administration to felicitate Dr. T. Ramkumar Garu, scientist, SGNARL. I also request Mr. Harikrishna Garu, GM, SMPC, SHAR, to accept our felicitation. May I now have Dr. Rajan. May I request Mr. Harikrishna Garu, GM, SMPC, SHAR, to come over. I also request Dr. Rajendra Prasad Garu, scientist, SENARL, to please come forward. I now request Dr. T. Harishwar Verma, scientist, SENARL, to please come forward and accept the felicitation. May I now have Mr. C.H. Yashwant Garu, scientist, SENARL. May I now have Mrs. Pavni, scientist, SDNARL, to please come forward and accept our felicitation. May I now have Mr. Gaurav Kumar Garu, scientist, SDNARL, to please come forward. May I have Mr. Abhishek Garu, scientist, SCNARL. I also request Mr. Ashriti, scientist, SCNARL. Ashish? Okay, I'm sorry, Mr. Ashish. Okay, Ashriti. May I now have Mr. Sitams-National Space, the member secretary of the committee, scientist, SCNARL. I also request Mr. Murthy Garu. Thank you all. Thank you. Okay, may I have Mr. Christian Valedictory to please come forward? We now have a small memento from NARL to our principal, sir. Moving forward to the much awaited prize distribution. I request our dignitaries to kindly do the honors for distributing the prizes to our deserving students. We'll start with the quiz participants, the prize winners for quiz contest school. The first prize goes to Mangal Vidyalayam Paitimitam. I request the students along with their faculty to please come forward. The students S. Revant Kalyan, B. Monesh, Devaki Nandan, Chirucharan, Guru Sai Reddy along with their faculty to please come forward. May we also request the faculty to join the students? Faculty from Mangal Vidyalayam. Oh.
Certificate yaad kara.
Please join the The second prize goes to PPS Public School. They have Bhavagna Sai, Yogya, Monica, Vairish, Prakash Reddy. The third prize for the quiz contest goes to Rainbow English Medium High School. May I request Mr. Mokshit Reddy, Tendul Sai, Vaishnavi, Tanushri and Mokshita to please come forward. Along with the faculty, please. College, S. Ramya, R. Kirtika, D. Vinay Kumar, D. Tarun Kumar and P. Trivikram Raju.
Madhushri K.M. Bhavna Shetty. Very happy. Moving to the second event, science fair prize winners are from the school Little Flower English School for Network Jammer, A. Andrew, S. Vinesh Kumar, S. Imran Sharif and P. Mokshit. Apollo Isha Vidya Niketan, that's the second prize. We have G. Dilip Kumar, M. Neha Shri, A. Sneha Shri, G. Aditya Reddy and A. Nagini Shant. The third prize goes to Rainbow English High School, who worked on GeoSat. GB Vedika, GB Bonsai Reddy, B. Bhavya Reddy, S. Sai Kirtana, G. Neha. Moving to the UG category, the first prize goes to Srinivasa Institute of Technology and Management Studies, who worked on firefighting robots. N. Durga Prasad, K. Tejesh, K. Prasad, P. Kaushik, and M. Jayaprakash. The second prize winners are Wemo Institute of Technology, who worked on smart farming. Vegan. B. Ganesh, R. Farooq, T. M. Ram Prasad, E. Soundarya, R. Hemalata from Wemo Institute of Technology.
The third prize goes to PVK Environment College, who worked on forest fire detection. We have P. Purnachandra, K. Ajay, S. Gayatri, B. A. Yuvasri, and M. Vashita. As we approach the end of this wonderful evening, it is time to express our gratitude. I now invite Mr. Shivans Tripathi, sir, scientist, NARL, to propose the formal vote of thanks.
So good evening everyone, my name is Shivans Tripathi and I'm a scientist at NARL, okay, and this is, and I was the member secretary for this committee from NARL. NARL and SDSC SHAR like combinedly they made this thing happen at Sitams with the help of the committee obviously. So first of all I would like to thank ISRO chairman, SHAR director, NARL director, and chief guest Shri P. Sunil, who is the outstanding scientist at SDSC SHAR. Thank you so much, sir. So I've always seen you on television and I've heard your voice, but this is the first time I'm actually meeting you. It's a very great honor. Thank you, sir. So actually this decision to make me the member secretary came as a shock to me by Ram Kumar sir. I have barely spent only 1.5 years at NARL, and to be given such a responsibility, it came as a shock as well as it was an excitement for me to be able to. I also was a member last time also when this National Space Day happened, and last time Mr. Harish was the member secretary, and I learnt a lot. Last time also I did panel discussions and such, and it made me more comfortable talking in front of the crowd and such. And I think that was a very nice opportunity, and now this is like a step up from that. Thank you so much for ISRO, to SHAR, for everyone who is involved, and for Ram Kumar sir for giving me this opportunity. Thank you so much, sir. Now coming to my experience of conducting it, it could have not been done without the commitment and the help of the Sitams College team. It was excellent management from the top. They took everything very seriously. The actions were speedy. Mr. Vijay, I think we had around 200 or 300 calls in the past 1 or 2 weeks. And the thing is, when you are organizing such a big event, there are so many things, there are so many variables that keep changing. And even if a small thing changes, the whole schedule has to change and has to accommodate for it. And it's a very challenging task. And we somehow made it happen, Mr. Vijay and me. We kept in contact. There was excellent communication from his side also. He replied immediately. He took action immediately. And obviously, Principal Sir, he said yes to everything very graciously. Thank you so much, sir. So I would like to now name the Sitams members who has to be named right now. So obviously, Shri K. Ranganatham, the chairman of the Sitams, need to be thanked. Dr. D.A. Kalpaja, the managing trustee. Shri D.K. Badrinayana, the secretary, I think he was with us yesterday, yeah. And Dr. K.L. Nayana, the advisor, and the academic heads obviously. The academic heads who have all been there for all the helps they can give. Dr. N. Venkata Chalpati, I am so sorry sir if I am ruining your name right now, but it's a very difficult thing to do for me. And thank you so much for your support, sir. You were always there for meetings and they always gave a very positive outcome. And Dr. M. Sravanan, the Dean Academics, thank you so much. Yeah, and obviously there were so numerous number of teams and such. I can't name everyone, especially because of my bad pronunciation. So I would like to thank each and everyone here who is there continuously standing here, distributing, giving the introductions, making the last minute changes. It's a very big thing to be able to rely on such support. And I'm very, very honored to be to have worked with you. Yeah, that's what. And now coming to the members of NARL. Now, Dr. T.K. Ramkumar sir, I learned a lot from this conducting this event. For every small change, sometimes I will feel, how is it possible? How will I make this change? But Ramkumar sir yesterday told me, everything is possible. You just need to sit down and think what can be changed where. And then we finally changed the whole schedule just one day before, just to accommodate everything and keep everyone happy. So I learned that from him. So he actually taught me how to keep my head cool and just focus on the solution rather than thinking what would go wrong. Thank you so much, sir. And the next, Mr. Hari Krishna, he has done an extraordinary job. He's been everywhere, running here from there, giving advice about the protocols and everything, and he has been extremely patient with me, I see. And thank you so much for everything, sir. Next, Dr. Rajendra Prasad, sir. So he has been the background runner. Everything, anytime I needed some advice, anything done, he was always there saying yes to whatever I needed. And he actually gave me the correct guidance every time. Thank you so much, sir. Yeah. So now, Dr. T. Harish Verma and Mr. Yashwant, I don't think they are here, but I'm very grateful for them because they had such a long experience and they are such senior scientists. They have helped me with the protocol because I always don't know what to speak because of my inexperience. They have told me what is the order of saying things, what is what, who should stand where and such, and I've learned so much. Thank you so much. Yeah, Miss Pavani, Abhishek Bhaiya and Ashrit Bhaiya, thank you so much. I have given them such responsibilities of conducting competitions and such, and nothing came to me. They have silently done their work in the background and not a single thing came to me. They have conducted the programs, they have coordinated with the Sitams team, they have made everything, all the results, and they just have finally given me the results. Thank you so much for working like that. And Mr. Gaurav Kumar, I think he is also not here. He was the person responsible for many small things, technical and science fair, and he did it flawlessly. Thank you so much. I wish he was here right now. And that's all. Yeah, Mr. Murthy Naik, yeah. Thank you so much. He has been taking care of everything with the mementos and everything. Everybody has played a small part here. I have also played a very small part here, but we have finally made something big happen. And I think it is not perfect, obviously. Some errors will be everywhere, but I think we have done a very good job. Thank you everyone for being here. And I would like to, for the whole audience, all the winners, to have a round of applause for yourselves. Thank you.
Thank you, sir, for your heartfelt acknowledgements. Now, national anthem to end the occasion here. As a mark of respect to our great nation, let us all arise for the national anthem.
support ಇಲ್ಲದ್ರು